Um, MuleSoft architecture. Here you can see a architectural diagram of MuleSoft. MuleSoft LLC is a software company headquartered in San Francisco, California, that provides integration software for connecting applications, data, and devices. Started in 2006, the company's Anypoint platform of integration products is designed to integrate software as a service SaaS on premises software, legacy systems, and other platforms. MuleSoft's Anypoint platform includes various components such as Anypoint Design Center, which allows API developers to design and build APIs, Anypoint Exchange, a library for API providers to share APIs, templates, and assets, and Anypoint Management Center, a centralized web interface to analyze, manage, and monitor APIs and integrations. MuleSoft also offers the Mule Runtime Engine, a runtime solution for connecting enterprise applications on premises and to the cloud, designed to eliminate the need for custom point-to-point integration code. The leader in one of the leaders in cloud API and middleware management is MuleSoft. Mule provides a huge library of ready-to-use connectors. API designs and cloud management tools. Mule is largely Java-based, so does not take a lot of training for most engineers to understand and use perhaps 1 week. Importantly, Mule forces you to delve into system and API design and properly construct not only for target operating model, but also the resources you wish to share or expose through an API. With Mule, we can have complex architectures. For example, I can have some business application deployed in AWS, connecting back to on-premise legacy system for certain calls or information needs. The API accessed by the end user will be in Mule, and we will call and expose the API on the application. The end user is directed to a secure connection via Mule, which handles the request and returns the desired resources to the end user. This middleware decouples the server from the end user with all advantages that decoupling offers. This API layer is essential in cloud universe. Importantly, MuleSoft has an excellent set of aids around API design, build, and management. Here you can see Anypoint. Here the Anypoint API manager interacts with customers or partners or suppliers and cloud platforms and SaaS and social and mobility and devices. Anypoint API manager interacts with API Kit and API Hub. These three interacts with the Anypoint integration platform, Mule Studio, and Enterprise Manager. Here the Anypoint integration platform includes Cloud Hub and Mule ESB. Anypoint integration platform interacts with Mule Studio and Enterprise Manager and Insight. Mule Studio, Anypoint integration platform, and Enterprise Manager interacts with Anypoint Service Registry. Anypoint Service Registry interacts with SAP, Oracle, IBM, custom apps, database, JMS, and file. Here you can see control plane versus runtime plane in hosting options, to understand the different hosting options that Mule supports, you must understand the control plane and runtime plane within the context of any point platform. Control plane, the components of the anypoint platform architecture that you use to design, deploy, and manage APIs and Mule applications. The control plane contains product features and components that are part of the anypoint design center. Anypoint management center and anypoint exchange. Runtime plane, component of the anypoint platform architecture where your APIs and Mule applications are deployed and made available to your users. Runtime plane includes Mule runtime server and supporting services. Here you can see a control plane, anypoint exchange, anypoint design center, and anypoint management center are in control plane. Runtime engine and services are in runtime plane. Here you can see a different MuleSoft and customer responsibilities for anypoint runtime fabric instances. So here you can see the anypoint runtime fabric as a shared responsibility. A successful operation of anypoint runtime fabric is a shared responsibility. It is critical to understand which areas you provide and manage and which areas MuleSoft provides. This following image illustrates different MuleSoft and customer responsibilities for anypoint runtime fabric instances. MuleSoft provides a runtime fabric agents. Mule runtime engine Mule. This is runtime Mule's runtime fabric agent, Mule's runtime engine Mule, and other dependencies used to deploy Mule applications. The runtime fabric agent deploys and manages the Mule applications by generating and updating Kubernetes resources such as deployments, pods, replica sets, and ingress resources. Runtime fabric core services. Anypoint runtime fabric core services. Anypoint runtime fabric and its underlying component run as a Kubernetes deployment object in EKS, AKS, GKE, and Red Hat OpenShift environments. AWS and AWS here. You manage the objects and via anypoint platform. Linux based operating systems are required for all nodes that run runtime fabric components in Kubernetes clusters. The runtime fabric agent. Runtime fabric agent is deployed as a pod in the cluster and communicates with the control plane via an MTLS outbound connection established at startup. The agent is event driven. When an application state change generates Kubernetes event. The agent sends the metadata describing the current state of the application to the control plane. Kubernetes events include application pod start and updates and restarts. The agent also listens for incoming request from the control plane. When the agent received the message from the control plane, the agent makes the changes to the Kubernetes resources specified in the message. Such changes include creating new application, updating an existing application, and deleting an application. Mule cluster IP service provides an API that Mule applications use to discover their peers inside the cluster. Resource cache provides a cluster local cache of the application dependencies. These services are isolated within the core runtime fabric installation, namespace, and replicas. These services do not multiply as applications or nodes increase. Application services, runtime fabric install the following application services only when they are configured by users. Persistence gateway, provides the persistent object store version 2 interface to Mule application replication configured by user. Endpoint monitoring sidecar for monitoring and logging one sidecar deployed per application replica. Customer manage. Customers are responsible for providing configuration and managing the Kubernetes cluster used for runtime fabric. Additional configuration used to set up or enable capabilities on the Kubernetes cluster, such as those listed in a moment, are also the customer responsibility to manage. Ingress controller and customization to ingress resources. External load balancing. Log forwarding. Monitoring, network ports, NAT gateways and proxies, host runtime and networking, provisioning and management of Kubernetes environment. This requires assistance from the following teams in your organization: IT team to provide IT team to provision and manage the infrastructure, network team to specify allowed ports and configure proxy settings, security team to verify compliance and obtain security certificates. Here you can see admin is connected to endpoint platform control plane and AWS, EKS, GKE, and Red Hat OpenShift, and here you can see load balancers. Runtime fabric agent components, ingress registry optional, monitoring and matrices and logging, proxies and nodes, and storage and host runtime and networking inside network. Here you can see runtime fabric agent and components. Below you can see ingress, registry optional, monitoring, matrices and logging, proxies. Here you can see below that you can see nodes and Mule applications and APIs, and runtimes are in nodes. And below you can see storage, and then under that you can see host runtime and networking. Here the customer managed AWS, EKS, JKE runtime, JKE and Red Hat OpenShift, load balancers and ingress, registry optional, monitoring, matrices, logging, proxies, storage and host runtime and networking. Mule provided endpoint platform control plane, runtime fabric agent and components, and runtimes in nodes. Here you can see how application deployment work in Anypoint Runtime Fabric. When you deploy an application in Anypoint Runtime Fabric on the following occurs. One, you use Runtime Manager to trigger application deployment. The runtime fabric agent in the target cluster receive the request to deploy the application. 3, runtime fabric assign the application to an existing namespace and create a new namespace if necessary. 4, runtime fabric generate an appropriate Kubernetes resources including deployment, config map, secrets, services, and ingress. 5, if the Kubernetes deployment resource includes the init container, it fetches the dependencies from the runtime fabric resource cache. If 6, if the resource cache doesn't contain required dependencies, runtime fabric fetches them from the control plane and add them to the resource cache. Here you can see a resource cache, init container, MuleSoft container, Anypoint monitoring sidecar, and empty dir volume are inside runtime fabric cluster. Here init container, mule app container, Anypoint monitoring sidecar, and empty dir volume inside the application pod. Here you can see init container is connected to empty dir volume, and into empty dir volume is connected to MuleSoft container and Anypoint monitoring sidecar. Here init container is connected to resource cache via request dependencies, and resource cache is connected to Anypoint control plane via fetch dependencies. Here the Anypoint monitoring sidecar is connected to Anypoint control plane via send matrices and logs. Here you can see assigning namespaces in Anypoint runtime fabric. Each application is deployed into a Kubernetes namespace based on the application's environment. One runtime fabric searches for a namespace with the label rtf.mulesoft.com/envid equal Anypoint environment ID. 2, if the runtime fabric can't find that label, it searches for the namespace with the name Anypoint environment ID. If the runtime fabric can't find that namespace, it creates a new namespace called Anypoint underscore environment ID, Anypoint environment ID. Here you can see deploy application is connected to does namespace exist. If it is yes, it's connected to create Kubernetes resource, and if it is no, create namespace, and it is connected to create Kubernetes resource. Now we are considering runtime fabric data flow in Anypoint runtime fabric security architecture. Anypoint runtime fabric provides a secure way to manage MuleSoft application and API gateways deployed into runtime fabric anywhere, and ensures that you own and control the source and destination of your data. MuleSoft architecture model enables the runtime fabric to be installed anywhere and managed centrally from platform cloud-based Anypoint management center, which includes Anypoint runtime manager, Anypoint API manager, Anypoint monitoring and access management. Endpoint monitoring and access management. Under this model, all of your data flows are controlled at the location of your runtime fabric installation with limited metadata and metrics stored in endpoint management center. This metadata assists you with managing, monitoring, and troubleshooting runtime fabrics, integration runtimes, and APIs. This model is powered by components that run within the fabric cluster, refers to as runtime fabric agent. Runtime fabric agent establishes the connection to endpoint management center. It also acts as a conduit between internal components that power runtime fabric, such as Kubernetes and endpoint management center. Runtime fabric data flow. View the following diagram that shows the runtime fabric data flow here. Activation flow. The following lists the steps in the application activation flow process. One, as an authorized customer, you obtain a runtime fabric activation token from the runtime fabric manager running on any point control plane. Two, this activation token is then presented back to the runtime fabric manager during creation of runtime fabric. Two, runtime fabric management manager responds with the TLS certificate, CA chain, and read-only credentials to runtime fabric container registry. For runtime fabric agent stores the certificate and CA chain in the Kubernetes secret. 5, runtime fabric agent stores the read-only Docker registry credentials in the Kubernetes secret. 6, runtime fabric agent uses TLS certificate and CA chain to establish the mutual TLS and MTLS connection to endpoint management center to communicate with endpoint runtime manager. 7, container registry credentials are used to pull Mule runtime images from the runtime fabric container registry. Management flow. The following list the steps in management flow process. The MTLS tunnel protects all metadata between endpoint management center and your runtime fabric. Runtime fabric agent initiates and controls the tunnel. 2, application deployment messages contain metadata that describes the application and its dependencies, along with the link endpoint management center configuration resolver to fetch the Mule app bundle and configuration from. The configuration resolver communication is also protected with the same MTLS credentials. 3, you can use endpoint runtime manager to manage and monitor applications in the runtime fabric cluster. 4, you can use endpoint analytics service to get insight into how your APIs are being used and how they are performing. The services send to this metrics data directly to analyze API over a one-way TLS connection. These metrics consist of data-specific request. 5, runtime fabric agent, Mule apps, and API gateway are separate processes. If the runtime fabric agent stops working and it loses connectivity with any point management center, Mule apps and API gateways continue to operate. 6, Mule apps and API gateways work as defined in your Mule flows, and no customer data travels to any point management center. Your data flow is specific to the application that was built and deployed to the runtime. MTLS certificate renewal flow. The following list the MTLS certificate renewal flow process. 1, when the MTL certificate is close to an expiration date, the runtime fabric agent requests a renewal certificate from the endpoint management center via existing MTS tunnel. 2. Endpoint Management Center responds with the new TLS certificate. 3. Runtime Fabric agent overrides the existing certificate with the new certificate. 4. Runtime Fabric agent restart and reestablishes the MTLS tunnel with the new certificate. Endpoint monitoring certificate renewal. Endpoint monitoring certificate renewal flow. The following list the monitoring certificate renewal flow process. 1. When the endpoint monitoring certificate is close to its expiration date, Runtime Fabric agent requests a renewal certificate from the Endpoint Management Center via the existing MTLS tunnel. 2. Endpoint Management Center responds with the new certificate. 3. Runtime Fabric agent overrides the existing certificate with the new certificate. 4. Endpoint monitoring containers reestablish the connection with the new certificate. Here you can see Endpoint Management Center is in internet, and Endpoint Management Center is connected to Endpoint Runtime Fabric via MTLS. Endpoint Runtime Fabrics are in cloud provider network. Here you can see apps and mules are inside nodes. Nodes are inside Endpoint Runtime Fabrics, and here you can see Runtime Fabric services and cloud hosted Kubernetes and control plane are inside Runtime Endpoint Runtime Fabric. Here you can see AWS with EKS and Azure with AKS and Google with GKE. Here you can see how long a Runtime Fabric agent takes to restart if invoked by a customer so cluster upgrade. With regarding if scalability benchmark, the Runtime Fabric is a core of a Kubernetes K8 software and works alike in all K8 environments with comply with Runtime Fabric hardware and software requirement. Runtime Fabric functionality and management of applications deployments is not affected by following: size of the individual application, size of the worker nodes, number of pods running per work node. Because the Runtime Fabric is K8 based and user cloud native orchestration principles, it works according to a specific configuration of deployment. This graphic shows how long the Runtime Fabric agent takes to restart if invoked by a customer or cluster upgrade. Runtime Fabric takes approximately 190 seconds to create the apps irrespective of deployment volume. Aspects to consider: Runtime Fabric agent requires more than default memory and CPU to manage clusters with large-scale deployment. You can modify such values using information in the documentation. Note that the Helm you need to disable not watcher enabled explicitly when you operate at large scale. Not watcher is always enabled by default. Not watcher enabled : true. Performance of large scale deployment orchestration through Runtime Fabric is inversely proportional to the volume of deployment. Here you can see a near empty cluster. It takes 30 seconds here with the latency. Here you can see latency, and here with the for the restart. Here the loaded cluster here is 240 latency in seconds. Here you can see how to use Ingress resource templates in Runtime Fabric. Endpoint Runtime Fabrics enabled you to specify a custom Ingress configuration using an Ingress resource template. In a template similar to Kubernetes Ingress spec, you can specify annotations, Ingress class name, and HTTP, HTTP and HTTPS rules. If you do not apply an Ingress resource template for an application, you can't add Ingress endpoints when you deploy it. Here you can see how ingress resource template work in runtime fabric. This diagram provides an overview of how to use ingress resource templates in resource runtime fabric. An IT admin configures an ingress controller an admin creates or modify the ingress resource template using necessary parameters. Various ingress controllers operate differently. Review your ingress documentation and adjust your annotations accordingly. 3. An IT admin applies the template using KUB CTL apply command. 4. From the applied template, runtime fabrics creates placeholder URL domains and propagates the ingress configuration in Anypoint Runtime Manager. As a template for all application deployment. 5. A Mule application developer uses Runtime Manager to configure application for deployment by selecting available host and optional subdomain and path combination as specified in the ingress templates. Six, runtime fabric receives the application deployment request and uses the ingress configuration from the templates to create corresponding ingress object in the cluster. Here you can see the template. Here the IT administrator is connected to runtime fabric on self-management Kubernetes via KUB CTL apply -f template.yml here, and runtime fabric services and Mule applications are inside the runtime fabric on self-management Kubernetes. Here the runtime fabric services is connected to Mule application. Here the runtime fabric services interacts with runtime manager in Anypoint platform via propagates acme-rtf-ingress.yml https://example.acme.com/API here. Runtime manager is connected to runtime fabric services, and fabric service runtime fabric services is connected to Mule application. Here the runtime manager interacts with runtime manager UI via application deployment requests, and you can see Mule application developer here. Here you can see how a load balancer interacts between a VPC and any point platform in government cloud. Government cloud dedicated load balancer has an internal domain name that is used by applications and client within Anypoint VPC. The internal domain uses the following naming convention, in which IB-name is the name you gave the load balancer when you created it. Internal _lb-name _lb-gprod-rt anypoint-dns.net. Each dedicated load balancer has a DNS A records. lb-name dot lb-gprod rt dot anypoints dns.net that resolves to the public IP addresses of the two instances through your DNS provider. You can add CNAME record pointing to this A record and use domain names to access it. When you want your load balancer to manage all connections to your applications, publicly exposed, then each application must listen on HTTP port 8091 or 8092. Alternatively, you can create custom mapping policy to redirect outside request from your load balancer to your specific application. The following graphic shows how a load balancer interacts between VPC and anypoint platform. Your load balancer listens for outside request over HTTPS and by default communicates internally with your worker over HTTP. If you configured your Mule application within anypoint VPC, to listen HTTPS, you must set upstream protocol to HTTPS when creating the mapping list using the load balancer mapping add command. The internal HTTP mod enables you to configure how HTTP requests are managed. They are slightly ignored. Mapping to HTTP on the default SSL endpoint or URL is mapped directly to the corresponding HTTPS URL. Here you can see here you can see the services and load balancer migrant service are in anypoint platform. The here the LB migrant LB management service, not migrant, sorry. The service perform LB deployment and recovery procedure based on customer requests and checks perform on recruiting recurring biases, recurring basis. Instance presence check runs every minute. Instance impaired status check, which checks for degraded hardware or services, runs every 5 minutes. The checks will trigger recovery if needed. The LB management service is connected to LB load balancer. Watchdog checks once a minute if LB process has failed, so that LB management service can recover when there is a failure. Here the HTTP colon 80 or HTTPS colon 443 via public is connected via public DNS is connected to LB load balancer. Watchdog and LB process are inside the LB. Here the LB is connected to apps. Here the LB is connected to HTTP 809 colon 8091 or HTTPS 8092 via internet DNS to app 2. Here and apps are inside here the customer VPC, and here the no public access via no public access via port 8091 and 8092 to apps. Here you can see how API data appears in Kibana in Anypoint Platform Private Cloud Edition. Use the Elastic Stack ELK stack to analyze the business data and API analytics generated by Anypoint Platform Private Cloud Edition, Anypoint Platform PCE. You can use FileBeat to process entire platform log files, insert them into Elastic search database, and then analyze them with Kibana. The following example shows how API data appears in Kibana. Here you can see a Mule API request by method. Here the green color is, this is delete, and this is get. Here you can see a Mule API request by API version. Here this one is 1.2 and this is 1.4. Here the Mule API request by status code. Here the 200 and this is 404. Here the Mule API request by resources. Here you can see the count, and here the /API /authorize /598 is 11. Here the /API /authors, here this 4, and here the /API /authorize author ss /598. It's around, it's 1. And here the Mule, here you can see a Mule.api.part descending. Here the Mule application request by application. Here you can see the count. Here the test API app. Here this is count is 9 here. Here request by platform, and here you can see 1.2, and here you can see 1.4, and here you can see other, and other, and this is this one is 1.2, and this is Mac OS X here. Now here you can see a 4-node configuration in Anypoint Platform Private Cloud Edition. 4-node configuration is the smallest configuration that Anypoint Platform PC supports. This is a minimum number of nodes that can enable high availability and failover. In this configuration, each node hosts the platform applications and services. You must configure a load balancer to use round-robin distribution of traffic among each other 4 nodes. Three of the nodes host an instance of the database. And object store. The hosting the database and object store enable persistence but requires larger minimum disk and memory requirements. Although 3 of the nodes contain database, only one database is used as primary. Applications can on each node write to this database only. The other 2 database instances are hot standby instances of the primary database that take over as the primary database of case of failure. Here you can see SMTP server, supported identity provider, firewall, and load balancer inside the data center or DMS. Here the SMTP server interacts with the node here. Here the supported identity provider is interact with the node here, and here the actor is connected to firewall, and firewall is connected to load balancer. Load balancer interacts with the nodes, and here also, and nodes are inside anypoint platform, and these parts are inside anypoint monitoring optional. And here you can see runtime Mule runtime engines are inside standalone runtimes, and engines are connected to firewall. Firewall interacts with load balancer. Load balancer interacts with nodes, and here you can see nodes interacts with file system NFS, and here you can see HDD 1, HDD 2, HDD 3, and HDDs are inside file network file system NFS, and here this node interacts with an other node, and likewise here you can see OPS center, API manager, runtime manager, access management, exchange, database, file storage, and caching are inside this node. And here you can see reverse proxy NGI NX, OPS center, ingester router, log stash, insights, provisioning API, monitoring center, visualizer, influx database, Stolon database, file storage, and caching are inside here, this one. Here you can see 7-node configuration in anypoint platform private cloud edition. The 7-node configuration, 4 nodes are dedicated to hosting platform, and the object store instances, although each node contains a database. Only one of the database nodes are used as the primary. Applications on each nodes write to the database only. The two other database instances are hot standby instances of the primary database that takes over as the primary database in case of failure. You must configure a load balancer to use round-robin distribution of traffic among all of the nodes in your cluster. Here you can see SMTP server, supported identity provider, actor, and firewall and load balancer are inside data center or DMS. Here SMTP server interacts with the node, and supported identity provider interacts with the node, with the node here, and load balancer interacts with the nodes. Here Mule runtime engines are inside standalone runtimes, and these engines are connected to firewall. Firewall interacts with load balancer. Load balancer interacts with the nodes. And here the network file systems NFS interacts with the the nodes are connected to network file systems NFS. HDDIs are inside network file systems NFS. Here the 7 nodes are inside anypoint platform PCE, and there are nodes inside anypoint monitoring optional, here the OPS Center, API Manager, Runtime Manager, Access Management, Exchange, Database, File Storage, and Caching are inside a node. Here the you can see reverse proxy, NGINX, OPS Center, ingester router, logstack, insight, provisioning API, monitoring center, visualizer, influx database, install on database, file storage, and caching here. Here you can see the high level view of how scheduler service work in accelerators. The command scheduling service is an optional component that will run schedules and perform API calls. The benefit of having a common scheduler service is to have all the integration level schedules maintained in one place. Here is a high level view of how scheduler service works. The service may be built in two different ways depending on the target deployment platform. The Anypoint Serve platform offers operational advantage to application deployed in the Cloud Hub when dealing with schedules. The high-level workflow. The following is a high-level description of the workflow of the scheduler process. One, a predefined schedule is triggered. The schedules have enriched information about the last execution, such as schedule underscore type and watermark. Two, scheduling service calls the job configured for this event and updates the scheduled status to triggered. When a current with the current timestamp, the trigger ID and the callback URL are generated. 3, once the process is complete, it does a callback to the scheduling status service through the callback URLs to report the execution status. Here you can see schedule jobs in common scheduler, and here you can see common schedule is connected to client jobs APIs via last successful timestamp. Jobs are in client's job APIs, and client job API is connected to common scheduler via update job status, update job success or failure. Common scheduler is connected to jobs object store via update last successful watermark, and jobs object store is connected to common scheduler via read watermark. Common schedule is connected to job history object store via add job status. Common job scheduler, client job APIs, job history object store, and job object store are in MuleSoft platform. Here you can see the high level design in notification services in accelerators. The solution provides an optional notification process API which consumes notification events and sends notification to individuals or groups via SMS, email, and or Slack via system specific system APIs specific to those services. A high level design is as follows. As you can see, the API offloads incoming request directly to a queue in order to avoid blocking calling apps. The high-level workflow. Following is a high-level description of the workflow for notification process. A module calls the notification process API, providing notification /_type, either email, SMS or Slack. Notification /_address, destination address, a number. Notification /_message, notification message text. 2. The API places the message on a queue for downstream processing and immediately returns the success response. 3. A queue subscriber receives a message and routes to the appropriate system API based on the notification type. System API synchronously process the message and post it to backend service. For service configuration details, please refer Getting Started Guide in the documentation, as well as the individual RAML specifications and implementation templates for individual service themselves. Here you can see a notification process APIs in process API layer. Here API consumer is connected to the notification process API via post notification. Here notification process API is connected to notification topic via publish received notification. Notification topic is connected to notification queue. Notification queue is connected to notification process API via consume received notification. Here publish target notification is connected to here the notification process API is connected to destination channel via publish target notification. Here notification topic, notification queue and destination channel are inside AnyPoint queue. Here notification process API is connected to Slack system API via post message, and Slack system API is connected to Slack via send message. And here post message notification process API is connected to email system API via post message, and email system API is connected to email via send message. And here the notification process API is connected to SMS system API via post message. SMS system API is connected to SMS via send message. Here the Slack system API and email system API and SMS system API are in system API layer. Here the AnyPoint MQ process API layer, system API layer are in here in MuleSoft platform, on top of MuleSoft platform. Here you can see payments in model diagram in CIM, finance, subject area in accelerators. Activities to trace to financial information in a company, for example payment, invoice and expense report. The following diagram show entities and relationships in this subject area organized by entity group. Here you can see capture payment and refund payment are within payment, and you can see status pending, settled and void. Here the SF score refund and SF score payment here, and here the payment SF score none, and here the payment group have 0 or many payment authorization, and 0 good, and also has 0 or more payments, and payment authorization has payment one and only one payment group, or one and only one sales order payment summary. And here the payment authorization has one and only one payment gateway, and payment gateway has 0 or more payment authorization. And the payment gateway has is associated with 0 or more payment authorization. And here the payment is associated with can have payment has one and only one payment group, or one and only one sales order payment summary. Here the payment authorization has one and only one payment method, and payment method has 0 or more payment authorization. And here the payment group has 0 or more payments, and sales order payment summary can have has 0 or more payments. And here the payments has one and only one payment method, and payment method has 0 or more payments. And here the payment method has one and only one payment type, for example credit card, PayPal. Here the payment type can have payment type has 0 or more payment methods, and here the sales order payment summary has here the sales order payment summary contains sales order, and sales order has 0 or more sales order summary. And here the payment has one and only one payment gateway, and payment gateway has 0 or more payments. And here the payment gateway has 0 or 1 system credential, and system credential has 0 or more payment gateway. And here the payment gateway has one and only one payment gateway provider, and payment gateway provider has 0 or many payment gateways. And here the payment has one and only one payment treatment. The payment treatment has 0 or more payments, and payment treatment contains payment policy. Payment policy has 0 or more payment treatments, and payment treatments has one and only one payment treatment method, and payment treatment method has 0 or more payment treatment. And payment treatment has one and only one legal entity, and legal entity has 0 or more payment treatment. And here the legal entity has one and only one internal business unit, and internal business unit has 0 or 1 legal entity. Internal business unit has 0 or more payments, and payment has one in business unit. And here the payment has 0 or 1 account, and account has 0 or many payments. And payment contains payment authorization, and for payment authorization capture payment contains payment authorization, and payment authorization has 0 or more capture payments. Here the payment authorization has 0 or more payment gateway authorization log, and payment authorization log contains payment authorization. And here the payment authorization has payment authorization reversal, 0 or more payment authorization reversal. Payment authorization reversal contains payment authorization. Here the capture payment has 0 or more payment authorization reversal, and payment authorization reversal has 0 or 1 capture payment. And here the capture payment payment contains payment has 0 or more payment gateway payment log, and payment gateway payment log contains payment. Here the payment gateway authorization log, and payment gateway payment log, and payment gateway authorization reversal log in payment gateway interaction log. Here the capture payment contains 0 or more payment application, and payment application contains capture payment. Payment invoice application and payment credit memo application in payment application, and payment invoke application has one and only one invoice, and invoice has 0 or more payment application invoice applications. Payment invoice application has 0 or more payment invoice allocation, and payment invoice allocation contains payment invoice application. Here the payment credit memo application has 0 or more payment credit memo allocation. Payment credit memo allocation contains payment credit memo application, and here the payment allocation has 0 or 1 payment allocation, and payment allocation has 0 or more payment allocation. And here the payment credit memo application has one and only one credit memo, and credit memo has 0 or more payment credit memo application. Here the capture payment has 0 or more refund payment allocations, and refund payment allocation has one and only one capture payment. And here the refund payment has 0 or more refund allocation, and refund allocation contains refund payment. And here the refund payment allocation and refund credit memo allocation are in refund allocation, and refund credit memo allocation has one and only one credit memo, and credit memo has 0 or more refund credit memo allocation. Refund allocation has 0 or more refund allocation, and refund allocation has 0 or 1 refund allocation. Here the internal business unit has 0 or more payments, and payment has 1 internal business unit, and internal business unit has 0 or 1 one legal entity, and legal entity has 0 or 1 legal entity, and legal entity has only one business unit. Here the account has 0 or many payments, and payment has 0 or 1 account. Here you can see a payment method in model diagrams in CIM finance subject area in accelerators. Here you can see account type has 0 or many accounts. Account has one and only one account type. For example, account types order account, change account, rebate account, membership, for example, loyalty account, installment account, rental account, service account. Account has 0 or more payment method, and payment method contains the account. Here the payment method has only one payment method type. Here you can see fields name, description, etc. And for example, debit card only $100 per day. And here the and payment method type has 0 or more payments. Payment has 1 and only one payment method type, and the payment contains 0 or 1 payment method, and payment method contains 0 or more many payments. Here the payment method contain payment 0 or 1 payment policy, and payment policy has 0 or many payment methods. Here the credit tender contains one and only one account, or purchase one and only one purchase order. Account has 0 or 1 credit tender, and purchase order has 0 or 1 credit tender. Payment card, prepaid card, coupon, credit tender, cash tender, check tender, trading tender, digital wallet, and bank transfer tender are in payment method. Here you can see a shipment in model diagrams in CIM full field subject area in accelerators. Activities you perform to fulfill an order to a customer, for example, shipment and return order. Following diagram show the entities and relationships in this subject area organized by entity group. Here the shipment. You can see a shipment shipment has only one contact point address, and contact point address has a 0 or more shipment, and contact point address has a 0 or more sales order delivery group, and sales order delivery group has one and only one contact point address. Here the shipment has one and only one sales order, and sales order has 0 or more shipment, and here the shipment has 0 or 1 fulfillment order, and fulfillment order has 0 or more shipments, and fulfillment order has one and only one sales order. Sales order has 0 or more fulfillment order. Here the sales order has 0 or more sales order delivery group. Sales order delivery group contains sales orders, and here the sales order has 0 or more sales order products. Sales order product contains sales order. Sales order delivery group has one and only sales order delivery group has a 0 or more sales order product, and sales order product has one and only one sales order delivery group. Here the sales order product has 0 or more fulfillment order product, and fulfillment order product has one and only one sales order product. Sales order product has 0 or more shipment product. Shipment product has one and only one sales order product. Fulfillment order product has 0 or more shipment products. Shipment product has 0 or 1 fulfillment order products. Shipment product has 1 and only one sales order product, and sales order product has 0 or more shipment products. Shipment product has one and only one sales order price adjustment group, and sales order price adjustment group has 0 or more shipment products, and shipment product has one and only one sales order tax, and sales order tax has 0 or more shipment products. Shipment products has contains shipment has 0 or more shipment products, and shipment products has one and only one shipment package, and shipment package has 0 or more shipment products. Shipment products has 0 or more shipment product price adjustment, and shipment product price adjustment has one and only one shipment product, and shipment product price adjustment has 0 or more shipment product price adjustment tax, and shipment product price adjustment tax has one and only one shipment product price adjustment. Shipment product package contains shipments, and shipment has 0 or more shipment packages, and shipment packages has 0 or more shipment document, and shipment document has one and only one shipment package, and shipment document contains shipments, and shipment has 0 or more shipment documents. Shipment documents has one and only one content document version, and content document has 0 or more shipment document, and shipment document has content document version contains content document, and content document has 0 or more content document version. Here you can see a party in model diagrams in CIM market subject area in accelerators. This defines who you have trading relationship with and how. For example, a customer and supplier along with the contact information such as phone number and email address. Model diagrams here the following diagram shows the entities and relationships in this subject area organized by the entity group. Here in the who section you can see a party. Party has 0 or 1 global party. Organization, individual, household, internal business unit, affiliation group, and uncategorized party are in party. Party has 1 or more 0 or more party credential, party business license, party board certification, party award, party accreditation are in party credentials. Organization has 0 or more Organization milestones. Organization milestones has milestone contains in organization. Individual has 0 or more account contact, and account contact has contains individuals. Party has 0 or more party web addresses, and party web address contains party. Party has 0 or more party additional names, and party additional name contains party. Party has 0 or more party identification. Party identification contains party. Party identification has 0 or more party role, and party role has 0 or more party identification. Party has 0 or more party related party. Party related party has contains party, and party has 0 or more party related party, and party related party has one and only one party. Party related party has one and only party related relationship type, and party relationship has 0 or more party related party. Individual have 0 or more person employment, 0 or more person education, 0 or more person life event, 0 or more person language, and 0 or more account contact, and person employment, person education, person life event, person language, and account contacts contains individual. In the here the Y section, this is who area, the global party, and party the party relationship type, party employment, party education, party life event, party language, and party credential, party identification, party additional name, party web address, party organization milestone, and global party. And here the Y section, and the party role, customer status history, and customer status, and user. Here the party here the party role contains party, and party has 0 or more party roles. Customer, consumer customer, and business customer in customer. Here the party role has 0 or 1 internal business unit, and internal business unit has 0 or more party role, and customer has 0 or more customer status history, and customer status history contain customer. And customer, seller, supplier, competitor, worker are in party role. Party role has 0 or more party identification. Party identification has 1 or 0 party role. And here the customer status history has 0 or more, 1 and only 1 customer status, and customer status has 0 or more customer status history. here the party role has 0 or more user, and user has a user, and here the user has 0 or 1 party role, and here the party role has 0 or many privacy content, and privacy content has 1 or 0 party role. Here you can see the house section, here the lead, account, and account partner, and account contact, and account contact role. Here the leads contains party role, and party role has 0 or more lead. Account contains account has 0 or more party, and party has 0 1 account. And here the account has 0 or more account contact. Account contact has contains individuals, and here the individuals has 0 or more account contacts, and here the account contact has 0 or more account contact role, and account contact role contains account contact. Account contacts has 0 or 1 association with fax with 0 or 1 contact point. Contact point can fax 0 or many account contacts. Account contact can do a mobile with 0 or 1 contact point, and contact point can do mobile with 0 or many account contacts. Account contacts can send other emails for 0 or 1 contact point. Contact point has 0 send other emails to 0 or many account contacts. Contact point account contact can email 0 or 1 account contact point, and contact point can send emails to 0 or many account contacts, and account contacts can do a business call to 1 or 0 contact point, and contact point can send 0 or many business call to 0 or many account contacts, and account contacts send mails to 0 or 1 contact point, and contact point send mail to 0 or many account contacts, and 0 account contact can do a can have a home phone can do a home phone call to account contact point, and contact point can do a home phone call to 0 or many account contacts. Account contacts have an indirect relation with 0 or many account contacts, and account contacts have indirect relationship with 1 or 0 account contacts. Account contacts has 0 or many account roles, and account role contains account contact, and account can have 0 or many account partner, and account partner can have one and only one account. Account has 0 or many account partners, and account partner contains account. And here the account can send a billing mail to 0 or 1 contact point address, and contact point address can send billing mails to 0 or many accounts. Account can send shipping mail to 1 or 0 contact point address, and contact point address can send shipping mail to 0 or many accounts. Account can send primary sales to contact point location, and contact point buffers to contact point, and contact point can send 0 or many primary sales to many accounts, 0 or many accounts, and account can fax uh, contact point 100 contact point contact point phone, and contact point phone can fax 0 many accounts, and account can fax phone 100 contact point name, and contact point phone and contact point phone can phone 0 many accounts. An account can send shipping email to 100 contact point email, and contact point email can send shipping emails to 0 many accounts. And your account has 0 or many accounts, and account has 100 accounts. And here you can see via in this section you can see a contact mail and contact point phone type use, location, address, software application, device endpoint. Here the contact point email, contact point phone, contact point location, contact point address, contact point social, and contact point app are in contact point. Here the contact point app has 0 or 1 device endpoint, and device endpoint has 0 or many contact point app. And here the device endpoint contains device, and device has 0 or many device endpoints. Device endpoints has 0 or 1 software application has 0 or many device endpoint. Device has 0 or many contact app point, and contact point app has one and only one device. And software contact point app has one and only one software application, and software application has 0 or more contact point app. Contact point address has 0 or 1 address, and address has 0 or many contact point addresses. Contact point location has 0 or 1 location, and location has 0 or many contact point address, and location has 0 or many addresses, and address has only 1 locations. Contact point phone has 1 or 0 phone type use, and phone type use has 0 or many contact point phone. Contact point email contact point has one and only one point contact point type, and contact point type has 0 or many contact points. Party has 0 or more privacy consent, and privacy consent contains party. Here you can see what section privacy contains data use purpose, and here the privacy content has 0 or 1 contact point, and contact point has 0 or many privacy content, and privacy content has contact point type 1 or 0 contact point type, and contact point type has 0 or many privacy content, and privacy content has 0 or 1 party role, and party role has 0 or many privacy content, and privacy content has one and only one data use purpose, and data use purpose has 0 or many privacy consent. Here you can see product in model diagrams in CIM produce subject area in accelerators. Handling of material that you are buying and moving and selling, for example product and inventory products. The following diagram shows the entities and relationship in this subject area organized by entity group. Here you can see product, good product, service product, bundle product, and master products are in products. Here the product cross catalog, one and only one cross catalog product cross catalog and primary catalogs are has one and only one 0 or 1 product category, and product category has 0 or many products. Products category has contains product catalog. Product catalogs e-commerce catalog, inventory catalog, partner spare parts catalog, NAICS code catalog, EU tariff code catalog. Product catalog has zero or more many product catalogs. Product category catalogs. Product category has zero or one product category, and product category can have zero or many product categories. Product category has zero or many product category attribute sets. Product category attribute set has contains product category. Product category attribute set has one and only one attribute set, and attribute set has zero or many product category attribute set. Product category attribute set has one and only one entity, and entity has zero or many attribute set. Custom entity and standard entity are in entities. Custom entity has zero or many attribute set storage entities. Attribute sets, for example, attribute sets product hazardous details, product top competitions. Attribute set has zero or many attribute set attributes in attributes. Attribute set attributes and product attributes are in attributes. Attribute set attributes and zero or many attribute product attribute value, and product attribute value has one and only one attribute. Product attribute value has zero or one attribute value, and attribute value has zero or many product attribute value. Attribute value contains attributes. Attributes has zero or many attribute value. Product attribute value has contains product, and product contains product has zero or many product attribute values. Attribute set contains attribute has zero or many attribute set storage entity, and storage entity contains attribute set storage entity attribute set. And attribute set has zero or many product attribute sets, and product attribute set has only one attribute set, and product attribute set has product category attribute sets. Product category attribute set has one and only one product attribute sets. Product category set has zero one product category product, and product category product has zero contains product category. Product category has one and only one product, and product has zero or more product category, and here the product has zero or many product attribute set, and product attribute set contains product. The product has zero or one custom product attribute sets, set 1 2 here, and categories set custom product attribute set 2 here has only one and only one product, and here the product has one or many product attribute, and product attribute has contains product. Here the product contains product contains product attributes value, and product has zero or more product attributes values, and product attributes values contain product. Here the product has zero or more product related products. Sales bundle product, marketing related product, service related product, and product component has in product related products, and product related products has one and only one product relationship type, and product relationship has zero or more product product related products. Product relationship type has one and only one product relationship role, and product relationship role has zero or more relationship type. And here the product has zero product related product has only one product also, and here the product has zero or many product image, and product image has contains product image has 0 or 1 image size, and image size has 0 or many product image has one and only one image, and image has 0 or many product image. Here the sales related products types are bundle for, bundle with, option for, option of, accessory to, accessory for. Here the marketing related product relationship types are cross sold by, cross sell of, upsold by, upsell for. Service related product relationship type substitute for, substitute by, compatible with, compatible with, compatible with, compatible with. And product component related type consist of, component of, dependent on, dependent for. And product image, product has 0 or more product image, and product image has contains product image has 1 or more, 1 or 0 image size, and image size has 0 or more product image has 1 and only one image, and image has 0 or more product image. Product has 0 or more entitlement product has 1 and only one product. Entitlement product contains entitlement policy, and entitlement policy has 0 or more entitlement products. Entitlement policy has 0 or more buyer group entitlement. Buyer group entitlement has 1 and only one entitlement policy, and buyer group entitlement has contains buyer group has 0 or more buyer group entitlement. Product has 0 or more assessment product, and assessment product has only one and only one product. Assessment product contains assessment, and assessment has 0 or more assessment product. Assessment product has 0 or more store assessment. Store assessment had only one and only one assessment. Here the assessment product group of products to store many carry. Here the store product is the what products a store is observed to have. Inventory product, what specific numbers of products in a store or other type of location have. Never use store product for inventory management. Product can have product has 0 or many store product, and store product has one and only one product. Store product contains sales store. Sales store has 0 or many store products. Sales store is in location. Sales store has 0 or more many store assortment. Store assortment contains sales store. Product has 0 or more many inventory products. Inventory product has one and only one product. Inventory product contains location, and location has 0 or more many inventory products. Product contains supplier products 0 or many supplier products has one and only one product. Supplier product contains a supplier has 0 or many supplier products. Product has seller products 0 or many seller products. Seller product has one and only one product. Seller product contains seller, and seller has 0 or many seller products. Customer product has one and only one product, and product has 0 or many customer product. Customer product contains customer has 0 or many customer products. Product has 0 or many campaign offer. Campaign offer has one and only one product, and campaign offer contains campaign has zero or many campaign offers. And here the product has zero many product collateral, and product collateral contains product. Here the country product has one or zero country produced in one or many country has zero many products. Here the product has package in zero or many country, and country package zero or many products. Here the product has many relationships drawn, only one for readability, with sales channel, time period, UIM, and brand is associated with 0 to 1, and here this is associated with 1 to 0 to many. Here you can see a brand is connected to a brand has one and only one brand grade, and brand grade has zero or many brands. Here the master product has many products, and many products has one master product. Product is associated with the master product. Service product has zero, one and only one service type, and service type has zero or many service product. Goods product has 1 and 0 of these types, and these are having many relationship drawn, only one for readability here, and with this it has 0 to many goods product. Here you can see gender, season, environment requirement, pattern, fabric, security requirement, color, style, and size, UOM. Here the local has 0 to many product translation. Product translation has one and only one local. And here the local has 0 to many product catalog translation. Product catalog translation has one and only one local. Here the local has product category translation, and product category translation has only one local. See here the product local has product image translation, and product image translation has one and only one local, and here the local has 0 or many attribute set translation. Attribute set translation has one and only one local, and here the local has 0 or many attribute value translation, and attribute value translation has one and only one local, and here the local has attributes 0 or many attribute translations, and attribute translation has only one and only one local. Here you can see a sales order in model diagrams in CIM cell subject area. Anything you plan to sell, or any part of the product that needs to be tracked for service purposes. For example, you are selling a green tractor. The following diagram shows the entities and relationship in this subject area organized by entity group. Here the sales order. Here you can see sales order has one and only one currency, and currency has 0 or many sales orders. Here the sales order has 0 or 1 sales store. Sales store has 0 or many location. Retail store and web store are in sales store, and sales store is in location. Here the web store has sales store has 1 and only one taxation policy, and taxation policy has 0 or many sales store. Location has sales store has 0 or 1 sales channel, and sales channel has 0 or many sales store. Here the sales channels For example, sales channels: UK retail stores, US web storefront, UK web storefront ads. Sales stores, for example, retail store San Francisco, retail store Miami, warehouse outlet Brooklyn, web store UK, mobile app, call center set, tweet ad, web ad. Sales channel has many sales order. Sales order has one and only one sales channel. Contact has many sales orders, and sales order has 1 contact. And here the sales order has can build to one and only one contact point email, and contact point email has many sales orders. Sales order has 1 quote, and quote has many sales orders. Sales order has 1 opportunity. Opportunity has many sales orders. Sales order has one and only one contact address. Contact address has many can build to or ship to many sales orders, and sales order also can build to or ship to one and only one contact point address. Contact point address has many sales order delivery group. Sales order delivery group has can have a shipping address with to one and only one contact point address. And sales order can build to one contact account contact, and account contact can build to many sales orders. Account contact contains account, and account has many account contacts. Sales order can have to many originals, and originals can have sales order originals can have 1 originals. Sales order can build to 1 account, and account can build to many sales orders. Sales order can solve to 1 customer, and customer can have many sales orders. Account contains customers, and customer can have 1 many accounts. Here the accounts account types: credit installment, credit revolving, layaway, rebate, rental, service, sales, loyalty. Account can have 0 or many sales order products, and sales order product can seller has seller account 1 seller account, 1 seller account. And here the customer contains party. Party contains many customers. Can be business, individual, and internal business unit in party. Party has many sellers, and sellers has sellers contains party. And internal business unit has many sales order, and sales order can have only one and only internal business unit. Sales order can have 1 seller, and seller can have seller has many sales orders. Here the party has many suppliers. Supplier contains party. Supplier has 0 or many sales order product, and sales order product has 1 supply. Sales order has 1 device, and device has many sales orders. Device has many user device session, and user device session has only one and only one device. User device session contains user has many user device session. and here the sales order has 0 many sales order product, and sales order product contains sales order. Um, sales order product has 0 or many invoice line has 1 or 0 1 sales order product, and here the sales order product has 0 many fulfillment order product, and fulfillment order product has one and only one sales order product. Here the sales order product has sales order one and only one sales order delivery group. Of sales order delivery group has 0 or many sales order product. Sales order product has 1 or many originals, and originals sales order product has 1 or 0 originals. Sales order product has one and only one product, and product has 0 many sales order product. Product has 0 many sales order delivery method, and the sales delivery method can only one and only one product. And product has 0 or many price book entity. Price book entity has only one and only one product. And here the product has 0 or many inventory product. Inventory product contains product. And here the sales order product has 0 or many sales order product in identity document, and sales order identity document has only 0 or contains sales order product. And sales order product identity document has one and only one party identification. Party identification has 0 or many sales order product identity document. And here the sales order product has 0 many sales order product related product, and sales order product related product contains sales order product. Sales order product order product related document has only one and only one sales order product. Product relation sales order product related document has one and only one product relationship type. Product relationship type 0 or many sales order product related product sales order product related product. For example, sales order product relationships types bundle with, bundle of, hash option 4, covered by, covering. Sales order product has 0 or many sales order product group assignment. Sales order product group assignment has one and only one sales order product. Sales order product group assignment contains sales order product group, and sales order product group contains 0 or many sales order product assignment. Sales order product contains 0 or many sales order product node, and product sales order product node contains sales order product. Sales order product contains 0 or many sales order change log, and sales order change log contains one and only one sales order product. Sales order product has 0 or many sales order product tax. Sales order product tax contains sales order product. Sales order product has contains 0 or many sales order product price adjustment. Sales order product price adjustment contains per sales order product. Sales order product has 0 many invoice line, 0 many invoice line contains 0 or 1 sales order product. Sales order product contains 0 many fulfillment order product, and fulfillment order product contains one and only one sales order product. Sales order product has one and only one sales order delivery group. Sales order delivery group has 0 many sales order product. Sales order product sales order delivery group has one and only one contact point address, shipping address, and contact point address has 0 many sales order delivery group. Sales order delivery group has one and only one sales order delivery method, and sales order delivery method has 0 many sales order delivery group. Sales order delivery group has 0 or 1 originals, and original 0 sales order delivery has 0 many originals. Here the sales order price adjustments, and here the sales order has sales order changing log, populated post activation 0 many sales popular, so how store order related to change orders and why change order is created. Sales order change log has one and only one sales order. Sales order and change order change log contains sales order. Sales order has 0 many sales order delivery group. Sales order delivery group has 0 many sales order change log. Sales order change log has one and only one sales order delivery group. Sales order has 0 or many sales order price adjustment. Sales order price adjustment contains sales order. Sales order price adjustment and sales order product price adjustment are in sales order price adjustment group. Here the sales order price adjustment group has 0 many sales order product price adjustment tax, and sales order product price adjustment tax contains sales order product price adjustment. Here the sales order product tax and sales order product price adjustment tax are in sales order tax, and sales order tax has 0 many sales order change log, and sales order change log has only one and only one sales order tax. Sales order product tax contains sales order product, and sales order product has 0 many sales order product tax. Sales order tax can have 0 one original, and 0 products can order tax can has 0 or many product or sales order tax. Sales order product price adjustment has 0 or 1 price adjustment tier. Price adjustment tier has 0 or many sales order price adjustment. Sales order price adjustment group has 0 or 1 coupon, and 0 1 coupon has 0 or many sales order price adjustment group. Sales order price adjustment group has 0 1 promotion, and promotion has 0 many sales order price adjustment group. Sales order product has 0 many fulfillment order product, and the sales fulfillment order product has one and only one sales order product. And here the delivery methods are in store, pickup, 2-day UPS, download, and here the sales order has 0 or many sales order payment summary. Sales order payment summary here contains the sales order. Sales order payment summary has only one and only one payment method, and payment method has 0 or many sales order payment summary, and payment method has contains 0 or many payments, and payment has one and only one payment method, and payment has 0 or one and only one payment sales order payment summary, and sales order payment summary has 0 or many payments. And here the sales order product has 0 or many fulfillment order products, and fulfillment order product has one and only one sales order product. Fulfillment order product has contains fulfillment order. Fulfillment order has 0 or many has 0 or many fulfillment order products. Fulfillment order product has one and only one fulfillment order type. Fulfillment order type has 0 or many fulfillment orders. Fulfillment order types are, for example, warehouse, picking and ship, supplier, dropship, retail store customer pickup. And yeah, here you can see document in model diagrams in CIM setup subject area in accelerators. Define technical resources such as software component and document images. Model diagrams. The following diagrams show the entities and relationship in the subject area organized by entity group. Here you can see document. The loan document is in document, and document has one loan application. Loan application has zero or many loan documents. Here the document has zero or many document index, and document index has one document. Document index has one document image. Document image has zero or many document indexes. Document image has 0 1 image content, and image content has one document image. Here you can see the functional diagram in CDA to FHIR converter in accelerators. The CDA to FHIR converter comes with a ready-to-use template for CDA to FHIR conversion. This template can be extended or modified to meet specific conversion requirements. Here you can see the functional diagram. Advantages are accelerate efforts to standardize on FHIR and enables more comprehensive view into patients. Follows best practices prescribed by HL7 and removes manual work associated with conversion. Solution can be extended to support additional CDA documents. Highly performant with underlying data view engine. Here you can see a Epic Oracle Center. Athena Health are connected to CCDA, and it's connected to Mule HL7 FHIR, and HL7 FHIR is connected to Health Cloud, custom outpatient system, and referral aggregator. Here you can see a functional diagram in HL7 version 2 to HL7 version 2 to FHIR converter in accelerators. The HL7 version 2 to FHIR converter comes with a ready-to-use template for HL7 version 2 to FHIR conversion, which is based on the guidance provided by HL7 version 2 to FHIR implementation guide. This template can be extended to or modified to meet specific conversion requirements. The advantages are removes manual work associated with HL7 version 2 and FHIR conversion following HL7 identified mappings. Support the most commonly used HL7 version 2 message formats. HL7 connector is pre-configured for this use case to easily read HL7 version 2 messages. Solutions can be extended to support any custom fields and segments. Highly performant with underlying data view engine. Here you can see Epic Oracle Center. Eternal Health are connected to HL7 Mule via HL7 version 2, and Mule is connected to Health Cloud FHIR repository and lab systems via HL7 FHIR. Here you can see the functional diagram in X12 to FHIR converter in accelerators. The X12 to FHIR converter comes with a ready-to-use template for X12 to FHIR conversion. This template can be extended or modified to meet specific conversion requirements. The converter converts FHIR R4 to X12 formats and its responses from X12 to FHIR R4. Advantages are removes manual work associated with X12 to FHIR conversion. X12 connector is pre-configured for this use case to easily read and write X12 EDI events. Supports multiple X12 message formats and use cases. 270 and 271 eligibility verification inquiry. 278, 270i, 278i and 275 prior authorization. 837 claims. Solution can be extended to support any custom field and segments. Highly performant with underlying data view engine. Here you can see Epic, Oracle Cent and Eternal Health are connected to Mule via HL7 FHIR, and Mule is connected to prior auth repository, clearing houses, claims and claim systems via X12. Here you can see a high-level architecture in SFTP setup guide in accelerators. The setup guide enables customers to upload existing customer, product and other order data to manufacturing cloud via SFTP. Data can be exported in CSV or Excel SX format for loading into Salesforce. Load data. Here you can see load data to manufacturing cloud. Functional considerations. Customer, product and order data need to be in CSV or Excel SX format. Customer and product data need to be loaded into manufacturing cloud before loading in order data, so that orders can be attached existing customers and products. Technical considerations. This section lists the technical consideration and concentrate on the solution design. The CSV and Excel SX files need to be in format specified and MDM implementation is required in order to reference customer and product data in orders. Systems involved Salesforce Manufacturing Cloud and SFTP server. PIM database. Anypoint MQ. Global data management. Processing logic. SFTP CIM handler reads the files from SFTP location and converts the records into respective CIM structures and publishes the records into the customer's products and orders exchanges for related objects. Corresponding processes, APIs, process APIs, process the messages in CIM format and insert the data into the manufacturing cloud via the corresponding system APIs. In your SFTP server, create inbox, archive and error folders for customers, product and orders. File configuration. SFTP integrations can only read comma separated text file with *.csv extension or Microsoft Excel file with *.xlsx extension. For Excel files, make sure all the data is in one tab and the tab names must be following: customer info, order info and product info respectively. Here you can see a machine is connected to SFTP CIM handler via SFTP customer product and order file. SFTP CIM handler is inside is in integration layer. SFTP integration, and here the customers queue, customers exchange, order exchange, orders queue, product queue, and product exchange are in AnyPoint MQ. Here the customers process API, order process API, product process API, and PIM sync process API are in process API layer. Salesforce customer system API, MDM system API, Salesforce order system API, MDM system API, MDM system API, Salesforce product system API, and PIM system API are in system API layer. AnyPoint and process API layer in cloud information model, and it's also integration layer and system API layer interacts with cloud information model. Cloud information model, integration layer, and system API layer in MuleSoft platform. Here the SFTP CIM handler is connected to customers exchange via publish customer CIM. Customers exchange is connected to AnyPoint MQ. Customers queue. Customers queue is connected to customers process API via consume customer or account event. Customers process API is connected to Salesforce customer system API via create update customer. Salesforce customers API is connected to here the via create or update customer. Here the customers process API is connected to MDM system API via create or update MDM objects. MDM system API is connected to the database via create to update MDM object, and it is connected to MDM system API via get MDM objects, and here the MDM system API is connected to process API layer via get MDM objects. Here the SFTP SIM handler is connected to orders exchange via publish order CIM. Order exchange is connected to orders queue via orders queue. Orders queue is connected to process order process API via consume order event. Orders process API is connected to Salesforce object system API via create to update order. Salesforce order system API is connected here the connected to settings via create to update order, and here the orders process API is connected to MDM system API via create to update MDM object, and it's connected to here via database via update to create to update MDM objects, and it is connected to MDM system API via get MDM objects, and it is connected to get MDM system API is connected to order process API via get MDM objects. Here the SFTP CIM handler is connected to product exchange via publish product CIM. Product exchange is connected to product queue. Product queue is connected to product process API via consume product event. Product process API is connected to MD system via create to update MDM object. MDM object is connected. MDM system API is connected to database via create or update MDM objects, and it is connected to MDM system via get MDM objects, and MDM system API is connected to product process API via get MDM objects. The product process API is connected to Salesforce product API system API via create to update product. Salesforce product system API is connected to settings via create to update product, and products process API is connected to update or create product. Product system products process API is connected to PIM system API via update or create product. PIM system API PIM system API is connected to database via update to create to update product, and it is connected to PM system API via get product details. PM system API is connected to PIM sync process API via get product updates. PIM sync process API is connected to product exchange via publish product update event. Here you can see a example team structure in access management. Imagine that your organization ACME includes a team called engineering that contains smaller teams that focus on building specific components. The identity and DevOps teams are specialized teams within a larger engineering team. Using teams feature, you can structure your users and permissions in the following way. A users team shown here are identified as follows. ACME, this team represents the organization and root team, and every user in your organization is a member. By default, team's name is everyone at ACME. You can set your permissions such that all ACME users can easily collaborate within your organization by creating new projects in Anypoint Design Center and viewing assets in Anypoint Exchange. To do this, you must configure the following permissions for everyone at ACME team: Design Center Developer and Exchange Viewer. Engineering, the first child team of the ACME team. This team includes all ACME engineers, but it excludes ACME's other members such as the marketing and partner teams. The engineering team inherits permissions from the everyone at ACME team, but you can give it additional permissions as needed. You can set permissions that allow members of the engineering team to deploy code to pre-production environments such as sandbox and design, but you can exclude permissions to deploy to production. To do this, you must configure the following permissions for the engineering team. Deploy API proxies applicable to sandbox and design environment, Design Center Developer, and Exchange Viewer. DevOps, this team is one of two child teams under under the engineering team. DevOps team is a group of specialized engineers who manage production code across all engineering teams. Unlike with the parents engineering team, you can give the DevOps team permission to manage code in production environment rather than only in the pre-production branches. To do this, you must configure the following permission for DevOps team: deploy API proxies applicable to sandbox, design, and production environment, Design Center Developer, and Exchange Viewer. Identity, the team is one of the two child teams under engineering team. The identity team is responsible for managing projects, assets, and other materials in its designated business groups. As a child of the engineering team, the identity team can still deploy code to pre-production environment, but unlike members of DevOps, members of identity do not need to deploy to production. You cannot give this team permission to manage entire organization, but you can give it permission to manage audit log and authentication services business groups by configuring the administrator permission within the scope of the audit log and authorization services business groups. Combined with the inherited permissions from the engineering team, the identity team has the following permissions: administrator applicable to audit log and authorization service business groups, deploy API proxies applicable to sandbox and design environment, Design Center Developer, and Exchange Viewer. Here you can see ACME is connected to engineering is connected to DevOps and identity. Here you can see identity management process in the SAML identity management process in access management. As the Anypoint Platform Organization Administrator, you can configure the identity management in Anypoint Platform to set up users for a single sign-on SSO. An organization can have up to 25 external identity providers. OIDP is configured for SSO. Configure identity management using one of the following single sign-on standards: OpenID Connect, end-user identity verification by an authorization server including SSO. SAML 2.0 web-based authentication including cross-domain SSO. The following diagram shows the SAML identity management process. Before configuring OpenID connect for SAML 2.0, select an OpenID connect compliant provider such as Ping Federate, OpenAM, or OKTA. If you are not using the OpenID Connect, select any SAML 2.0 compliant provider. Following SAML providers are fully supported: Salesforce, Ping Federate, versions 678, OpenAM version 14, and OKTE. Following SAML providers are known to work but aren't actively tested: Active Directory Federation Services, ADFS, Sibboleth, OneLogin, CA, Single Sign-On, Secure Auth. Following providers are fully supported to work with OpenID Connect: Salesforce, Ping Federate, version 6, 7 and 8, OpenAM version 14, and OKTA. After you select an identity provider, set up your endpoint platform organization as audience in new identity provider configuration. Note the IDP the IDP you select is effective for entire organization and all business groups. Configure identity management in the endpoint platform root organization. Configure the attribute names on the IDP and endpoint platform to match. For more information, see the documentation for your identity provider. Here you can see the user and endpoint platform and API here, and here you can see IDP and OKTE and OAuthn. The step 1, user browser attempt get of any point platform resource to the platform redirect to IDP. 3, browser send an authentication request to IDP. I repeat again, step 1, browser attempt to get of any point platform resource from user to any point platform, and step 2, the any point platform redirect to IDP from any point platform to user, and here the browser send an authentication request from user to IDP, and here the IDP authenticates the user, and here the step 5, the IDP send an assertion to user. Then step 6, browser sends an SAML authentication process to endpoint platform, and then endpoint platform from endpoint platform response with the resource initially requested to user. Here you can see SAML response element in Chrome developer tools as a result of logging into any point platform using SSO. In access management, this figure SML response element after logging into any point platform in Google Chrome. In the network tab, the receive ID line indicates that you attempted to log in to an endpoint platform single sign-on through your identity provider. Because the login is successful, you can expand receive ID and access the data that contains your SAML response element. Note that unsuccessful login attempts still generate SML response elements. Here you can see a typical site structure in API Community Manager. The structure of your Salesforce Experience Cloud site is defined by your site pages. The Lightning components contains in each and the links between them. You can define your own website structure and use journeys throughout your site with these elements tailored to your specific need and desires. Typical site structure. To configure your site according to typical site structure, organize it into these pages. Home page contains welcome information, rich text components, or HTML component. Select APIs and API groups, API carousel components, news and announcement, CMS collection component, and the main search bar ACM search box component. Login page allows a member to log on to your community or to go to the registration page if they are not already a member. Login form component. Registration page allows a guest to register as a member in your community. Self-register component. Search page. Search results page shows results in searches in the community. ACM search results component. Each search result links to the appropriate page based on the type of the element, such as a content article page and API details page and others. News list page contains a list of different content articles such as news or announcement, CMS collection components. API groups and API groups catalogs page contains full catalog of APIs and API groups available in your site for consumers to explore and discover. API catalog component. And news details page also. API and API groups details page displays the documentation and technical content of an API or API group, including API console and a way to request access to the API. The content of this page is tailored to the type of object being accessed by user page variants. Whereas you can find more information about the page variation in Salesforce Experience Cloud documentation page. API marketing pages. These pages are optional. Each page displays the content specific to the individual API or API group, rich text component or HTML component. You use one page for each API or API group as required. Each page is explicitly configured on the API or API group details in the community control panel as described in the publish API page of the API community manager documentation. My applications page display the members client applications, application listing components. My details page display the details about one client's application details component. Forums page Displays the component for discussion forums, feed component, member profile page. Displays member profile information and allows the members to update their details. User profile component. This page also shows user uses their API subscriptions and provide the optional to unsubscribe from each API, user settings and user subscriptions component. Here you can see home page, and here the home page is connected to the login page. Login page is connected to register page. Register page is connected to the home page. Here the home page is connected to search results. Search result is connected to news announcement detail and API marketing page and API details and console. Here the home page is connected to news announcement news or announcement detail, and here the home page is connected to all news or announcement, and it is connected to news or announcement detail. Here the home page is connected to catalog, API catalog, and API catalog is connected to API marketing page, and here the home page is connected to API marketing page, and again home page is connected to all API details and console, and home page is connected to API applications, and API application is connected to application details, and here the home page is connected to forums and marketing profile. Here you can see the types and relationships that monitors the public APIs can have with their schedules, public locations, APIs and environments. In API functional monitoring. The public APIs are API with endpoints that are exposed to the public internet. Tests of such endpoints are run by workers that themselves run in public locations or private locations. A public location is a region or resource pool that is shared with other MuleSoft customers. Examples of such regions are US East 1, US East 2, US Central 1. For information about private locations, see monitoring on the endpoints of private APIs in the documentation. The test in the monitors are run on schedules. For a worker to run a public location according to a schedule must be associated with it. A public location can be associated with one or more with more than one schedule for more than one monitor. The following diagram depicts the types of relationships that monitors of the public APIs can have with their schedules, public locations, APIs, and environments. Each type of relationship is indicated with a unique line style. Here you can see API functional monitoring. Here you can see the monitors, schedules, and public locations are in API functional monitoring. and here the this API 1 to 7 are here, are in environment A in here, and the API 8 is in environment B in this diagram, and environments are in environment A and environment B are in Cloud Hub, and API 9 and API 10 are in World Wide Web here in this diagram. Monitor one's relationships indicated with solid black arrows. Single schedule, single location, single environment. Monitor one runs on a single schedule, schedule A, which is associated with the public location 1. The monitor is written to the test 1 or more endpoints in the public API 1 and public API 2. Although it could be, it could also test endpoints in the more public APIs. 2 APIs are in a single environment, environment A. Monitor 2's relationship ships indicated with dash line, green arrows. Multiple schedules, single location, single environment. Monitor 2 runs on 2 separate schedules, schedule B and schedule C, each of which are associated with the same public location 1. Monitor 2 is written to the test 1 or more endpoints in public API 3 and public API 4. Although it could also test endpoint in more public APIs. The 2 APIs are in a single environment, environment A. Monitor 3 runs on 2 separate schedules, schedule D and schedule E, each of which is associated with the different public location 1 and public location 2. Monitor 3 is written to test more than one, test one or more endpoints in public API 5 and public API 6. Although it could also test endpoints in more public APIs. The 2 APIs are in a single environment, environment A. Monitor 4's relationship indicated in dotted orange arrows. Multiple schedules, multiple environments. Monitor 4 runs on 2 separate schedules, schedule F and schedule G. Each of the schedules is associated with the same public location 2, although each could be associated with the different public locations. Each of 2 tested public APIs is in the different environment A and environment B. One environment could be test environment, and the other environment could be a production environment where public API 7 and public API 8 are copies of the same API. Monitor 4 is written to test one or more endpoints in public API 7 and the same endpoints in public API 8, although it could also test endpoint in more public APIs. Monitor 5's relationship indicated with dark blue arrows. Test APIs in Cloud Hub 1.0 environment and on the web. Monitor 5 runs on a single schedule, schedule H, although it could run on multiple schedules. The schedule is associated with the public location 2. Monitor 5 is written to test one or more endpoints in public API 9 and public API 10, although it could also test endpoints in more public APIs. Both APIs are accessible on the web. Here you can see the types of relationship that monitors of private APIs can have with their schedules, public locations, APIs, and environments. Each type of relationship is indicated with a unique line style. Here you can see monitors and schedules are in API functional monitoring, and here the private locations and private here the private location 1 to 4 and APIs 1 to private APIs 1 to 7 are in environment A, and here the private location 5 and private API 8 and 9 are in environment B. Here environments are in A and B are in any point virtual private cloud, and any point virtual private cloud is in Cloud Hub, and here public API 10 is in World Wide Web. Here the monitor one's relationship indicated with the solid black arrows. Single schedule, single location, single environment. Monitor 1 runs on single schedule, schedule A. The schedule is associated with the private location 1. The monitors is written to test one or more endpoints in the private API 1 and private API 2, although it could also test endpoint in more private APIs. The private location and the APIs are in a single environment A. Monitor 2 runs on two separate schedules, schedule B and schedule C, and each is associated with the same private location 1. The private location is shared with the schedule that runs monitor 1. Monitor 2 is written to test one or more the endpoints in the private API 3 and private API 4, although it could also test endpoints in more private APIs. Private locations and APIs are in a single environment A. Monitor 3's relationship indicates relationship indicated with the dash and dotted light blue arrows. Multiple schedules, multiple locations, single environment. Monitor 3 runs on two separate schedules, schedule D and schedule E, and each is associated with different private locations. Private location 2 and private location 3. Monitor 3 is written to test one or more endpoints in API 5 and API 6. Although it could also test endpoints in more private APIs. The private locations and the APIs are in a single environment A. Monitor 4 force relationship indicated with dotted orange arrows. Multiple schedules, multiple environments. Monitor 4 runs on two separate schedules, schedule F and schedule G, and each is associated with the different private locations. Private location 4 and private location 4 and private API 7 are in environment A, and private location 5 and private location and the private API 8 are in environment B. One environment could be test environment, and the other environment could be a production environment. Where private API 7 and private API 8 are copies of the same API. Monitor 4 is written to test one or more endpoints in the private API 7 and the same endpoint in private API 8, although it could also test endpoints in more private APIs. Monitor 5 is 5's relationship indicated with the solid violet arrows, test private and public APIs. Monitor 5's run on the one schedule H, although it could run on multiple schedules. The schedule is associated with the private location 5. Monitor 5 is written to test one or more endpoints in private API 9 and public API 10. Private locations 5 and private API 9 in environment B, and public API 10 is on the web. Here you can see the API functional, the component of a monitor in API functional monitoring. API functional monitoring enables you to monitor responses and requests sent to API resources and their endpoints. The monitor's API, monitor APIs by you monitor APIs by accessing the functional monitoring section in endpoint monitoring, which you select from the home page of endpoint platform. Functional monitoring section contains tools for creating and editing monitors. Additionally, you can upload test suites written in BAT and a behavioral development language. The following image illustrates the component of a monitor. A monitor includes test and one or more schedules for running test. Monitor test includes the following: endpoints to verify, optional assertions to verify at the endpoint, for example 200 status code, optional HTTP headers to include when sending requests to the endpoints, optional tools such as Sumo Logic or Slack used to send test reports. A monitor test schedule includes following: location from which to run the test. Location can be public or private. Time interval between tests. Here you can see a monitor, and test and schedule are in monitor. Endpoint, sessions, headers, and reporters are in test. Location and interval are in schedule. Here you can see the functional monitoring page with the monitor selected here in API functional monitoring. Here the duration of the test for selected monitor. Here the daily average response time. In milliseconds of all tests to all endpoints. Colors in each bar indicate the breakdown of the average time for each steps in a test. Hover over the bar to see the breakdown details. 3 here the schedule information, including when that next run is scheduled, the schedule interval, the information about location where the tests are scheduled to run. 4 here the details about the previous execution, including the method executed and assertions. 5 here the a summary list of last few executions. 6 here the option to add schedules to the selected monitor. The bar graph shows the daily average response time in milliseconds of all tests to all endpoints. Colors in each bar indicate the average time for each of the steps in a test. Hover over the bar to see the details. Here you can see a monitor name and here the test duration, average response time in milliseconds. Here the last executions, and here the schedule, and here the last test execution, and here the add schedule. Now we are considering the Size-based aggregator timeout and max size behavior diagram. To understand the aggregated module size-based aggregator scope timeout behavior, review the following diagram that explain how the timeout and max size fields work. Then learn how to configure these fields in Anypoint Studio and in XML editor in Mule applications. Example: this max size field indicates the total number of elements to be aggregated before considering the aggregation complete. Timeout field indicates the maximum time to wait for the aggregation to complete. The first process indicates that the aggregation is complete because the total aggregated elements reach the number of required before timeout occurred. The second process indicates that the aggregation is not complete because the total aggregate element did not reach the number of required before the timeout occurred, which causes the aggregation reset. The third process indicates that you can use aggregator listener source to capture the elements that were aggregated before the timeout occurred. The source triggers when the timeout occurs. If you choose to use aggregator listener source to capture incomplete aggregation elements, you must select the include timeout group field to indicate that the source is triggered when the timeout occurs. Here you can see a size-based aggregator and aggregator listener. Here the incremental aggregation and aggregation complete and aggregation is not complete inside the size-based aggregator here. Here the incremental aggregation is connected to the two aggregated elements reach max size before timeout occurs, and if it is yes, it is connected to aggregation complete. If it is no, it is connected to aggregation is not complete. Aggregation is reset, and here the aggregator listener is connected to size-based aggregator. Here you can see any circuit breaker states in Anypoint MQ subscriber source in Anypoint MQ connector. Circuit breaker has three states: closed, open, and half open. The behavior of the app changes based on the current state. Closed, the starting stage where the subscriber source retrieves messages normally from the MQ based on its configuration, effectively working as if the circuit breaker is not present. Closed open transition, when the number of failures occurs in session during messaging processing without success and reaches error threads value, the circuit breaker trips and circuit breaker transits to an open state. Messages that were already dispatched to the flow then finish processing regardless of whether the result is success or failure. Messages kept locally that are in flight for the broker but haven't been dispatched yet are not acknowledged and returned to the queue for redelivery to another consumer. Open, subscriber source doesn't attempt to retrieve messages and skip the iterations silently until trip timeout is reached. Half open, after trip timeout elapses, the subscriber source goes to a half open state. In the next poll for messages, the subscriber source retrieves a single message from the service and uses that message to check if the system has recovered before going back to the normal close state. When the subscriber source successfully fetches a single message, dispatches it to the flow and processing finished successfully. Subscriber source returns the normal and immediately attempt to fetch more messages. If the mule flow fails with one of the expected error types, the circuit goes back to an open state and reset the trip timeout timer. Here you can see start is connected to close, normal retrieval and processing of messages based on the subscriber strategy. Close is connected to open via errors count greater than or equal error threshold. Open, here you can see open, schedules messages fetch are skipped and no more messages are processed. Here open is connected to half open via trip timeout evicted, and half open is connected to open via single message failure. Here the half open retrieve a single message that and attempt to process it. Half open is connected to closed via single message success. Here you can see get auth access token in HTTP connector. The auth2 authorization code configured the OAuth 2.0 authorization code grant type. The OAuth authentication server holds the resources protected by OAuth. For example, API calls to the GIT hub API can be authenticated through GIT hub server using OAuth. Note that HTTP connector supports only OAuth 2.0. Following example shows how to configure the OAuth 2 authorization code grant type authentication for the HTTP request operation by creating a Mule app to access a protected resource, GIT hub user data on the GIT hub OAuth authentication server. The example covers how to set up authorization, create Mule app, and run the Mule app. This example requires that you have a GIT hub account. Before you create a Mule app, review the following diagram here that show the procedure of getting OAuth access token and returning token for data. Here's step 1. Submit an HTTP request for GIT hub process GIT hub access to the client app. To client app redirect the request to the GIT hub authentication server. 3. GIT hub request the login credentials. 4. Login and author and log in and authorize the client app. 4. Login and authorize the client app. 5. The GIT hub authentication server returns an access token. 6. The client app listens for the next request. Here you can see GIT hub user interacts with the Mule client. Here the GIT hub user is connected to Mule client via request GIT hub access. Listen and request are in Mule client, and here the Mule client is connected to GIT hub AOAuth server via redirect GIT access request. Here user data is in GIT hub auth server, GIT hub login prompt here, and here the GIT hub auth server is connected to Mule client via return access token, and Mule client is connected to GIT hub user via listen for next request. GIT hub user is connected to GitHub auth server via login and authorize app. Here is step 1 and step 2 and step 3 and step 4 and step 5 and step 6. Here you can see a return token for data. Step 1, request the second user data using access token. Step 2, here the redirect user data request. Step 3, the client app gets the user data from the GIT Hub authentication server. And 4, the client app listen for next request. Here the GIT Hub user is connected to a Mule client via request user data, and listen and request are in Mule client. Here the Mule client is connected to GIT auth server via redirect user data request pass token. User data is in GIT Hub auth server. Here the GIT Hub auth server is connected to a Mule client via return user data, and Mule client is connected to GIT Hub user via listen for next request. Here you can see a setup authorization in HTTP connector. To set up the authorization, follow these steps. 1, register the client application on the authentication server. The authentication server assigns a client ID and the client secret to Mule app. The app uses these credentials to identify itself to an authentication server. During the registration, provide URL to the Mule app homepage and the application callback URL. Step 2, log in to GIT GitHub. Step 3, register the application in your GitHub personal settings. Step 4, on the register new auth application auth application page, complete these fields: application name, auth grant code, homepage URL http://localhost:8082, authorization callback URL http://localhost:8082/callback. 5, click register application. GitHub creates a page for registered application on https://github.com/settings/applications app number that includes the GitHub assigned client ID and client secret. Here you can see a setup GitHub user. GitHub user is connected to GitHub auth server via register app. User data is in GitHub auth server, and here the GitHub auth server interacts with the GitHub user via return client ID and secrets. GitHub user is connected to Mule client via configure app. Listen and request are in Mule client. Step 4, Mule client is connected to GitHub user via listen request. Here you can see Anypoint Studio app flow in HTTP connector. The following example has multiple flows, has each having an Anypoint connector for HTTP, HTTP connector listener source that listen request to different subpath. HTTP request directed to HTTP ://localhost 8081 accounts are routed to the first flow. HTTP request directed to HTTP ://localhost 8081 employee employee, for example, are routed to the second flow. HTTP requests that don't match the path defined in any of the HTTP listeners make the connector return to the HTTP 404 resource not found error, for example. To accomplish this, as an example, you must create a Mule app, configure the HTTP global element, run, and test the app with curl commands. The following screenshot shows the Anypoint Studio app flow for an example here. Here you can see method, attributes.method, post. Here you can see the path, method path colon method as attributes dot listener path. Here you can see the query parameters, attributes dot query param dot user. Here the attribute dot query param dot age, for example. Here you can see the full URI, attribute dot request URI here. Here you can see host colon localhost colon 8081. Here the host one colon attributes dot request dot host. Here the accept dash language colon en dash us. Here the headers, attributes headers accept language, for example accept dash encoding content dash type. Here the accept dash encoding here, colon gzip deflate. Here the content type colon application / x dash www dash form dash URL encoded. Here the body, here the body.payload.name. Here the age equal Aaron and ampersand age equal name equal Aaron and ampersand age equal 32. Here you can see a Windows gateway service for any point platform. The Windows gateway services agent perform protocol translation when calling the dynamic AX system services. The dynamic AX system services, metadata service, query service use the .NET TCP protocol, which is not implemented in Java. To execute request, the connector routes the request through the Windows gateway service as described below. Step 1, the connector send the HTTP request to the Windows gateway service. Services 2, Windows gateway services receive the HTTP request. 3, the Windows gateway service executes the request against the dynamic AX system services using net.tcp. 4, the Windows gateway services receive the response from the dynamic AX system services. 5, the Windows gateway service send the response to the connector over HTTP. The 6th, the connector receives the response. All connection between the anypoint platform and the Windows gateway services are authenticated and secured by SSL. Here you can see a dynamic AX connector is in MuleSoft in Linux or Windows or others. Dynamic AX connector is interacts with request router via HTTP. Request router is in Windows gateway services in Windows. Request router interacts with AOS services via net.tcp. AOS services are in Microsoft Dynamics AX in Windows. Here you can see a high-level diagram of the solution architecture in Microsoft MS MQ connector. You should be familiar with MSMQ, Mule runtime engine, Mule anypoint connectors, anypoint studio, Mule concepts elements in MuleFlow and global elements. You need to log in. You need login credential to test your connection to use connection to your target source. For software requirement and compatibility information, see the connector release notes in notes. Important install the Windows Gateway service before installing and configuring MSMQ. View the see also section in the documentation for a link to the Windows Gateway Services guide in Mule documentation. The following is a high-level diagram of the solution architecture. Here you can see the Mule and Jersey HTTP client is in JVM, and this is Mule runtime here in Windows, Linux. or Windows or others, runtime can interact with the MuleSoft Windows Gateway Service via HTTP, and ASP.NET Web API is in OWIN host, and OWIN host is in CLR. CLR is in Windows, and this is the MuleSoft Windows Gateway Service, and it interacts with MSMQ and in Windows. Here you can see the general network architecture for data graph. In data graph, Anypoint Data Graph is a fully managed service that runs on Anypoint platform within the default region of your business group. The following diagram shows the general network architecture for data graph. Consumer requests from the public internet are routed to Anypoint Data Graph through shared or dedicated load balancers depending on your Cloud Hub or Anypoint Virtual Private Cloud, Anypoint VPC configuration. Data graph sends the request to the underlying APIs that make up the unified schema. When you make changes to the Anypoint Data Graph UI, those changes trigger updates of Anypoint Data Graph in runtime plane. If you are unable to use port 882 on a shared load balancer, you must set a new URL for Anypoint Data Graph to use on a Cloud Hub dedicated load balancer, DLB. Here you can see the public internet is connected to option A, shared LB, and disconnected to Anypoint Data Graph via port 882. Here the public internet is connected to option B, dedicated LB, and it is connected to Anypoint Data Graph via port 8092. Here the Anypoint Data Graph option B, dedicated LB, API 1, 2, and 3 are in Anypoint VPC in this diagram, and Anypoint VPC option A, shared LB in runtime plane, Cloud Hub. Here the developer or integrator here, and the control plane is connected to Anypoint Data Graph. Anypoint Data Graph is connected to API 1, 2, and 3, and external API 1 and external API 2 in this diagram. Here you can see the structure in object type extension in data graph. The object type extensions, this extension marks an object type has a primary key and thus can be used as a reference for extension, reference or extension. This extension applies to object type. Here you can see the field entity and type map and marks an object type as an entity. Here the field entity.key, type is string, and an array that must not be empty. Each item must reference a field that is a key of the entity. Here you can see the structure in entity reference in data graph. Entity references, this extension generates a data graph link from the properties of one type to another type. The link can be to a type that is not defined in the same API spec. This extension applies to object type. You can see the field entity dash reference, the type an array of object, a list of all the references. Entity dash reference dot name is type string. The name of the type being reference may or may not be part of the API. entity dash reference dot array and dot field name, type string, the name of the new field that will be created for this type. Entity dash reference dot array dot key mapping, type map, the keys of the map represent the field of this type and the values represent the keys of the reference type. Here you can see the structure in entity provider in data graph. This extension marks an endpoint returns instances of an entity by ID. In data graph, this is the default query method. This extension applies to get operations. The target is not specified because it is implicit in the operation. The field you can see the entity dash provider, type map marks that this endpoint returns entity instances. Field the entity dash reference dot key mapping, type map, the keys of the map represent parameters of this operation and the values represent the keys of the target type. Here you can see the structure in HTTP method override in data graph. You can see the field HTTP dash method dash override, type map marks an operation to be overridden. Here the field HTTP dash method dash override dot method, type string, the HTTP method that will be used to override the original operation. Here you can see the structure in data graph specific extensions in data graph. Here the target is not specified because it is the implicit in the operation. Here the field data graph, type map, a container for data graph specific annotations. Here the data graph dot height, type boolean. If true, the element is hidden in the unified schema. If false, the element is not hidden, which provide the same result as not setting the annotation. Here you can see the structure in name in data graph. The name use this extension to set the desired name of an element in data graph, such as defining specific name for elements in the unified schema. You can also use this extension to federate types from different APIs without changing the underlying APIs. This extension applies operations any type object properties structure. The structure is not specified because it is implicit. The target is not specified because it is implicit in the operation. Here the field data graph, type map, a container for data graph specific annotations, data graph.name, type string, the desired name for the element in data graph. If possible, use the pattern for valid names. Here you can see features of the Flow Designer interface in Design Center. The Flow Designer's features are organized into 5 areas. The 5 areas of the Flow Designer interface. Canvas. Here you create flows in a project. In the top left corner of the canvas are the names of the project and the flow. To the panes, click the top icon to open the project pane, which lists the project flows, the configurations that are being used, and any global data types that have been defined. Click the bottom icon to open the dependencies pane, which lists the project's dependencies. You can hide the panes by clicking the icon of whichever pane is to open. To show the panes, again click either icon. What are the reusable configurations? When you add a card that connect to another system, you specify a Flow Designer can locate and authenticate that system. For example, if you add a database card to a flow, you need to specify the type of database, its host, and other connectivity information and how to authenticate it. The set of information is called configuration. After you add one database card, the next database card you add uses the same configuration by default. You can change it. In the project pane, the list of reusable configuration is the list of all the configuration that you have created in a project, and that can be used in additional card. What are the data types? Data types show the formats in which data are used in a flow. The local type of defined is within a particular card. The global type is defined for a project and can be reused in multiple cards. What are dependencies? A dependency is any connector, core Mule runtime component, API, or module that you use in flow. The first time you add one of those objects to a flow, you add the current version of it. Every time afterward that you use that object again in the flow, use the same version of it. From time to time, that object might be updated in exchange. If you would like your flow to benefit from the update, you can update the version of the object that you are using in your flow. 3 toolbar. Here you can undo, redo changes in a project. Download the project and change the zoom level of the canvas. The control bar. Here you can run the application for testing, as well as deploy the application to another environment. 5 the problems and logs. Click the first tab to see a list of any errors that are in a project. You can click the listed errors to open the location in which the errors occurs. Click the second tab to see the log file for a project. The file can be helpful when you are troubleshooting problems running an application. Here you can see create your first Mule application with the Flow Designer in Design Center. This is your approach. To automate this process, you have to overcome a few integration challenges. You come up with this list of what needs to happen in order to automate this order to cash cycle. First, Salesforce start the workflow automation process when a sales is made. This process is triggered in Salesforce when the opportunity is changed to closed won. To the process retrieve the appropriate product information from the products database. 3. After the process has retrieved the information, it places an order with NTO orders API. 4. The orders API returns the order number, tracking information, and ETA for delivery. 5. The information returned by the API is translated into human readable text and sent as an SMS to the customer. Visually, the process should look like this. Fortunately, you know just the tool to help you carry out this plan, Flow Designer. This is an example. Here the option close an opportunity is connected to trigger the process. It is connected to get product info from the database. It is connected to place the order by using the NTO order API. It is connected to return the order ID, tracking info, and ETA. It is connected to send SMS to the customer. Here you can see the connection that you create in Flow Designer is the set of information that Mule app must use to connect the system in Design Center. When you add the flow card that represent a connector, the Flow Designer requires that you specify your Mule app can connect that at runtime to the system that connector is for. For example, if you add a card that represents an instance of the database connector, Flow Designer opens the database configuration dialog. In that dialog, you can either select an existing connection to the database or create connection. A connection in the sense that Flow Designer uses the term is saved set of information that Mule apps need to connect to the system when app is running. The connection is not an open channel of the communication between the app and the system. It is the information that the app needs to use to open a channel communication with the system. A connection in the sense that Flow Design uses the term, the set of information that Mule app needs to open a channel of communication with the system. To the a connection in more common sense, an open channel of communication between two entities. A connector is used in a configuration to a connector. Configuration is saved a set of we will discuss configurations later. So here you can see the Mule app. It is connected to it interacts with system. Here the connection is used in a configuration for a connector. A configuration is saved set of data that includes the connection and specified various types of information depending on the type of connector that is the configuration is for. You can create and save one or more configuration for each type of connector. That you use in Mule app project. The relationships between connections and configurations and connectors are configuration connectors are depicted in the following diagram. In this figure, a connection, in this case a database connection, is used by a configuration which is itself used by an instance of a database connector in Design Center. You can create a pool of connections for each type of connector. In this diagram there is a pool of 3 connections. Through the ellipses dot indicate that it is possible for the pool to contain more connections. You can create pool of configuration for each type of connector. Each configuration uses a single connection. In this diagram, configuration config 1, this one, uses connection B, and configuration config 2, and configuration config 2 uses connection A. The ellipses indicate that it is possible to have larger pool of configurations. Each instance of a type connector uses a single configuration. In this diagram, the instance of database connector uses config 1, even though config 2 is also available. To give another example, you might have 2 instances of Salesforce connector in a Mule app. Each instance might use the same configuration, or they might use different configuration. Typically 2 configuration for a connector type, each use the different connection. There are 2 types of connection. Connection that can be used only within a single project, and a connection that can be shared with multiple projects and users. Here you can see connections, configurations, and connectors. Here connection A is used by config 2. Here the connection B is used by config 1, and config 1 is used by database connector. Here you can see the steps for adding a connector to a Mule. This flowchart shows steps for adding a connector to a MuleLab project. Creating a MuleLab project. A connection is saved at connection is saved a connection is a saved set of information that a running Mule app must use to connect to a specific system by means of a connector. You might create a connection as part of adding a connector to a flow. Here you can see this flowchart shows information steps to adding a connector to a MuleLab project. Creating a connection can be included in those steps. One, when you add the connector to a flow, you create configuration, which is a set of information that include the connection. If a configuration exists that you use it, that you can use, then you can simply select it. However, if no configuration existed, the connector, net for the connector, and if no existing configuration fits your use case, then you must create a configuration. Part two, part of creating a configuration is specifying which connection the connector must use to connect to a system. When then you can simply select it. However, if no configuration exists yet for the connector, or if no existing configuration fits your use case, then you must create the configuration. Here the part two, part of creating a configuration is specifying which connection the connector must use to connect to a system when your Mule app is running. Three, then when the dialog for creating configuration is opened, it presents list of connections. If any connection already exists for this type of connector, the dialog also enables you to create a connection. For example, if you are adding an instance of a database connector, the flow designer opens the database configuration dialog. This dialog presents a list of connections to databases. If any connections already exist for this type of connector, the dialog also enables you to create a connection to a database. For the if you click Add Connection button to create a connection, you return to the configuration dialog for the connector to specify values for the field in the advanced section if you need to do so. So here you can see the start is connected to add the connector to a flow. Add the connector to a flow is connected to select the operation to use the connector for, and it's connected to does a configuration exist, and if exist, it is gonna then move to use the existing configuration, and it is connected to stop. And if the configuration does not exist, then move to create the configuration. Then create a configuration is connected to start, and start is connected to does a connection exist. If the connection exists, select a connection, and select a connection is connected to stop. And if the connection does not exist, create a connection, and it is connected to stop, and stop is connected to create a configuration. Create a configuration is connected to stop. In this diagram, this diagram depicts the switch from config 1 to config 2. In Design Center, every connector that you include the flow in a Mule app project uses a connection to connect to a system. A connection is saved set of information that a running Mule app must use to connect to a specific system by means of a connector. For example, if you configure a Salesforce connector to use a specific connection to a Salesforce, instead of database connector, use the specific connection to a database. You can change the configuration to use a different connection, or you can create a new and use a new user configuration that uses a different connection. For example, suppose that you add the instance of a database connector. When you create configuration config 1 for it, and you create connection to MySQL to specify the information that your Mule app needs to connect to the MySQL database at runtime. Now you want to test your Mule app against an Oracle database. Because of the configuration for the Oracle database required not only a separate connection but also different additional information, you create the configuration config 2 and the connection Oracle. Then you switch to using config 2. Here you can see connections, configurations, and connector. Here MySQL is used by config 1, and it's connected to database connector. And here the Oracle is used by config 2, and it's used by database connector. And now you have switched. Now you have switched it to config 2. You can switch connections in a configuration in this Design Center. This diagram, in this diagram, the instance of database connector is using the configuration config 1, which uses the connection MySQL 1. If you want to switch to a different MySQL database and connecting to the database does not require any differences in the information that configuration provides, you can simply change the configuration to use the connection MySQL 2. Here you can see connections, configurations, and connector. Here the MySQL 1 was connected to config 1. Now here now we switched it to MySQL 2, and is used by config 1, and config 1 is used by database connector. Here you can see a choice of card being used in a flow. You can add cards to perform variety of tasks to change the course of a flow, log messages, data, transform data, add or remove data variables or payloads, and more. These cards represent the component of Mule applications and are provided by Mule runtime. Here the choice, if you want a flow to evaluate data to determine which route among several to send the data to, use the choice components. This is a choice card being used in a flow. Here a card passes its output to a choice card. The card uses an expression to evaluate the data and follows this logic. If data is X, the card routes the data to one subflow. If the data is y, the card routes the data to a different subflow. If the data is a default value that you set in the card, the data is routed to a default subflow. To the output of the subflow is sent to the card that follows the choice card. Here card 1 is connected to card 2, card 2 is connected to choice, and choice is connected to card 3, and card 3 is connected to this. Here you can see this diagram represent the flow in which for each component is used. The rounded rectangles are cards. For each component is for processing each element in a collection serially, and then proceeding in a flow with the original payload that was passed to for each component. A card uses the payload of a flow for each component. The payloads consist of a collection of elements. For each component divides the collection into separate elements. It then sends each element serially to the first component connector or module that is in its scope. Each element is treated as a payload within the scope. So if a connector within a scope is configured to act on a payload or uses a script to process payload, the payload is not the payload that the for each component received, but the element that the component is processing. 3. After the final element is processed, for each component passes the payload that it received from the previous card to the next card in the flow. For the next card in the flow receive the same payload that the for each component received, and the flow continues. Here you can see a card is connected to for each component via payload, and for each is connected to this card here via in scope payload, and for each component is connected to this card via payload. Here you can see this diagram represent a flow in which the parallel for each component is used. The rounded rectangles are cards. The parallel for each component is for processing each element in a collection and then passing the result to the next card in the flow. A card passes a payload of a flow to the parallel for each component. The payload consists of a collection of elements. A parallel for each component divide the collection into separate elements. It sends elements simultaneously to the first component connector or module that in its scope. You can specify maximum number of elements to process at a time. Each element is treated as a payload within the scope. So if a connection within the scope is configured to act on payload or use a script to process payload, the payload is not the payload that the parallel for each component received, but the element that the component is processing. After all the element is processed, the parallel for each component aggregates and passes the result of the processing that was done within its scope. The results from the payload that is passed to the next card in the flow. The next card in the flow receives the result from the parallel for each component, and the flow continues. Here the card is connected to parallel for each component via payload, and parallel for each component is connected to other card via parallel inner scope payloads. And here then the parallel for each component is connected to the next card via payload. Here the parallel for each component and this card are in the scope for the parallel for each component. Here you can see a scatter gather card that includes the minimum of 2 routes. with the scatter gather card, you can send a message through more than one set of cards simultaneously, collect the result from each set, and pass those results along with the original message to the next card in the flow. Any card pass messages to the scatter gather card. The card that passes messages can be the trigger of the current flow or any other card in the flow. To the scatter gather card is displayed in a larger rectangle that is called the scope of the card. Within this scope are two or more sets of cards, each set called root. The scatter gather card processes all root at the same time, and the roots are all independent of each other. Each root can have one or more cards. When all roots are finished for processing data, the results from the roots are included in a payload of the original message. The received message is passed to the next card of the flow. The message that move through a flow have this general structure: payload, attributes, and vars. After message leaves the scatter gather card that contains two roots, the message has a new sub payload for each root: payload 0, payload 1, payload, attributes, vars. Here you can see card is connected to scatter gather card. Scatter gather card is connected to card in root 0. Here this card is connected to this card, and here the and scatter gather card is connected to a card in the root 1, and the last card in the root 0 is connected to card here, and the card in the root 1 is connected to card here, and these two cards are in the root 0 and this card is in the root 1. Scatter gather card, root 0, root 1 are in the scope of the scatter gather card. Here you can see this is the flow that creates a CSV file aggregating the contacts from the two Salesforce organizations. In this example, HTTP listener triggers the flow when it receives a request. The scatter gather card initiates two routes that retrieve the list of contacts of two Salesforce organizations. The scatter gather card combines the payload from each instance of any point connector for Salesforce connector to into a single payload. This payload is stored in a variable that concatenate the result of two queries. Finally, the fields in the concatenated results are mapped to a data type that creates a CSV file. Here the an HTTP listener card for triggering the flow. 2, the scatter gather card with two roots, each root consisting of an instance of Salesforce connector. The instances query different Salesforce organizations. 3, a set of card for storing the concatenated query result from the scatter gather card in a variable. 4, a transform card for mapping the fields in a variable to the fields in the CSV file. Here you can see HTTP listener / generate report is connected to scatter gather, and it has two roots: Salesforce connection query on org A and then route 2 Salesforce connection query on org.b, and scatter gather is connected to set variable sg payload, and set variable is connected to transform data view. Here you can save data in one or more variables that one or more routes can use. If you want a route to act on only part of the message, you can store what you need for the route in a variable before message reaches the scatter gather card, or at the beginning of the route. The following configuration is useful if your variables need to be used in more than one route. In this case, the first card in each route receive the same message, which might have these parts if you create two variables before scatter gather card. Payload attributes was var1, var2. Here the card is connected to one or more set variables cards. One or more set variable card is connected to scatter gather card, and scatter gather card is connected to cards in card in route 0, and it is connected to another card, next card. Then scatter gather card is connected to card in route 1, and last card in route 0 is connected to card here, and the card in route 1 is connected to card here. Scatter gather card, route 0 and route 1 are in scope of the scatter gather card. The following configuration, here you can see you can save data in variable that is used by only one route. The following configuration is useful if your variables need to be used only one single routes. Suppose that you create var1 and at the start of your route, and you create var2 at the start of your second route. Then the second card in the first route receives a message that has three parts: payload, attributes, was, var1, and the second card in the route second route receives the message that has three parts: payload, attributes, was, var2. In both of these here the final card could be a transform card, which might require you to know how to write script in data view, or another set variable card that as in the example about aggregating contacts, combine somehow the result from the roots in this scatter gather card and then passes the variable to another card, such as transform card. Here card is connected to scatter gather card, and it is connected to set variable card in route 0, and it is connected to card, it is connected to another card, and the last card is connected to card here. And here the scatter gather card is connected to set variable card in route 1, and it is connected to the next card, and that card is connected to card here. Scatter gather card, route 0 and route 1 are in the scope of the scatter gather card. Here you can see a flow ref card referencing one flow from the main flow. By placing a flow ref core component in a flow, you can run one flow from the another within the same application. When the ref flow is reached in a flow, it triggers the reference flow. The reference flow runs and returns the mule event object to the original flow when the execution proceed after the flow ref component. Flow ref is handy for reusing groups in components within the same mule application. Here first the trigger card starts the main flow. To the flow ref card passes the output from the second card to the first card in the reference flow, trigger that flow. 3. The last card in the reference flow passes its output to the card that comes after the flow ref card in the main flow. 4. This card process the output, create its own output and continues the main flow. Here you can see the main flow and here the reference flow. In main flow, card 1 is connected to card 2, card 2 is connected to flow ref, and flow ref is connected to card 3 in reference flow, and card 3 is connected to card 4 is connected to card 5 in reference flow, and card 5 is connected to card 6 in the main flow, and card 6 is connected to the next card. Here you can see here the custom data type output by card A matches the custom data type that card B requires. So the card B can immediately follow the card A in the flow. A card in a flow that might require that the data that is sent to it use the custom data type. If the output of the previous card uses the different custom data type, you must map the element of the previous card's custom data type to the element of the custom data type of the next card requires. For example, suppose that the flow contains card A and card B, and that the card B follows card A. If the output of card A uses the same custom data type that card B requires for its input, then you do not need to map the output of a card A to the input of the card B. Here you can see card A and card B, and this depicts the data types, and here card A is connected to card B. The custom data type of the output of card A does not match the custom data type that card B requires. Therefore, you must use the transform card to map elements of card A to the element in the required input card B. However, if the custom data type do not match, you must use the transform card to map element in the custom data type output from the card A to element in the custom data type required by the card B. Note, if the both cards were using simple data types, then either of these two scenarios are possible. If card A output data that use the simple data type such as string, number or date, and card B require data to be in a simple data type, no mapping would be required. If card A's output data that is use a simple data type and card B requires the data to be in a different simple data type, card B could not follow a card A. So no mapping between data types would be possible. If the only one card used simple data type and the other used a custom data type, then these two scenarios are possible. If card A output data that is used in simple data type and card B required data to use the custom data type, no mapping would be possible unless the custom data type for card B had only one element that was the same simple data type. For example, suppose the card A output a string and card B required input in this custom data type A : string. In this case, you could map the string output from card A to the element A in the custom data type required by card B. However, suppose the custom data type for card B were one of these two types, A number, A string, B number. The only element in the custom data type example uses the number data type in the example for one example, and the string cannot be mapped to number. If the custom data type in the second example, if the third example there are two elements, because the string that example is A string and B number, because the string from the card A can map the only to element A, and element B would be left without a value. Because the card B requires a custom data type, all of the element in it must contain data, so you could not map the string from card A to this custom data type. If the card A outputs the custom data type and card B required data to use simple data type, it might be possible to map an element from custom data type to the simple data type. The element would need to use a simple data type. For example, suppose card A output data that use the custom data type in example 3. If card B requires the input data to be a string, you could map element A to the input card B. Mapping would also be possible if card B requires input data to be a number. However, card B required input data to be a date or some other simple data type. Mapping this case would not be possible. Here you can see card A and here card B, and card A is connected to transform card, and transform card is connected to card B. Here you can see an ordinary flow contrasted with the flow in which a set variable card is used. You can use set variable card to create a variable that stored all of the output from a preceding card, stores part of the output and manipulate the output card using functions in the data view expression. You can then reuse the value in a later card by using a variable. Normally, a card output data that is received entirely by the next card in the flow, as depicted by the first flow in the diagram. The first flow carries out these steps. One, the card A produces an output. Card B receives the entire output from the card A. However, when you create a variable with the set variable card, both the variable and the output from the previous card are passed to the next card in the flow. As the second flow depicts here. One, the card A produces an output. Two, the set variable card create a variable to store all the output from card A, store part of the output, or manipulate the output by functions in the data view expressions. Card B receives the entire set of data from the card A, payload and attributes and the variable. The output its own data output its own set of data and the variable. Output from the card A, except for the part that was stored in the variable, is no longer part of the flow. For the card C received the entire set of data from card B and the variable. Here you can for example, here you can see card A is connected in the first flow. Card A is connected to card B via output from card A. The second flow, you can see the card A is connected to set variable card via output from the card A. Set variable card is connected to card B via output from the card A and variable. Card B is connected to card C via output from the card B and variable. Here you can see an ordinary flow constructed contrasted with the flow in which the card outputs to target variable. You can store a value that is based on the output of a card, that is entire output as part of the output or manipulation of the card of the output, and then pass that variable into the next card together with the output from the previous card. Normally a card outputs that is different from the data that is received as input, as depicted by the first flow in the diagram. The first flow here the first flow carries out these steps. One, the card A produces an output, and card B receives the entire output from card A. However, when you create a large variable, when you create a target variable, the flow changes as depicted in the second flow in the diagram, which carries out this step. Card A produces an output, card B receives the entire output from the card A, and it stores its own output in a variable, and then passes the variable and the output from card A to card C. Card C receives the output from card A and the variable that contains the output of card B. Here you can see the first flow. Card A is connected to card B via output from card A, and card B is connected to card C via output from card B. Here the second flow, card A is connected to card B via output from the card A, and card B is connected to card C via output from the card A and variable V variable. Here you can see the manage asset cycle status. In the software development life cycle, the assets are developed, released, and eventually deprecated, and each exchange asset version moves through these life cycle states of development, stable, and deprecated. Deployment state. An asset version in the deployment state is an iterative process of design and development. If you republish an asset version in the development state with the same group ID, asset ID, version GAV, and new metadata, the asset version is overwritten, including following version metadata, files, dependencies, keywords. Change in this information for an asset version in any other state requires creating a new version, which prevents republishing or overwriting the asset version. Overwriting an asset version also updates the search index. Following information is not overwritten when republishing an asset in the development state. Asset type, tags, categories, custom fields, documentation pages. Deleting an asset version in the deployment state is always hard delete, enabling you to reuse the asset name, group ID, asset ID, and version. The public portal does not show the asset version in the deployment development state. Anypoint platform products other than Exchange, such as Anypoint Flow Designer, Anypoint Studio, or Anypoint Data Graph, do not consume asset versions in the development state. Stable state. An asset version in the stable state is ready to be consumed. The asset cannot be republished or overwritten. Deleting an asset version in the stable state in the first 7 days is a hard delete, enabling you to reuse the asset name, group ID, asset ID, and the version. Deleting an asset version in the stable state after the first 7 days is a soft delete, preventing you from reusing the asset's name, group ID, asset ID, and version. After a hard delete or soft delete, asset cannot be recovered. The Exchange backend and some API responses use the term published to mean the stable, mean the stable. Deprecated state, an asset version is deprecated state is similar to an asset version in the stable state. The only difference is that the status property shows the asset version is deprecated. Here you can see the states, development state, stable states, and deprecated state. Here you can see Flex Gateway architecture in Anypoint platform gateway. Anypoint Flex Gateway is an NOI based ultra-fast, lightweight API gateway designed to manage a secure API running anywhere. Built to seamlessly integrate with DevOps and CI/CD workflows, Flex Gateway delivers the performance required for the most demanding applications and microservices while providing enterprise security and manageability across any environment. Flex Gateway architecture. The Flex Gateway comprises two components that work in tandem: control plane and runtime. Following graphics diagrams the relationship between these components. Control plane. The control plane is the Mule hosted platform that centralizes the management and observability, enabling you to build APIs, add policies, deploy APIs into runtime, monitor APIs in Anypoint API Manager, configure runtime in Anypoint Runtime Manager. Runtime. The gateway runtime is customer hosted distributed entity installed in any cloud data center or testing purposes on your local laptop. The runtime receives command from the control plane and routes and protects the backend APIs. Built with security in mind, Flex Gateway secures the communication between the runtime and the runtime and the control plane through MTLS and HTTPS. FluentBit implementation enables log output to local files or to aggregators such as New Relic, Sumo, Logic, and Splunk. Replicas. A runtime unit is called a replica. While a single runtime can support multiple backend APIs for high availability, it is best to deploy Flex Gateway as a cluster with multiple replicas running in parallel. Using clusters increase gateway performance and robustness, and it is recommended for high performance applications that must scale. A single Flex Gateway can support multiple backend APIs. To support more backend APIs, you can deploy multiple replicas or additional Flex Gateways. Increase replica CPU and memory for higher throughput and increased performance. You can configure an optional external RAID storage for features such as distributed rate limiting and distributed caching. Gateway replicas use the RAID storage as a scratchpad to coordinate rate limiting across multiple replicas, so customer SLAs are adhered to. Here you can see UDP, UMPM deployer, runtime manager, API manager, and monitoring are in MuleSoft hosted control plane. Runtime manager client and policy engine are in Flex controller, and policies are in NY proxy. Flex controller, NY proxy, and FluentDB are in cluster hosted Flex Gateway runtime replica. Here APIs are in backend. Here you can see the custom consumer applications are connected to NY proxy, and NY proxy is connected to backend services. Here the UMP deployer interacts with client runtime manager client via secure WebSocket MTLS. Here the runtime manager interacts with policy engine via secure WebSocket MTLS 443. Here one-way initiated MTL connection. Here API here the policies are connected to API manager via REST pull HTTPS 443. Here the fluent bit is connected to monitoring via REST pull HTTPS 443. And here the policy engine is connected to envoy proxy, and policy engine is policies are connected to policy engine. Envoy proxy is connected to fluent bit. Fluent bit is connected to New Relic, Sumo Logic, and Splunk via fluent bit supported output. Here you can see the here you can see the all traffic is inside an organization owned network in standalone deployment in Flex Gateway, in any point platform gateway. In a standalone deployment, Flex Gateway acts as a standalone service that protects one or more integration APIs, API flows by managing internal traffic. As the following diagram shows, the all traffic is inside an organization-owned network. The traffic passes through Flex Gateway before reaching the consumer APIs. Here you can see Flex Gateway and APIs and consumer applications are in organization-owned network. Here the consumer applications are connected to Flex Gateway. Flex Gateway interacts with APIs, and Flex Gateway interacts with any point platform. Here you can see ingress. Here you can see all external traffic passes through Flex Gateway before reaching the consumer API. In ingress deployment in Flex Gateway, in any point platform gateway. Similar to standalone deployment, in an ingress deployment, Flex Gateway acts as a standalone service that protect one or more organizations' API flows. However, in ingress deployment, in ingress deployment, Flex Gateway manages the external traffic entering the internal network. Ingress deployment is the most common deployment model. Flex Gateway can act as both ingress and egress gateway. As of the following diagram shows, the all external traffic passes through Flex Gateway before reaching the consumer APIs. Flex Gateway is typically deployed behind the load balancer, and consumer application does not belong to the same network as Flex Gateway or APIs. Note: ingress deployment is not the same as Kubernetes ingress controller or ingress resource. For more information about routing configuration, see the routing configuration methods in the documentation. Here, consumer applications are connected to L4 load balancer. Here, the Flex Gateway, L4 load balancer, and APIs are in organization-owned network. Here the consumer applications are connected to L4 load balancer. L4 load balancer interacts with Flex Gateway. Flex Gateway interacts with the APIs, and Flex Gateway interacts with the Anypoint platform. Here you can see the all internal traffic from the consumer applications passes through the Flex Gateway before reaching to the external APIs. In egress deployment in Flex Gateway, in Anypoint platform gateway, egress deployment is the opposite deployment model of an ingress deployment. Flex Gateway still acts as a standalone service that protects one or more integration API flows. However, in an egress deployment, Flex Gateway manages internal traffic exiting the internal network. For example, API requests to non-organization owned APIs. Flex Gateway can act as both ingress and egress gateway. As the following diagram shows, all internal traffic from the consumer application passes through the Flex Gateway before it's reaching the external APIs. Here you can see consumer applications are connected to the Flex Gateway. Flex Gateway interacts with the APIs here, external APIs. Here Flex Gateway and consumer applications are in organization-owned network, and here the Flex Gateway interacts with Anypoint platform. Here you can see the traffic in a sidecar deployment process through Flex Gateway to the respective consumer APIs in sidecar deployment in Flex Gateway, in Anypoint platform gateway. In the sidecar deployment, each Flex Gateway deployment only protect the API exposed by each protected service. Then a new Flex Gateway replica is added with each new protected service. As the following diagram shows, the traffic in a sidecar deployment passes through Flex Gateway to the respective consumer API. The consumer application can belongs to the same network as a Flex Gateway or an external network. Here you can see the consumer applications interacts with Flex Gateway. Here this Flex Gateway interacts with API 1, and Flex Gateway interacts with Anypoint platform. Here the consumer applications interacts with this Flex Gateway, and this Flex Gateway interacts with API 1, and Flex Gateway interacts with Anypoint platform. Here Flex Gateways and APIs are in organization owned network. Here you can see integration use cases in Flex Gateway, in Anypoint platform gateway. The following integration use cases are determined by the ownership of the API provider and API consumer. Each use case shows physical patterns that demonstrate the necessary services in the system. For the following use case diagrams, Flex Gateway is running in the connected mode. However, you can also run Flex Gateway in a local mode or use combination of connected mode and local mode for separate runtimes in the same or different environments. The use case diagrams use Kubernetes terminology, but you can extend the architecture to other terminology stacks that have the appropriate network controls applied. Flex Gateway supports the 4 use cases. Use case 1, organization owned API exposed to an organization owned API consumer. Use case 2, organization owned API exposed to non-organization owned API consumer. Use case 3, non-organization owned API exposed to an organization owned API consumer. Use case 4, non-organization owned API exposed to a non-organization owned consumer. Each use case supports different integration patterns that vary depending on the location of API related to the network in which the Flex Gateway is located. You can use the different use case patterns depending on the different API owners and the network in your system. In each use case, there are 3 different classification of networks. Classification describe the relation of each network to your organization and network that Flex Gateway is in. Organization internal networks owned by your organization and network owned by your organization and in the same network as a Flex Gateway. Organization external trusted networks external to your organization but in a different network than Flex Gateway. For example, your organization's Splunk instance. Non-organization external network untrusted by your company and in a network as a Flex Gateway. An API provider or API consumer's network status affect the necessary security protocols MTLS you can take when communicating between networks. If an API provider or API consumer is organization owned, it belongs to either the organization internal network or its external networks. The following use case 1, organization owned API exposed to an organization owned API consumer. Use case 1, the organization owned API exposed to an organization owned API consumer. Pattern 1A, organization internal API exposed to an organization internal consumer that uses the same VPC or network as an API. Role of the Flex Gateway is ingress. Pattern 1B, organization internal API exposed to an organization internal consumer that uses different VPC or network API. Role of the Flex Gateway is ingress. Pattern 2, organization internal API external exposed to an organization external consumer. Role of the Flex Gateway is ingress. Pattern 3, organization pattern 3, organization external pattern 2, organization internal API exposes to an organization external consumer. Role of the Flex Gateway ingress. Pattern 3, organization external API exposed to an organization internal consumer. Role of the Flex Gateway egress. Pattern 4, organization external API exposed to an organizational external consumer. Role of the Flex Gateway is ingress and egress. Use case 2, organization owned API exposed to an non-organization owned API consumer. Pattern 5, organization internal API exposed to an non-organization external consumer. Role of the Flex Gateway ingress. Pattern 6, organizational external API exposed to organization to an non-organization external consumer. Role of the Flex Gateway ingress and egress. Use case 3, non-organization owned API exposed to an organization owned API consumer. Pattern 7, non-organization external API exposed to an organization internal consumer. Pattern 8, non-organization external API exposed to an organization external consumer. Role of the Flex Gateway is ingress and egress. Use case 4, non-organization owned API exposed to an external non-organization owned API consumer. Non-organization external API exposed to a non-organization external consumer. Here you can see providers, and here you can see organization owned, and here non-organization owned. Here you can see providers and consumers. Systems of record is connected to stream processing. Stream processing is connected to systems of engagement and systems of insight and systems of engagement insight. And AI or machine learning is connected to systems of engagement and systems of insight. The providers is connected to use case 1 org owned API exposed to org owned API consumer, and it is connected to consumers in organization owned. And here the providers, organization owned providers is connected to use case 2 org owned API exposed to non-org owned API consumer, and it is connected to non-org consumers in non-org organization owned. And here the in consumers in organization owned, you can see the mobile, web, client apps, telephony, chatbot. Here you can see providers in non-organization owned, third party, social, IoT, SaaS, B2B ED, B2B EDI, or SFTP. And providers are connected to use case 3 here, the non-org owned API exposes to org owned consumer, and it is connected to consumers in organization owned. And here the providers in non-organization owned is connected to use case 4 non-org owned API exposed to non-org owned API consumer, and it is connected to non-org owned consumers in non-org owned. And here you can see the use case 1, use case 2, use case 3, use case 4, and use case 4 are in API platform here. Here you can see organization's internal API. Organization internal API exposed to an organization internal consumer that uses the same VPC or network. In this use case pattern, both services are available on the same infrastructure, such as same public cloud VPC, such as a public cloud VPC data center or Kubernetes cluster. You can deploy Flex Gateway as either a sidecar or a standalone gateway. Here you can see the standalone gateway mode. Here the consumer applications are connected to Flex Gateway. Flex Gateway interacts with APIs, and Flex Gateway consumer applications and API are in organization owned network. Flex Gateway interacts with any point platform. Here the consumer applications and Flex Gateways and APIs are in organization owned network. Here consumer applications interacts with Flex Gateway here, and Flex Gateway interacts with API here, API 1 here, and Flex Gateway interacts with any point platform. Here the consumer application interacts with Flex Gateway here, and it interacts with API, and it interacts with the any point application here in sidecar mode. Here you can see the organization internal API exposed to an organization internal consumer that uses the same VPC or network in pattern in Flex Gateway reference architecture in any point platform gateway. The following diagram shows the physical implementation of standalone Flex gateway running in the connected mode. The network policy netpol permits ingress access only from Flex gateway. You can configure the consumer application in the same or different namespace from Flex gateway and other provider services. Here you can see in K8's cluster, consumer applications, load balancer, Flex gateway, service 1 load balancer, service 2 load balancer, and APIs and netpol protected K8 services are in K8 cluster. Here you can see consumer applications interacts with the load balancer. Load balancer interacts with Flex gateway. Flex gateway interacts with service load balancers, and service load balancers interacts with the APIs, and API interacts with the netpol protected K8 service. And here the Flex gateway interacts with the firewall, and firewall interacts with the anypoint platform. Runtime manager, API manager, monitoring center, and exchange are in anypoint platform. When API provider is located in a different Kubernetes cluster from Flex gateway, and the consumer application, you can do either of the following: deploy a Flex gateway runtime on each of the cluster, as in pattern 1b, or establish a network restriction in secure channel between cluster and deploy Flex gateway in only one of them, as shown in this diagram. The second cluster only allows connection from Flex gateway from a connection from the Flex gateway that acts as an ingress controller. Here you can see consumer applications, load balancer, Flex gateway, load balancer, and API and netpol protocol K8 service are in K8 cluster, and here API 2 load balancer and ingress controllers are in K8 different K8 cluster. Here the consumer application interacts with load balancer interacts with Flex gateway. Flex gateway interacts with load balancer interacts with API 1 here, and API 1 interacts with netpol protected K8 service, and here Flex gateway interacts with the firewall interacts with the ingress controller, and ingress controller interacts with the load balancer, and load balancer interacts with the API 2 here, and here the Flex gateway interacts with the firewall, and here the firewall interacts with the anypoint platform. Runtime manager, API manager, monitoring center, and exchange are in anypoint platform. Here you can see the organization internal API exposed to an organization internal consumer that uses a different VPC or network pattern. In this pattern, in Flex gateway reference architecture in anypoint platform gateway, in this pattern the API provider is isolated from API consumer. However, there are secure communication channel available between two networks. You deploy in this pattern, the API provider is isolated from the API consumer. However, there's a secure communication channel between the two networks. you deploy Flex Gateway as an ingress behind a firewall because the traffic is considered external to the location of the provider. Flex Gateway received and processes the incoming traffic. You can use Flex Gateway to terminate TLS or MTLS connection if required. Here you can see the consumer application, ingress controller, and firewall are in trusted network, and consumer applications interacts with the ingress controller. It is ingress control interacts with firewall. Firewall interacts with the firewall in internal network via secure channel. Firewall, Flex Gateway, and APIs are in internal network. Firewall interacts with Flex Gateway. Flex Gateway interacts with APIs. Here this acts as an ingress Flex Gateway. Flex Gateway interacts with Mule platform. Here you can see the organization internal API exposed to an organizational internal consumer that uses the different VPC or network pattern. This is a particular in Flex Gateway reference architecture in any point platform gateway. This is the physical implementation on Kubernetes. Here the consumer applications and egress controller and firewall are inside trusted network. Consumer applications interacts with the egress controller, and egress controller interacts with firewall. Firewall interacts with DNS service in public cloud service via VPC peering or secure channel. DNS service and firewall and VPC are in public cloud service. DNS service interacts with firewall. Firewall interacts with Flex Gateway in K8's cluster. Flex Gateway and service load balancers and APIs are in K8's cluster, and K8's cluster is in VPC. Flex Gateway interacts with service load balancers, and service load balancers interacts with APIs. Flex Gateway is an ingress Flex Gateway. Flex Gateway interacts with firewall. Firewall interacts with any point platform. Runtime manager, API manager, monitoring cluster, and exchange are in any point platform. Here you can see the pattern organization internal API exposed and external organization external consumer in Flex Gateway reference architecture in any point platform gateway. In pattern 2 here, the organization owned API is located from the organization owned API consumer. For example, in package delivery tracking API that access from the user interface, the consumer can access the exposed API via internet. In this case, you deploy Flex Gateway as an ingress gateway, as an ingress. This pattern is similar to pattern 1B. However, in this pattern, traffic arrives from the public internet instead of private channel. Because traffic is coming from the public internet, you must add the additional controls to strengthen the communication security before reaching Flex Gateway. Here you can see consumer application interacts with public internet. Public internet interacts with firewall in internal network. Firewall, Flex Gateway, and APIs are in internal network. Firewall interacts with Flex Gateway. That's the Ingress Flex Gateway. Flex Gateway interacts with the APIs, and Flex Gateway interacts with Anypoint platform. Here you can see the pattern organization internal API exposed to an external consumer in Flex Gateway reference architecture in Anypoint platform gateway. This is the physical implementation of a scenario in which the organization's internal API is exposed to an organizational internal consumer on Kubernetes. The following diagram shows the physical implementation of a scenario in which the organization's internal APIs is exposed to an organization internal consumer on Kubernetes. The diagram assumes that the firewall terminates the incoming external MTLS connection. Here you can see the consumer applications interacts with the public internet via MTLS or external. Public internet interacts with the DNS service in public cloud service. DNS service, DDoS, IPS, firewall, and VPC are in public cloud service. Here the DNS service interacts with DDoS, IPS, and firewall. DDoS, IPS, and firewall interacts with Flex Gateway in K8 cluster via MTLS org internal. Flex Gateway, service load balancers, and APIs are in K8 cluster. K8 cluster is in VPC here. Flex Gateway, the Ingress Flex Gateway interacts with load balancers, and load balancer interacts with APIs here. Flex Gateway interacts with firewall, and firewall interacts with Anypoint platform. Runtime manager, API manager, monitoring center, and exchange are in Anypoint platform. Here you can see the pattern organization external API exposed to an organization internal consumer in Flex Gateway reference architecture in Anypoint platform gateway. The pattern 3, the API consumer in the same network as Flex Gateway. You can use Flex Gateway to monitor, control, and enrich the flows to external services. For example, Flex Gateway can provide rate limiting for external access traffic, or matrices and analytics tracking for this external service connection. Pattern examples: a payment service must obtain exchange rates from an external service provider, and an internal API consume access the organization's external service now instance SaaS service. For pattern 3, you deploy a Flex Gateway as a standalone gateway that acts as an egress container. Here you can see the consumer applications. Flex Gateway and firewall are in internal network. Consumer applications interacts with Flex Gateway, that is egress Flex Gateway. Flex Gateway interacts with the Anypoint platform, and Flex Gateway interacts with firewall. Firewall interacts with the public internet. Public internet interacts with external APIs. Here you can see the the pattern the pattern organizational external API exposed to an organizational internal consumer. The physical implementation of a scenario in which the organizational external API is exposed to an organization internal consumer in Kubernetes. This is with the Flex Gateway reference architecture in Endpoint Gateway, Endpoint Platform Gateway. This following diagram shows a physical implementation of a scenario in which the organization's external API is exposed to an organization's internal consumer on Kubernetes. This diagram assumes that the firewall terminates the incoming external MTLS connection. Here you can see consumer applications and Flex Gateway are in K8's cluster. Kubernetes cluster. Consumer applications interacts with Flex Gateway. That's egress Flex Gateway. Flex Gateway interacts with firewall in VPC via MTLS org internal. Here the Kubernetes cluster and VPC and firewall are in VPC, and VPC is in public cloud service. Here the firewall interacts with public internet, and public internet interacts with APIs via MTLS org external, and here the Flex Gateway interacts with firewall. Firewall interacts with the endpoint platform, runtime manager, API manager, monitoring center, and exchange are in endpoint platform. Here you can see organization's external API exposed to an organization external consumer pattern in Flex Gateway reference architecture in endpoint platform gateway. In pattern 4, the Flex Gateway acts as an intermediary between two organizations' external entities. For example, when organization's Workday instance SAS service access the organization's ServiceNow instance SAS service. This pattern, the Flex Gateway runs as an ingress and egress that applies secure connection and policy enforcement. Here you can see consumer applications interacts with public internet. Public internet interacts with the firewall in internal network. Firewall, Flex Gateway, and the other firewall are in internal network. Here the firewall interacts with the Flex Gateway. Flex Gateway interacts with the endpoint platform, and Flex Gateway is ingress or egress. Flex Gateway interacts with the firewall, and firewall interacts with the public internet. Public interacts with the APIs. Here you can see the physical implementation scenario. The firewall terminates the incoming organization external MTS connections. In organization pattern organizational external API exposed to an organization external consumer in Flex Gateway reference architecture endpoint platform gateway. The following diagram shows a physical implementation of a scenario in which the external organization API is exposed to an external organization's consumer on Kubernetes. The diagram assumes that the firewall terminates the incoming organization's external MTLS connections. Here you can see a consumer application interacts with public internet via MTLS or external. Public internet interacts with DNS service in VPC. DNS service, DDoS IPS and firewall, and Kubernetes cluster and other firewall are in VPC. VPC is in public cloud service. Here the DNS service interacts with the DDoS IPS and firewall. DDoS IPS and firewall interacts with the Flex Gateway via MTLS org internal. Flex Gateway is in Kubernetes cluster. Flex Gateway is ingress egress. Flex Gateway interacts with the firewall, and firewall interacts with the endpoint platform here. Runtime manager, API manager, monitoring center, and exchange are in endpoint platform. Flex gateway interacts with the firewall here, and via MTLS org internal. Firewall interacts with the public internet. Public interacts with the APIs via MTLS org external. Here you can see shared storage in the same cluster in Flex Gateway reference architecture in Anypoint platform gateway. When configuring shared storage in shared storage models, MuleSoft recommends placing a Redis storage shared storage service as close to Flex Gateway as possible. If the Redis shared storage service is available locally in the same cluster or same virtual private cloud VPC, a mutual authentication transport layer security MTLS connection is not required to communicate with the storage with the shared storage. To configure the connection between Flex Gateway and the shared storage service, see the configure shared storage in connected mode and shared storage in the local mode. This is the local mode. In the documentation, this following this diagram uses use Kubernetes terminology, but you can extend the architecture to other technology stacks that have the appropriate network control applied. You can place the Redis shared storage within the same Kubernetes cluster as Flex Gateway, or instantiated within the same VPC as Flex Gateway. Here the shared storage in the same cluster. Here you can see Redis shared storage interacts with Flex Gateways, and Flex Gateways interacts with Anypoint platform, and Flex Gateways and Redis shared storage is in Kubernetes cluster, and Kubernetes cluster is in VPC, and VPC is in public cloud service. Here the runtime manager, API manager, monitoring center, and exchange are in Anypoint platform. Here you can see shared storage in the same VPC in Flex Gateway reference architecture in Anypoint platform gateway. Here shared Redis shared storage interacts with Flex Gateway in Kubernetes cluster, and Flex Gateways are in Kubernetes cluster, and Kubernetes cluster is in VPC, and the Kubernetes VPC and Redis shared storage are in public cloud service here. Flex Gateways are get connected to Anypoint platform. Runtime manager, API manager, monitoring center, and exchange are in Anypoint platform. Here you can see how an internal network communicates with an external network using forward proxy in Flex Gateway in Anypoint platform gateway. A forward proxy such as Squid enables you to route external HTTP Flex Gateway connections through a proxy connection. For both connected mode and local mode, you configure a forward proxy using YAML configuration file. The following diagram demonstrates how an internal network communicates with an external network using forward proxy. As in the diagram, when using a forward proxy, HTTP communication out of your internal network must travel through the forward proxy. In this example, all HTTP API upstream communication must also pass through the forward proxy. For more information about how to enable some connections to communicate directly without a forward proxy, see the no proxy parameter in the documentation. Here, Flex Gateway replicas and forward proxy are in internal network. Here the Flex Gateway replicas interacts with the forward proxy. Forward proxy interacts with the internet in external network via firewall. Internet and anypoint platform are in external network. Internet interacts with anypoint platform. This diagram demonstrates the differences between communication using no proxy. No proxy in Flex Gateway in anypoint platform gateway. No proxy parameter, adding no proxy parameter enables HTTP services you trust to communicate without using forward proxy. For example, when you enable no proxy, you can hit list HTTP log connections and connections to upstream services to have them connect directly to Flex Gateway. When using no proxy parameter in the YAML configuration file communicate with HTTP logs, you must list the exact domain name. You cannot list the domain suffix, for example .svc, .cluster, You need to list full domain name, logging name .svc, .cluster, for all HTTP log connections. Following diagram demonstrate the differences in communication with no proxy. In the diagram, when you do not enable no proxy, Flex Gateway communicates with the internal API endpoint using forward proxy. When you enable no proxy, list the API upstream domain, Flex Gateway communicates directly with the internal API endpoint. Here you can see user request interacts with Flex Gateway replica, and Flex Gateway replica interacts with forward proxy. Forward proxy interacts with API endpoint, and forward proxy interacts with external networks. Here the no proxy disabled, and user request, Flex Gateway replica, forward proxy, and API endpoint are in internal network. Here the no proxy enabled, user request interacts with Flex Gateway replica, and Fed Gateway replica interacts with endpoint. Flex Gateway replica interacts with forward proxy. User request, Flex Gateway replica, API endpoint, and forward proxy are in internal network. Here the forward proxy interacts with external networks. This is no proxy enabled. Here you can see how an internal network communicates with an external network using forward proxy in local mode in Flex Gateway in anypoint platform gateway. Forward proxy such as Squid enable you to route external HTTP Flex Gateway connections through a proxy connection. For both connected mode and local mode, you configure the forward proxy using YAML configuration files. The following diagram demonstrates how an internal network communicates with an external network using a forward proxy. As in the diagram, when using forward proxy, HTTP communication out of your internal network must travel through the forward proxy. In this example, all HTTP API stream communication must also pass through the forward proxy. For more information about how to enable some connections to communicate directly without the forward proxy, see the no proxy parameter in the documentation. Here you can see a Flex Gateway replicas interacts with forward proxy. Flex Gateway replica and forward proxy are in internal network. Forward proxy interacts with the internet in the external network via firewall. Internet interacts with the anypoint platform. Internet and anypoint platform are in external network. Here you can see the differences in communication with using no proxy in local mode. Adding no proxy parameter in local mode in Flex Gateway in Anypoint Platform Gateway. Adding no proxy parameter enables HTTP services you trust to communicate without using the forward proxy. For example, when you enable no proxy, you can list HTTP log connections and connections to upstream services to have them connect directly to Flex Gateway. When using the no proxy parameter in YAML configuration file to communicate with HTTP logs, you must list the exact domain name. You cannot list the domain suffix, for example, .svc.cluster.local. You need to list full domain name, login name .svc.cluster.local for all HTTP log connections. Following diagram demonstrate the differences in communication using no proxy. In the diagram, when you do not enable no proxy, the Flex communications with the internal API endpoints using the forward proxy. When you enable the no proxy and list the API stream domain, the Flex gateway communicate directly with the internal API endpoint. And here you can see user replica interacts with Flex gateway replica, and Flex gateway replica interacts with forward proxy. Forward proxy interacts with API endpoint in no proxy enabled. User request, Flex gateway replica, forward proxy, and API endpoints are in internal network. Forward proxy interacts with external network. Here you can see no proxy enabled. User request interacts with Flex gateway replica. It interacts with API endpoint and a forward proxy. Here the user request, Flex gateway replica, forward proxy, and API endpoint are in internal network. Forward proxy interacts with external networks. Here you can see two configuration models in Flex Gateway in Anypoint Platform Gateway. Anypoint Flex Gateway running in local mode supports two configuration models. The resource-based model, common in Kubernetes, is ideal for granular definitions. Resources each contain one of the following values for configuration: kind, API instance, service, policy binding, configuration. The inline model is ideal for concise definitions, but is less versatile. For example, automated policies can only be applied in resource-based definitions. Inline definitions contains API instance, value for configuration kind, under which services and policies are both defined. Here you can see a API instance. The kind API instance, metadata name, the API instance name. Here the spec address, the proxy address including port and path. Here the policy binding, the kind policy binding, metadata name, the policy binding name, spec target ref name, API instance name, policy ref name, policy name, config optional policy configuration, rules optional policy rules. Service here, kind service, metadata name, service name, spec address, service address including port. The configuration, define desired gateway state by creating configuration entity. Configuration entity specifies several runtime configuration aspects for Flex Gateway itself, such as logging and shared storage. Inline configuration here, the kind API instance, metadata name, API for example, metadata name, for example, API dash example, spec address, for example, HTTP ://0/0.0.0.0 8080, and etc. Here you can see API instance. Here you can see the resource-based configuration model. Here you can see API instance, and here the service and policy binding are in resource-based configuration model. Here you can see API instance is in inline configuration model. Here you can see one level search scope in basic authentication in Flex Gateway in Anypoint platform gateway. With this option, with this option, the filter affect only object immediately subordinate to the LDAP search base, and not the LDAP search base itself. In the following example, the first level has four entries, 2 users, and 2 groups. These are the only entries that are part of any search. If you set the search filter to UID 0, only the Jane and Paul are found. The group entries are not considered. Here you can see the base, OU equal people, DC equal my dash company, and DC equal com, and this is the base level. Base is connected to group 1, Jane, Paul, and group 2, and Paul, group 1 OU equal DevOps, Jane UID equal 1, Paul UID equal 2, groups 2 OU equal engineers, this is level 1, and group 1 is connected to Patrick, UID equal 3, and group 2 is connected to Anna, UID equal 4, and Anna and John, Anna UID equal 4, and John UID equal 5. This is in the level N. Patrick, Anna, and John are in level N. Here you can see the subtree search scope in basic authentication in Flex Gateway in Anypoint platform gateway. With this option, the basic authentication dash LDAP policy examines the subtree below the LDAP search based, and also include the LDAP search base level. Notice that performance is affected by this behavior. In this in the previous example, the analyzed area covers the entire organization. The group and the user entries are considered at any level of the organization. Here you can see base OU equal people, DC equal my dash company, DC equal com, and this is base level. And here group ID, base is connected to group 1, Jane, Paul, and group 2. Group 1 OU equal DevOps, Jane UID equal 1, Paul UID equal 2, group 2 OU equal engineers. Group 1, Jane, Paul, and group 2 are in level 1. Group 1 is connected to Patrick, UID equal 3. Group 2 is connected to Anna and John. Anna UID equal 4. John UID equal 5. Patrick, Anna and John are in level N here. Here you can see the valid result is written in basic authentication in Flex Gateway in Anypoint Platform Gateway. After applying the basic authentication LDAP policy to the API, a request to the API must contain the following header: authentication basic username password. The username password value must be base 64 encoded string. For example, on Mac OS, on Mac OS X or Linux system, the username and password requirement is implemented as echo-n client ID client's secret vertical line base 64. From the username and the search filter, LDAP finds the registered user and verifies the credentials. The valid result is returned. Here you can see client, Mule and LDAP server. Here the client, here the message plus authorization header is sent to Mule, and then here the client is connected to Mule via message plus authorization header, and Mule is connected to LDAP server via credentials plus search filter, and then LDAP server is connected to Mule via validation result, and then Mule is connected to Mule via message process, and then Mule is connected to client via response. Here you can see the an invalid request in basic authentication in Flex Gateway in Anypoint Platform. The following diagram illustrates an invalid request. The basic authentication, the LDAP proxy throws an HTTP 401 status code to indicate that the authorization header is malformed, not provided, or invalid. Here you can see the client, Mule and LDAP server. Here client is connected to Mule via message plus authorization header. Mule is connected to LDAP server via credentials plus search filter, and LDAP server is connected to Mule via validation result, and Mule is connected to client via response 401. Here you can see the XML HTTP request. XHR in JavaScript flow for determining whether to execute the actual request. In how CORS work in Flex Gateway in Anypoint Platform Gateway. When your web pages request data, the browser detects whether the request is from within the same origin, or determines whether to apply the CORS algorithm. If you query from a web page that is not in your origin, then the CORS policy is applied. The CORS algorithm works on the web server and on the client side for the web page that requested the information. The client-side algorithm in the CORS policy is implemented by determining whether the request is complex and potentially dangerous, and sending preliminary pre-flight request to verify whether the server accepts the origin. And executing actual request and validating the server response correctly and accept the origin. Pre-flight is a preliminary request using options and as HTTP header. As the HTTP method from the web browser to the backend server to test the identity, origin, and a few other headers of the web page that is trying to perform the request. If the backend does not accept the origin, the backend server responds to the request without specifying header, access control, or allow origin. The client then understands the page origin is not allowed. Allow that in the server and does not execute the actual request. The following diagram shows the XML HTTP request XHR in a JavaScript flow for determining whether to execute the actual request. As illustrated in the diagram, the request is validated based on the communication between the browser and the server. If the request is considered to be complex, then the pre-flight request is executed. If the server does not return the proper course response, proper course response headers for the pre-flight, then the client library XHR is not allowed to perform actual request. If the pre-flight response is correct and complete, then the client library execute the actual request, which include certain course headers. The client library then validates the course headers of the response. If some of the required headers are missing, then the client library is obliged to block the response from the reaching the client, which is usually a web page. Here you can see the path of the latency, and this is part of added latency. Here the JavaScript makes a cross-domain XHR call, and it is connected to is it a get or head? If it is yes, it is connected to are there any custom HTTP headers? If it is no, it is connected to is it a post? If it is yes, it's connected to is this content is type standard. If it is yes, it's connected to are there custom HTTP headers. If it is yes, it is connected to make options to call to server with all custom details. And if it is it a post? If no, it's connected to make options call to server with custom details. And if the content type standard, and if it is no, make options call to server with all custom details. And make options call to server with all custom details is connected to did server response with appropriate cross control headers. If it is yes, it is connected to make actual XHR, and if it is no, it is connected to errors. And here the other custom HTTP headers. If it is no, it's connected to make actual XHR. And here the is it a get or head, and is it a post, and is the content type standard, and are there in custom HTTP headers. And make actual XLR are in path of standard latency, and make options call to server with all custom headers, and did server response with appropriate access control headers are in path of added latency. Here you can see the header injection policy in Flex Gateway in endpoint platform gateway. The header injection policy adds the HTTP headers to the request or response of a message. When you configure this policy for your API, you must specify inbound and outbound map of the headers. That you want to add in the message processing in the form of key value pairs. You can optionally include data wave expressions in the value or name of the header. For example, all headers matching the following configured expressions are injected to the message. Hash attribute dot request path. If the injected header already exists in the message attributes, the policy creates a new header without overriding the value of the existing one. Only certain headers are restricted to support multiple values, and they will be overwritten using the configured values. These headers are access control, allow origin, content type, content length, transfer encoding. To override any other existing message header, remove it before adding your header. Here you can see the client interacts with proxy via header injection policy and header removal policy, and proxy interacts with the implementation API, and proxy interacts with the client via header removal policy and header injection policy. Here you can see a header removal policy in Flex Gateway in Endpoint Platform Gateway. The header removal policy removes all listed headers from a request or response of the message when you specify an inbound or outbound map of the headers that you want to remove with the key value pair. You can optionally include data wave expressions in the value of the header. For example, all headers matching the following configured expressions are injected into the message. Hash attribute dot request path. The following headers may not be removed except host, content type, content length, date, transfer encoding, connection. Here the client is connected to proxy via header injection policy, header removal policy, and proxy interacts with implementation API. Proxy is connected to client via header removal policy and header injection policy. Here you can see cache miss in Flex Gateway in Endpoint Platform Gateway. In cache miss scenario, the HTTP caching policy checks whether a response to the submitted request is already cached. Request reaches the backend and the process is initiated only when it's cache miss. The diagram illustrates the flow of event that occur in this scenario. One, the client user send the request to API. Two, the request proceed through the other policies on the policy chain before reaching the HTTP caching policy. 3, the HTTP caching policy checked if the request is already in the object store. If not, cache miss process is initiated. 4, the request continues throughout the chain of other remaining policies. 5, the request reaches the backend and complete all required processing. 6, backend response travels back through the policy chain. 7, response reaches the HTTP caching policy. 8, caching hits the object store again and attempts to save the key of the request for later reuse. Response continues through the remaining policies in the policy chain. Response is returned to the client. Here you can see client is connected to policy A and policy A is connected to caching policy, and caching policy interacts with the object store here, and caching policy A is connected to policy B here, and the policy A, caching policy, and policy B are in API gateway, and policy B is connected to backend, and then backend is connected to policy B, and policy B is connected to caching policy, and caching policy interacts with the object store, and caching policy is connected to policy A. Here the caching policy, here the API gateway, backend, and object store are in runtime, and policy A is connected to client. Here you can see cache hit in Flex Gateway in Anypoint Platform Gateway. In cache hit scenario, the HTTP caching policy searches for the key in the object store and find that response to the request is already cached as the stored entry. The request does not proceed any further in the policy chain towards the backend, and the cached response is reused. Subsequently, all policies that must be executed in the policy chain after caching are not executed in case of the cache hit. The client, the user sends a request to the API to the the request crosses other policies before reaching the HTTP caching policy. 3. HTTP caching policy verifies that the request is already in the cache. The key is found and found in the object store, and the stored response is returned. 5. The response is continues through the rest of the policy chain until it reaches the last one. 6. Cached response is returned to the client. Here the client is connected to the policy A. Policy A is connected to the caching policy, and caching policy is connected to the object store, and object is connected to the caching policy. Here the policy A, caching policy, and policy B are in the API gateway. Here the caching policy is connected to the policy A, and policy A is connected to the client. Here the API gateway, object store, and backend are in runtime. Here you can see before logging an API flow in message logging policies in Flex Gateway in Anypoint Platform Gateway. Here you can see the actor and the policy A and message login policy. Here the policy B and message login policy, and policy B and proxy and backend. Here the request is passed to policy A, and policy A is connected to message login policy via request, and message login policy is connected to message login policy via logging, and message login policy connected to policy B via request, and policy B is connected to proxy via request, and proxy is connected to policy A via backend request, and the policy A is connected to message logging policy via backend request, and message logging policy is connected to policy B via backend request, and policy B is connected to backend via backend request, and backend is connected to policy B via backend response, and policy B is connected to message logging policy via backend response, and message logging policy is connected to policy A via backend response, and policy is connected to proxy via backend response, and proxy is connected to policy B via proxy response, and policy B is connected to message logging policy via proxy response, and message logging policy is connected to policy A via policy response, and policy A is connected to the actor via policy response. Here you can see after logging an API flow in the message login policy in Flex Gateway in Anypoint Platform Gateway. Here the actor is connected to policy A via request, and policy A is connected to message login policy via request, and message login policy is connected to policy B via request. Policy B is connected to proxy via request, and proxy is connected to backend policy A via backend request, and policy A is connected to message login policy via backend response. Message login policy is connected to policy B via backend request, and policy B is connected to backend via backend request, and backend is connected to policy B via backend response, and policy B is connected to message login policy via backend response, and message login policy is connected to policy A via backend response. Policy A is connected to proxy via backend response, and proxy is connected to policy B via proxy response, and policy B is connected to message login policy via proxy response, and message login policy is connected to message login policy via logging, and message login policy is connected to policy A via proxy response, and proxy response policy A is connected to actor via proxy response. Here you can see error handler after API flow in message logging policy in Flex Gateway, in Anypoint platform gateway. Here you can see actor, policy A, message login policy, policy B, proxy, and backend. Here the actor is connected to policy A via request. Policy A is connected to message login policy via request, and message login policy is connected to policy B via request, and policy B is connected to proxy via request, and proxy is connected to proxy A via backend request, and policy is connected to message login policy via backend request. Message login policy connected to policy B via backend request, and policy B is connected to backend via backend request, and backend is connected to proxy B via backend failure response. Policy B is connected to message login policy via backend failure response, and message login policy is connected to policy A via backend failure response, and policy is connected to proxy via backend failure response. Proxy is connected to policy B via proxy failure response, and here the proxy B is connected to message login policy via proxy failure response, and message login policy is connected to receive logging, and message login policy is connected to policy A via proxy failure response, and proxy is connected to actor via proxy failure response. Here you can see the OpenID connect access token enforcement policy workflow. The following diagram in Flex Gateway, in Anypoint platform gateway. Here the following diagram illustrates the OpenID connect access token enforcement policy workflow as shown in the diagram. Step 1, here the user first send an HTTP request to the API protected by the policy. 2, the policy extract the token from the request and send it to the validation endpoint to verify the integrity of the token. 3, the token validation endpoint returns the token metadata, including the client ID of the application. And 4, the using the local database updated with the contract previously obtained from the Anypoint platform, the policy verified whether the client ID has access to the API. If the all validations are successfully completed, the request is allowed to reach the backend. Here you can see a user is connected to policy, and policy is connected to token validation endpoint, and token validation endpoint is connected to policy, and policy interacts with the Mule control panel, and policy is connected to API. Here you can see the rate limiting policy in Flex Gateway, in Anypoint platform gateway. The rate limiting policy monitors the number of requests made in the current window, the available quota, allowing the request to reach the backend only if the available quota is greater than 0. You can configure the policy for multiple groups of requests by using identifiers in the policy configuration. Each group has a separate variable quota for its window. To understand how the rate limiting policy works, consider an example in which the configuration of 3 requests every 10 seconds allows or restrict incoming requests based upon the quota available in that window. In the first window, because of the quota is reached with the third request, all the subsequent requests are rejected until the window closes. In the second window, only 2 of the 3 requests are processed, and the quota remaining is dropped after the window time has elapsed. An accepted request passes through the API to the backend. Conversely, the rejected request displays the 429 status for HTTP, or either 400 or 500 if the API is WSDL and does not reach the backend. A rejected request, on the other hand, displays 429 status for HTTP, or either 400 or 500 if the API is WSDL and does not reach the backend. Here you can see the accepted requests, and here the rejected request. Here the first window, and here the second window. And this is the time. Here you can see the configuration identifiers by using regular strings in Flex Gateway, in Anypoint Platform Gateway. When you use UI to add identifiers to the policy configuration, you can define groups of requests. The configured limits apply independently to each group. You can also use the identifier attribute hash attribute.method for the one bucket for HTTP method in your rate limiting policy configuration. An identifier in the UI is non-obligatory parameter. By default, the identifier has no value. Based on whether you accept the default or provide a value, the policy performs the following ways. Not configured. Default, the rate limiting quota applied to every request per bucket or group. Configured for an obligatory HTTP header. Each header has its own quota. Header values are case sensitive. Quotas are created using lazy creation strategy. Configured for non-obligatory HTTP header. Custom header, payload, query parameter, or expression values have their own quotas. The identifier, if not sent to the request, default to an empty value having its own quota. This behavior allows the rate limiting policy to be applied to an API consumed by the uncontrolled client, and at the same time accommodates the special buckets for the client sending the identifier. The following example shows the order of events that occur over a period of time using identifier hash attribute.method for a limit of 3 requests for every 10 seconds. In this example, entry HTTP method is allowed 3 requests for every 10 seconds. In this example, only get and post requests are made to the API. The rate limiting policy works in a fixed window fashion. For more information, see the fixed window size bucket in the diagram. The window start times are independent. The engine uses lazy creation strategy that spools a rate limiting algorithm whenever the first request for the method is received. Here you can see the window size. Accepted post request here, here, and the rejected post request here. Here the accepted get request. Here the accepted post request. This is 3 here, and here this one is rejected in this window. Here the accepted post request are here, 3 here. We accept 3 here, and the rejected post request is here. And here the accepted get request are 3 here in this window, and rejected fourth one. Here you can see the configuring identifier by using data wave expressions. The rate limiting engine, which is HTTP agnostic, depending solely on the resolution of the data view expression. You can alter the identifier expression in the UI to cover the complex rate limiting scenarios. For example, you can configure rate limiting policy with an identifier that uses one bucket for all class A and class C LAN requests and another bucket for everything else. Following image illustrates this second bucket in the previous sentence, which corresponds to the 3 requests per 10 seconds quota with the data wave expression hash attributes.queryParam customer identifier as the policy identifier. In the example, all requests without identifiers are solved to the empty identifier and therefore use a single rate limiting algorithm. Each different identifiers uses different bucket with its own independent quota. This configuration creates a false or true bucket that correspond to the locality of the IP that make the request. The false and true values correspond to the domain of Boolean values and not HTTP. Nevertheless, the policy works correctly because the engine treats the solved expression as a string. In this case, the value is automatically cast to the Boolean to string. You can explicitly define casting in the data view by adding output text /pain -- to your script. Note the HTTP rec header names are case sensitive. Anypoint connector for Mule HTTP changes header names to lowercase characters. However, the data wave key is case sensitive. Therefore, when creating identifier expression, remember the reference headers in lowercase. Here you can see the window sizes here. Window size, here the accepted request param ID 2. There are 3, and the third one is rejected request param ID 2 in this frame here. Here the accepted request no param, no query param here, and 3, and the other 4 and 6, 5 are rejected in this bucket here. And the accepted query param ID 1, here the 1, 2 and 3 and 4 is, and this is reject request param ID 1 here, and this is time. Here you can see a rate limiting SLA policy in Flex Gateway. In Flex Gateway, in Anypoint platform gateway, the rate limiting SLA policy monitors the number of requests made in the current window, the available quota, allowing the request to reach the backend only if the available quota is greater than 0. Because each client identifies the separate available quota for their window, the client application must define an SLA with an API contract. Therefore, to verify whether the request is within the SLA limit, you must define a way to obtain the client ID from the request. And the optionally the client secret. After a contract is created between client application and an API gateway automatically manages these contracts by monitoring your API manager configuration. Additionally, API gateway implements the high availability strategies in case of unexpected downtime in Anypoint platform management plane. To understand how the limiting SLA policy works, consider an example in which the configuration of SLA of 3 requests every 3 seconds. For the client ID, client with ID 1, allows or restrict the request based on the quota available in that window. In this example, request for client ID with ID 1. In the first window, because of the quota is reached with the third request, all the subsequent requests are rejected until the window closes. In the second window, the only 2 of 3 requests are processed because the time elapses at this window, and remaining quota is unused. An accepted request passes through the API to the backend. Conversely, the rejected request displays the 429 status for HTTP, or 400 or 500 if the API is WSDL and does not reach the backend. Request client with ID #2, because the client has no contract defined for that for the API. Every request is rejected, therefore no request is allowed. The API might have several contracts, each with its own SLA. The rate limiting policy independently monitors the quota or windows available for each client by creating one rate limiting algorithm per contract. With the first request to the API algorithm are created using lazy creation strategy. Here you can see accepted in the first window, accepted request for client ID, client with ID 1 and 3 is allowed, and here the rejected request for client ID 1. Here the rejected request for client ID, client with ID 2. Here you can see request timelines in spike control policy in Flex Gateway, in Anypoint Platform Gateway. The spike control policy uses a sliding window algorithm which reduces the spike in traffic and protect the gateway instance. The window self-adjusts its display size to accommodate the results over time. If the current window has no remaining request quota without closing the connection to the client, the spike control policy allows the request to be queued for processing later. For your policy to queue the request, you must configure the policy parameters as shown in the following example here. The time period 1 second, number of requests 2, delay time in milliseconds 499 milliseconds, delay attempts 1, queuing limits 5. Queuing a request requires remaining a thread and HTTP connection. When you specify queuing limit for the policy, the parameter protects the gateway from running out of resources and ensures that the API does not fail in case of an attack. Request time limits, timelines. The following diagram illustrates the lifespan of each request accepted by the algorithm using the configuration defined before. The first requests are accepted. The first 2 requests are accepted, and available quota is now 0. The quota increases to 1 after 1 second. The window size value passes from the request 1. Request number 3 arrives. Because no quota is available, the request is queued for 499 milliseconds. 3, the request 4 arrives. Number 4 arrives. Because there is still no quota available, the request is queued for 499 milliseconds. Shortly before request 3 is retrieved, the request 1 ages a second, and the quota is released because it fails out of the window. 5, the quota 1 is now the quota is now 1. The request 3 is reprocessed successfully. The quota returns to 0 until request 2 ages quota returns to 0 until the request 2 ages 1 second. The request 4 delay conclude it and it must be reprocessed. Request 4 is rejected. Request 2 and 3 have not aged a second. And there is no quota available. The request 4 have no more delays. The request 5 arrives because the request 2 has already aged more than a second. The request is accepted. In this example illustrates the request delays and how queuing regulates spikes in the traffic. In high connection scenarios, the backend continues to function properly. It serves no more than X request and in the last Y milliseconds. User querying the API might still see their request being served, but with the higher latency. Exact configuration for policy depends exclusively on your API and its throughput. Here you can see the time here, and here you can see the time period, and here the accepted request here, and here the rejected request, and here the queued request, and the queued request 3 is accepted request, and here the queued request 4 is a rejected request. Here you can see traffic management policy in Flex Gateway, in Anypoint Platform Gateway. The traffic management policy directs to the different set of upstream services by using multiple routes with a defined route order and individual rule sets to direct traffic to different sets of upstream services. In the following diagram, the different routes manage requests to flight information databases and to customer service application. Route 1 has two upstream services defined, which direct 30% of the request to a stable database and 70% of the request to the stable database and 30% of request to the beta database. To achieve this configuration, bind two route weighted resources to the exposed API instance. The one route weighted resource direct traffic to the flight information database, and the other route weighted resource direct to the traffic to the customer service application. Here you can see the downstream configuration, and here you can see the upstream configuration. Client application interacts with the http://x.x.x.x:8081/flights in consumer endpoint, and it interacts with the Flex Gateway. Flex Gateway interacts with upstreams. Here Flex Gateway interacts with upstream 1 and upstream 2. Upstream 1 and upstream 2 are in route, and here the upstream 1 weight 70%, and http://www.iberia.com/flights. And it's connected to the data center here, and in the upstream 2 weight 30%, and http://www.iberia.com/flights beta interacts with the data center here. Here the upstream 1 is in root 2, and here the http://www.drive.com/users and it interacts with endpoint enterprise applications. And here you can see the difference between inbound and outbound requests in Flex Gateway and Anypoint Platform Gateway. When configuring and running Flex Gateway, you might encounter interconnection issues. By making direct requests, you can troubleshoot both the outbound connection between upstream service and Flex Gateway and the inbound connection between Flex Gateway and the client. Making direct request isolates Flex Gateway connections, allowing you to localize the issue. The following diagram demonstrates the difference between inbound and outbound request. Here the client application interacts with the inbound request. Here http://0.0.0.0:881/API, and inbound request interacts with the Flex Gateway. Here Flex Gateway interacts with the outbound request, http://upstream.domain. Outbound request interacts with the upstream service. Here you can see a Mule Gateway overview in Anypoint Platform Gateway. The Mule runtime includes an embedded Mule Gateway. Using this gateway, user can, for example, apply a basic authentication policy on top of a Mule application, enrich an incoming outgoing message, or add any other complex capability to an API without having to write any code. The overall Mule Gateway allows you to add a dedicated orchestration layer on top of your backend APIs and services to help you separate orchestration from implementation concerns. You can leverage the governance capabilities of API Manager to apply, among other capabilities, throttling, security, caching, and logging to your APIs. If you want to apply policies and generate analytics info, you must use either an API defined in a Mule application or a Mule application that proxies your existing backend implementation. Here you can see API Manager is connected to Anypoint Runtime Manager agent via governance enforce. Anypoint Runtime Manager agent is in API Gateway. This is orchestration layer, and below you can see the backend API is the implementation layer. API Gateway and backend API is in Mule Runtime Engine. Clients communicates. Client interacts with API Gateway, and API Gateway interacts with backend API. Here you can see Mule API proxy in Mule Gateway in Anypoint Platform Gateway. API proxies, also known as auto-generated proxies, are meant to enhance the usability of API Manager in your Mule application. Typical usage: either when you want to leverage Mule Gateway capabilities and your backend API is not based on the Mule runtime, or when your API is based on the Mule runtime but you are unable to define the corresponding auto discovery element because it is a closed code. When you configure your API to be proxy endpoint, Anypoint Platform allows you to download a pre-configured Mule application. If application is deployed to Mule runtime and you are using the correct platform credentials, API for the application will be automatically tracked by the API Manager. You do not need to know how to create Mule application. You simply deploy the application to a correct configured runtime. Note: Anypoint Platform can deploy the proxy directly to Cloud Hub or using Mule agent through Runtime Manager. If you would like to use HTTPS instead of HTTP, you can follow these steps. 1. Import the auto-generated proxy into Anypoint Studio. 2. Specify the certificates to be used. 3. Deploy the application to Cloud Hub. or runtime instance. Proxies can be downloaded from API platform, convenient tool to speed up your application network deployment. Having said that, you are not restricted to using auto-generated proxy. Any Mule application provided with the correctly configured auto discovery can be used to leverage the Mule gateway capabilities. Here you can see API manage is connected to Mule runtime manager agent via governance enforced. Anypoint runtime manage agent is in API gateway. This is orchestration layer, and it is in the Mule application. Mule runtime engine. And here the backend API is in backend. You can see the backend API is in Mule runtime engine, and it is the backend API is the implementation layer. Here the clients interacts with the API gateway via proxy endpoint, and API gateway interacts with the backend API. Here you can see basic one level search scope in basic authentication in Mule gateway in anypoint platform gateway. With this option, the filter affects only the object immediately subordinate to the LDAP search base, and not the LDAP search base itself. In the following example, the first level has 4 entries, 2 users and 2 groups. These are the only entries that are part of any search. If you set the search filter to UID equals 0, only Jane and Paul are found. The group's entries are not considered. Here you can see the base OU equal people, DC equal my dash company, and DC equal com. This is the base level, and base is connected to group 1 here, group Jane and Paul, and group 2 here. Here the group 1 OU equal DevOps, Jane UID equal 1, Paul UID equal 2, group 2 OU equal engineers. Here group 1 is connected to Patrick, UID equal 3. Here the group 2 is connected to Anna, UID equal 4, and John, UID equal 5. Here the group 1, Jane, Paul, group and group 2 are in level 1. Here the Patrick, Anna and John are in level N. Here you can see subtree search scope in basic authentication in Mule gateway in anypoint platform gateway. With this option, basic authentication LDAP policy examines the subtree below the LDAP search base, and also include the LDAP search base. Notice that performance is affected by this behavior. In the previous example, the analyzed area covers the entire entire organization. The group and user entries are considered at any level of the organization. Here you can see the base OU equal people, DC equal my company, and DC equal com. Base is in base level. Here group I base is connected to group I group 1 OU equal DevOps, and Jane UID equal 1, and Paul UID equal 2, and group 2 OU equal engineers. Group 1 Jane, Paul, and group 2 are in level 1. Here group 1 is connected to Patrick, UID equal 3. Here group 2 is connected to Anna, UID equal 4, and John, UID equal 5. Here you can see here the valid result is returned to Mule in basic authentication in Mule gateway in anypoint platform gateway. After applying the basic authentication LDAP policy to API, the request to that API must contain the following header: authentication basic username password. The username password value must be a base 64 encoding string. For example, on the Mac OS X and Linux, the username and password requirement is implemented as echo-n client ID client secret vertical line, and base 64. Mule runtime engine. Mule separates the credentials of the header and send the request to the LDAP server with each filter. From the username and search filter, LDAP finds the registered user and then verify the credentials. Valid result is returned to the Mule. Here you can see the client and Mule and LDAP server. Here client is connected to Mule via message plus authorization header. Mule is connected to LDAP server via credentials plus search filter, and LDAP server is connected to Mule via validation result. Mule is connected to Mule via message process, and Mule is connected to client via response. Here you can see the an invalid request in basic authentication in Mule gateway in Anypoint platform gateway. The following diagram illustrates an invalid request. The basic authentication LDAP policy throws an HTTP 401 status code to indicate that the authorization header is malformed or not provided or invalid. Here you can see the client, Mule and LDAP server. Client is connected to Mule via message plus authorization header. Mule is connected to LDAP server via credentials plus search filter. LDAP server is connected to Mule via validation result, and Mule is connected to client via response 401. Here you can see the detokenizing request in detokenizing policies in Mule gateway and in Anypoint platform gateway. The following events occur when tokenizing requests. 1. The user performed a request to the application protected by the policy. 2. The request goes first to the Anypoint security and then to the application detokenization policy. 3. Detokenization policy extract the token from the payload using the select expression. 4. The detokenization service receive the tokens and return them to the original sensitive values and send the result to the policy. 5. Here the policy replaces the tokenized payload with the detokenized values and forward it to the Mule application. 6. The Mule application processes the request and the result returns the result. Here the request is sent to Anypoint security. Anypoint security tokenization service and runtime as a API gateway in runtime fabric. Here the Anypoint security is connected to API policy tokenization. And API policy is connected to tokenization service, and tokenization service is connected to API policy. Then API policy is connected to Mule application. Here API policy and Mule applications are in runtime as a API gateway. Mule application is returns the result. Here you can see the detokenizing responses in detokenization policy in Mule gateway in runtime platform gateway. 1. Here the user performs the request to the application protected by the policy. 2. The here request goes to the Anypoint security and then to the application detokenization policy. 3. The detokenization policy redirect the request without extracting anything from the payload. 4. Mule application processes the request and return the result. 5. Detokenization policy extract the tokens from the payload using the select expression. 6. Detokenization service receive the tokens, return them to their original sensitive values and send the result to the policy. 7. Here policy send the response back to the user with the detokenized values in the payload. Here the request is sent to endpoint security, and endpoint security is connected to API policy tokenization. API policy is connected to tokenization service, and tokenization service is connected to API policy. Here endpoint security, tokenization service, and runtime as a gateway are in runtime fabric, and here API policy is connected to Mule application. Mule application is connected to API policy. API policy is send the response. Here you can see the Mule AOT provider policy in AOT 2 access AOT 2.0 access policy enforcement in with Mule AOT provider policy in Mule gateway in Anypoint platform gateway. The following diagram illustrates the AOT 2.0 token enforcement using Mule AOT provider policy workflow. As shown in this diagram, step 1, the user first send the HTTP request to the API protected by the policy. To the policies, extract the token from the request and send it to the validation endpoint to verify the integration of the token. 3, the token validation endpoint returns the token metadata, including the client ID of the client application. 4, using the local database updated with the contracts previously obtained from the Anypoint platform, the policy verifies whether the client ID has the API. Client ID has the access to the API. 5, if all the validation are successfully completed, the request is allowed to reach the backend. Here the user is connected to policy first, then policy is connected to token validation endpoint. Token validation endpoint is connected to policy, and policy interacts with the Mule control panel. Policy is connected to API. Here you can see the configuring the policy for clusters, Mule only in rate limiting policies in Mule gateway in Anypoint platform gateway. Consider the same configuration as an example of consider the same configuration example of the with 3 requests and a window that start exactly at 12:00:00 is reset at every 10 seconds and has 2-node Mule cluster. Both nodes start and end their windows at the same time, and the cluster allows 3 requests per window in total. Because the policy is clusterized, the whole cluster accepts 3 requests. If the clusterizable policy is turned off, the Mule cluster can accept 6 requests per window. That is 3 requests per node. To avoid distributed counters negatively impacting performance due to the node synchronization needs, the policy uses caching mechanisms to predict the behavior and maximize throughput. However, some scenarios nevertheless result in higher latency, so be careful when you use your clusterization configuration. Note that to configure the rate limiting policy for clusters, Mule runtime engine instances must be running as part of the Mule cluster. Here you can see accepted request, here rejected request, and here 2 accepted request in node 1 and the 3 rejected requests. Here the in node 2 1 accepted request and 2 rejected requests. Here total 3 accepted requests in node 1 and node 2. Here you can see a tokenized requests in tokenization policy in Mule gateway in Anypoint platform gateway. The following events occur when you tokenize a request. 1. The user performs a request to the application protected by the policy. To the request goes first to the endpoint security, then to the application tokenization policy. 3. The tokenization policy extract all the tokens that match the select expression, and 4. The tokenization service receive the tokens and transform them and return the result to the policy. 5. The policy replaces the payload with the tokenized values and forward to the Mule application. 6. The Mule application processes and the request return processes the request and return the result. Here, request is connected to endpoint security, and endpoint security is connected to a tokenized API policy tokenization. API policy is connected to tokenization service, and tokenization service is connected to API policy. API policy is connected to Mule application. Mule application returns the result. Here, endpoint security, tokenization service, and runtime as API gateway are in runtime fabric, and here API policy and Mule applications are in runtime as API gateway. Here here you can see tokenization responses in Mule gateway in endpoint platform. The following events occur when you tokenize responses. The user performs the request to the application protected by the policy. The user request goes to endpoint security and then to the application tokenization policy. The tokenization policy tokenizes the Mule response and redirect the request without extracting anything from the payload. The Mule application processes the request and return the result. 5. The tokenization policy extracts the tokens from the payload using the select expression. 6. The tokenization service receives the token and transform them and returns result to the policy. And 7. Tokenization policy send the response back to the user with the tokenized values in the payload. Here the endpoint security, tokenized service, and runtime as API gateway are in runtime fabric, and the API policy and Mule applications are in runtime as a gateway. Here the response is sent to the endpoint security, and endpoint security is connected to API policy tokenization. Endpoint policy is connected to Mule application. Mule application connected to the API policy, and API policy is connected to the tokenization service. Tokenization service is connected to the API policy, and API policy response back to the user. Here you can see the rejected request in rate limiting and throttling in Mule gateway in endpoint platform gateway. The policy configuration, here the 5 requests per 10-second window, 1 retry with 500 milliseconds delay. User send 5 requests within the first 6 seconds, and all are accepted. At 8 seconds, a new request comes in. No quota remains. So the request is delayed for 500 milliseconds. At the 8.5 seconds, the queued request is reprocessed. As the window has not yet closed, there is still no quota available, so there are no more retries available, so the request is rejected. Here you can see the time, and here you can see the 5 accepted request, and here you can see the queued request, and this is it is a rejected request. Here you can see the accepted request in rate limiting and throttling. The policy configuration, 5 requests per 10 seconds window, 1 retry with 500 milliseconds delay. Users send 5 requests within the first 9 seconds. All of them are accepted. At 9.7 seconds, a new request comes in. No quota remains, so the request is delayed for 500 milliseconds. At 10 seconds, the window closes. The quota is reset to 5. At 10.2 seconds, since the start, the since they start then the 0.2 seconds mark of the current window, the queued request is reprocessed. Now there is available quota, so the request is accepted. Available quota decreases to 4. Here the accepted there are 5 accepted requests and one queued request, and then it is accepted after window closed. Here you can see OpenAIM 2.0 token enforcement policy in Mule Gateway, in Anypoint Platform Gateway. This diagram shows how the policy works with an existing OpenAIM or Ping Federate authorization server. OpenID connect token introspection endpoint to process access to your API version. The client application requests the token directly from the authorization server before making an API call. The client application makes this request by authenticating with the user credentials. Then server supplies the client application with the valid token. Next, the client application here. Next, the client application send the valid token in the API call. Here. Then the the server supplies the client application with the valid token, and then the next the client application send the valid token in the API call. Next, the Mule governed by the OpenAIM, OpenID Connect or Ping Federate or token enforcement policy checks that the token in the header or query parameter is valid and matches the correct scopes. The policy invokes the OpenAIM authorization server, Open ID Connect token introspection endpoint or Ping Federate authorization server to validate the token and check the scopes. Finally, the API receives the call from the client application. To improve the performance, Mule caches the call to the authorization server, which is only performed once during the lifetime of the token. If the token is not valid, the authorization server an error. For example, OpenAIM 11.0.0 returns 404 not found. OpenAIM 12.0.0 returns 400 bad request. Ping Federate returns 403 forbidden. Here the authorized app to access the API, and user is connected to send user credentials. User is connected to authorization server via send user credentials. Authorization server is connected to the call app via send valid token, and this is called API. App is connected to the policy via valid token. Check scope and token in the header or parameter, and policy is connected to authorization server via valid token in header or parameter and scope. Authorization service connected to API via API is called. Here you can see the default path before flow after, and error path before exception strategy, and after exception. In creating a custom policy in Mule Gateway, in Anypoint Platform Gateway, you can define before and after exception blocks in custom policy definitions to enhance the cache exception strategy of the flow without need to modify it. Following diagram shows the default path before flow and after, and the error path before exception, exception strategy, and after exception. Any exception in any part of the default path stops the execution of that path and trigger the execution of the error path. Any exception in either before exception or after exception stops the execution of the error path. If the error is raised in the exception strategy, after exception is executed. Here you can see error paths with dash arrows. Here the normal paths. Here the request is sent to before, and before is a normal path, and before is converted to flow through normal path, and flow is converted to after through normal path. And before is here, the before is and the after is converted to the response through normal path. And here the exception strategy is converted to the after exception via normal path. Here the before exception is converted to the exception strategy via normal path, and exception strategy is converted to the after exception via normal path, and after exception is after sending handled error response via normal path. And here the before is connected to before exception via error path, and after is after and flow are connected to before exception via error path. And here the before exception is connected to send the error response, and here the exception strategy is connected to after exception via error path, and here after exception is returning error response. Here the before exception and after exception are in policy and flow, and exception strategy are in app. Policy and app are in API gateway runtime. Here you can see queues in AnyPoint MQ. Message queues provides temporary storage that enables the application to communicate in a scalable and reliable way. Publishers can publish messages into queues, and subscribers can receive the messages from the queues. Here publisher is connected to the queue, and queue is connected to the subscriber. Here the message exchanges in AnyPoint MQ to distribute messages to multiple queues and consumers. Bind multiple queues to a single message exchange. Messages sent to an exchange appear in all of its bound queues simultaneously. For example, if a publisher publishes exchange in weather and multiple apps must receive in the weather, multiple apps must receive the data. Use a message exchange to publish the single message to multiple queues for each app. A binding is a relationship between the queue and the message exchange that tells the message exchange where to send messages. By configuring intelligent message routing rules on binding, you can route messages to the specific routes that are bound to the message exchange. You can bind a queue to multiple message exchanges. You can bind a maximum 450 queues to a message exchange. You can bind a maximum of 10 queues to an exchange, and with message routing rules defined. If an exchange has more than 10 queues binding, you cannot use intelligent message routing. So here the publish is connected to the exchange, and exchange is connected to queues, and queues are connected to consumers. Here an example in AnyPoint MQ. In this example, an app running Salesforce customer relationship manager, here this CRM, uses AnyPoint MQ to communicate with two applications that handle different databases. The Salesforce apps send a pub sub message to an AnyPoint MQ message exchange customer updates. The two applications, customer 1 customer consumer 1 and customer consumer 2 receive the message from the message exchange and send it to the respective databases. Here the CRM is connected to customer updates exchange, and customer update exchange is connected to customer consumer 1 and it is connected to DB, and here the customer update exchange is connected to customer consumer 2 and it is connected to this app. Here you can see how messages are sent to DLQ. This flow chart shows how messages are sent to DLQ in AnyPoint MQ. Here the starting get here the is connected in the start it is connected to get message from the queue, and get message from the queue is connected to delivery acknowledge. If it is acknowledged, it's connected to a message consumed, and message consumed is connected to wait for next customer. And the end here the if the delivery acknowledge is not acknowledged, it is connected to a message return to queue, and it is then it's connected to delivery policy define. If it is yes, it's connected to message check max delivery attempts, and then it's connected to delivery attempts exceeded. Yes, if it is yes, it's connected to move message to dead letter queue. Here the if the delivery policy define no, is connected to the wait for next consumer, and this then end. And the here the if delivery attempt exceed no, then it's connected to wait for next consumer, and then end. Here you can see the configure rules on message exchanges to route messages. AnyPoint MQ includes the ability to create intelligent message routing rules to route a subset of messages published to an exchange to a specific queue. When you configure the message routing rule on the binding on an exchange, when you publish the message to an exchange, the message routing rule routes the message to the queue only if the message includes a property or header that matches the rule. Note that any binding without configured message routing rules continue to receive all messages from the exchange. For example, you might want to designate the queue to handle all order for size medium items and another queue for premium items. To route messages published to an exchange to specific queues, define the message routing rules on the binding between exchanges and the queue. You configure one message routing rule per binding on the exchange, and at any point MQ evaluates the configured message routing rules against all headers and properties attributes in the published messages. To the filtering criteria defining properties and headers in the message. So if you publish for here you can see the exchange purchases, and purchases are connected to queue size medium via binding. Here the binding, here the routing rule item size equal medium. Here the purchases are connected to premium purchase the queue via binding. Here routing rule item category equal premium. Here you can see the workflow for accessing API. The following example with the broker API illustrate the workflow for accessing an API. Steps 1, an app sender request to an AnyPoint MQ and set how long it to hold the lock on the message. 2, lock on the message. 2, the AnyPoint send the message and locked ID. 3, the app acknowledge the message and request AnyPoint MQ to delete the message, or app negatively acknowledge the message and request AnyPoint MQ to make the message available to other apps. The app sends the message ID and locked ID to AnyPoint MQ. If no action is taken and the duration of the lock times to live expires, the message is negatively acknowledged and returns to the queue to be available for other apps. Here the receive request past lock TTL is connected to AnyPoint MQ. To the AnyPoint MQ is connected to locked with message locked with locked ID. 3 here the 3 and 4 are in lock TTL, and here the 3 the ACK and enact and modify TTL with message ID and lock ID is connected to AnyPoint MQ. For here otherwise NACK is with message ID and lock ID is connected to AnyPoint MQ. Here you can see the basic module structure in Java SDK in Mule SDK. The entry point for building a Mule module is an extension annotated class. This class is used to export all module functionality and all the elements associated with it. Warning: this class must be a public and non-abstract class. The extension annotation cannot be used on interfaces, abstract classes, private or protected classes, or type classes with generics. When using at extension annotation, you need to provide descriptive and concise name for the module. You should not use extension, module, or connector in the module name. If you do, the SDK will trim them. Optionally, you can specify the attribute vendor and attribute category. Once you have created an empty module, you can start adding elements to it. Here you can see the basic module structure. At the high level, the elements are components, then operations, sources, functions, routers, scopes on the components, and the connection providers, configurations, and parameters. Components are the key to the functionality of a module. Given set of parameters, they can be executed to produce and alter messages in the flow. Sources and operations are most common component in the module. Operations are component that process an incoming message and generate a result. Sources are component that receive and generate new messages to be processed by Mule runtime. Configurations are set of configurable parameters that affect the behavior of the module. Sources and operations typically depending on the configuration for parameters that determine their behavior. However, some can work on their own without a configuration. There's no requirement to declare configuration for a module, but you can declare as many as you need. Different configuration might provide different set of parameters and specify a set of operations and sources that are only available when using that configuration. Connection providers. A connection provider is a module element in charge of handling connections which are created from the configuration. They centralize the logic and parameterization to provision and release connection of some specific type. Like configurations, sources and operations, connection providers typically depend on connection in order to be executed. A connection is not required, but it is common. Connections used by operations and sources are provided by connection provider. Connection providers are bound to configurations. Configurations have one or many connection providers that create different types of connections. For example, one connection provider for HTTPS and another for non-secured HTTP connections. Parameters are most granular elements on the module model, and they are used in all these elements: operations, sources, configurations, connection providers. They represent configurable element that accept values for element to execute, or they hold the configured values. Other elements, the module can have other element types, for example, routers, scopes, functions, or errors. The ones described here are the core element that most modules are likely going to have. Here the operations are one of the most important Mule concept because they represent the actions your module can perform inside the flow. You can use them to process incoming messages through business logic and that is implemented in the module. Sources, the operation, are components that process the message and generate results. The message sources are components that give received or generate new messages to be processed by the Mule runtime. Functions, database is a main expression language in Mule 4 and Mule SDK is also aligned in that view. This allows you to contribute functions to data view from your module code in a similar fashion that you code your Mule operation. Using custom functions allow you to reuse code in a new way, providing extra functionality in a single module with very little overhead regarding how they declared compared to Mule operation. Routers, conceptually routers are operations that can receive many executable routes and set of parameters that handle the execution of one, all, or none of them. Scopes are similar to operations. but the execution includes the execution of their child operations. This means that the scope is basically an operation that received one or more argument that are simple parameters along with the single chain component and completion callback. Connection providers, connected modules. Connectors are most common types of module. They provide connection between MuleFlow and the external resource. Configure these connections with the connection provider in a connectivity framework to create disconnect and describe the connection for Mule runtime engine to handle. Configurations are set of configurable parameters that affect the overall behavior of your module. All modules are required to have at least one configuration, but you can define as many as needed. Parameters are configurable argument that belongs to an given component. Configurations components and connection providers are called configuration components, and connection providers are called parameterizables because they can be configured through their parameters. Here you can see module is connected to configuration and components. Here the component has operations, sources, routers, scopes, and functions. Here the configuration is connected to components and parameters and connection providers. Here components are connected to parameters, and here the connection providers are connected to parameters. Here you can see the life cycle of a message source in Java SDK in Mule SDK. Unlike operations, where the lifecycle is tied to the owning flow, sources can be started and stopped separately through runtime manager. To support that, the source class forces you to implement onlyStart and onlyStop methods. OnlyStart in this method, you have to initialize all resources such as threads, schedulers, connectors, and so on, and that you need so that you can produce messages. If an exception or error condition is found trying to do that, then you have to release any resources you did not go to allocate, throw an exception with the meaningful message. If a source fails to start, the app that contain will fail to start. Tip: all the resource parameters values are defined through that parameter annotation are resolved and very available at this point. The method is example method is that at override public void onlyStart source callback serializable VM message attribute source callback throws mule exception. OnlyStop. This method will be invoked by the runtime to make the source stop producing messages. This method should not fail. Any exceptions found during the stop process should be logged and correctly handled by the source. But after invoking this method, the source must stop producing messages, free any allocated resources, be capable of being restarted. Here you can see onlyStart method and onStop method. Here you can see a simple flowchart to aid with the decision process of how to use POJOs and parameter groups in DSL decision making in Java SDK in Mule SDK. Here the parameter is connected to is a simple type. If it is yes, then done. If it is not a simple type, then it's connected to can be declared as a global element for templating. If it is yes, it's connected to can be declared as an inline child element. If it is yes, it's connected to annotated the parameter at parameter is and allow inline definition equal true and allow references equal true. Here the parameter as a global element for templating. If it is no, then annotate the parameter at parameter IDs allow references false, and can be declared as an inline child element. If it is no, the annotate the parameter at parameter is allow inline definition equal false and allow references to is true. See the object store version 2 overview. Here the object store version 2. The object store version 2 lets Cloud Hub application store data and it stores states across batch processes, Mule applications and applications from within an application or by using object store REST API. You can select object store version 2 as implementation for Mule 3 and Mule 4 in the Cloud Hub by checking the object store version 2 checkbox in runtime manager at deployment time. On premises, Mule applications can access object store version 2 only via object store REST API. You can configure Mule app to use object store REST API to store and retrieve values from an object store in another Mule app. Here you can see the store is connected to Mule components and user-defined components. Here the batch processes, aggregator, distributed cache until successful, resequencer, idempotency filter, and tokens are in Mule components. API caching, API rate limiting, and distributed synchronization are in user-defined components. You can see RPA lifecycle. MuleSoft provides a complete solution to manage RPA development lifecycle, which includes the following phases. Evaluation. In this phase, you use the process evaluation module in RPA manager to determine if a business process qualified to be automated by evaluating the cost savings and benefits of building the automation based on processes, complexity, stability, and other key values. Design. If the evaluation is complete and the process qualifies for automation, you can start designing the workflow of the automation that specify the actions to perform and the conditions under which to perform those actions. RPA manager uses the business process model and notation BPMN to create the workflows. You can design the workflow manually by using the drag and drop tools in RPA manager or automatically by using RPA recorder. Build. In the build phase, you fill the previously created process with specific instruction for human and bots. With RPA build, you can import BPMN diagram generated in RPA manager and then drag and drop the operation or record key inputs to specify the action steps. When you finish building the process, you upload it to RPA manager. Test. During the test phase, you create different testing scenarios for your automation projects to confirm that they work as expected. This phase works as the qualify assurance step of the development process. In the phase, you can create real-world test scenarios using different parameters and troubleshoot failed steps when there are errors. Deployment. When the automation project successfully completes the testing phase, you are ready to deploy. In the deployment phase, you use the RPA manager to set up the production parameter values, configure the process execution schedule, and select the RPA bots to run the process. You can deploy one automation process to one or multiple RPA bots. Monitor. RPA manager provides different management and monitoring options for your deployment and automations. You can monitor the performance of the deployed automations, configure alerts and notifications when there are issues, and locate the source of these issues. RPA lifecycle, the evaluation, design, build, test, deployment, and monitor. Here you can see RPA builder and builder user interface. The RPA builder user interface has following main areas. One, the Explorer pane to the menu bar. 3, BPMN editor. 4, workflow properties pane. 5 workbench, 6 workflow run results. In addition to the workflow run result, you can also find the process status in this area. Most visual elements in RPA Builder have tooltips. If you ever want to know what the button or settings does, hover your mouse pointer over it for a few seconds. Menu bar. The menu bar contains icons for saving, uploading, uploading, and validation projects. The other icons are shortcuts to various views in the RPA Builder. Explorer pane. The Explorer pane includes 5 tabs: toolbox, project, activity library, repository, and outline. If any of these views are not visible, you can always show them by using the view menu from the menu bar. The toolbox contains a list of elements such as action steps, control blocks which can be inserted into the workflow. Elements are organized in categories, and so you can find the fitting ones easily. By clicking on the start symbol next to an element, you can add it to the category favorites. Elements can be inserted into the workflow using drag and drop. You can find detailed description of each element in the toolbox section. If you input text in the field filter that contains content of the toolbox, it reduced successful to element, the name of which contains this text. Filters is case sensitive. The project tab contains a list of loaded workflows of a project. If you click on the workflows, it also display the workbench. That's where you can easily switch back and forth between the workflows. If you are using repository or for storing your business process, tab Repository Explorer shows a list of available business processes that can be downloaded for editing. If you use the activity library, you can view and delete all available activity templates here. Workflow outline is the shortened view of the open workflow. You can double click on an element mark on the workbench pane. Workflow run results. Workflow run results section shows details information on the last activity workflow that was run. Project status. Project status section provides details information about the validation and scripting generation of the project. Workflow properties grid. Workflow properties grid is located on the right hand side of the screen. In the initial view, it is set to auto hide, but it will expand as soon as you have open or create a workflow. Display all properties of the current section within the workbench. If you click on an element, the description shows in the bottom of the pane. If you enter text in the field filter, the displayed properties are successfully reduced to those containing entered text. Here you can see the workbench elements in RPA. The workbench contains the graphical presentation of workflow. The workflow type shows as a watermark in the upper right corner. The workbench is capable of holding several windows as tabs, which enables you to work on more than one project at a time. Hold the mouse pointer over a tab for a short time, and then the path to the folder where the project is stored shows as a tooltip. Here you can see the multiple workflows organized in tabs. 2 here the project location tooltip, and 3 here the workflow type icon. Here you can see anypoint security. Anypoint security provides a layered approach to secure your application network. These layers work together to protect both application network and the network's individual nodes by controlling access to APIs, enforcing policies, and proxying all inbound and outbound traffic to mitigate external threats and attacks. Anypoint security also provides you with a dedicated endpoint to detect attacks and validate traffic without taxing your network implementation. Policies. Endpoint security features a high performance, reliable and scalable service to enforce policies that apply to all nodes deployed to your runtime fabric. These policies can act as a default firewall or router capability through which all traffic traverses. Secrets manager. Endpoint security provides a secure vault for you to store TLS certificates and key stores used by your deployments. Through Secret Manager, you can store the necessary secrets to set up TLS context that encrypts inbound traffic to your runtime fabric. Tokenization service. Anypoint security tokenization service protects sensitive data from unwanted exposure by replacing key values such as a credit number with the token. Here, a client is connected to endpoint security, endpoint platform, and endpoint security via request. Endpoint security is in runtime fabric and endpoint platform. Endpoint security has policies and TLS validation. Endpoint security is connected to Mule applications. Mule applications and endpoint security are in runtime fabric. Runtime fabric is in endpoint platform. Here you can see endpoint security policies for Edge. Endpoint security features high performance, reliable, and scalable service that works with endpoint runtime fabric to enforce security policies on nodes deployed on your endpoint runtime fabric. Endpoint security provides denial of service (DOS) IP allow lists, HTTP limits, and web application firewall with WAF. Policies to protect your APIs. You can use anytime, anypoint security policies to manage all traffic to a runtime fabric, and leverage API manager policies to apply specific behavior to specific APIs. Anypoint security policies then act as a default router capability through which all traffic traverses. Threat detection and prevention, content attack prevention, HTTP header and message limit checks, denial of service, IP allow list, access advanced TLS, for example, certificate pinning and CRL, basic TLS, for example, mutual TLS, SSL termination, API policies that are configured in API manager and running through API gateway give you capability to further customize or extend certain limitations you are applying at the Mule application level. This layer of security provides the same control as any API manager policy offers. For example, basic TLS, for example, mutual TLS, SSL termination, rate limiting, OAuth, authorization and accounting, AAA, DOS policy. DOS policy are designed to protect your network nodes against malicious client trying to flood your network to prevent legitimate traffic to your APIs. IP allow list policy. So create IP address allow list policy to configure an explicit list of IP addresses that can access your deployed endpoint. HTTP limits policy. HTTP limit policies prevent attacks from clients that send large messages that can consume all your processing bandwidth. WAF policy. Policies provide open web application security project OWASP core rule set for checking requests and responses to detect common web application attacks. Here you can see runtime fabric and endpoint security are in endpoint platform. Endpoint security, DOS policy, IP whitelist, HTTP limits policy. Endpoint security is connected to API policy, rate limit throttling here, and API policy is connected to Mule application. Here the endpoint security is connected to API policy, IP whitelist, and it is connected to Mule application. Here endpoint security is connected to API policy, custom policy, and it is connected to Mule application. Endpoint security, API policy and Mule policies and Mule applications are in runtime fabric here, and runtime fabric is in endpoint platform. Here you can see format pursuing tokens. In endpoint security, endpoint tokenization creates format perceiving tokens, which means the output tokens have the same format as the sensitive data input. Format perceiving tokenization ensures that the changes are not required for existing enterprise data flows or data storage, because the generated tokens conform to the existing data structure and validations. This method minimizes changes to existing applications compared to a point-to-point encryption, which requires data protection implementation at each point. Making detokenization call to the tokenization service returns the identity of the tokenized value. In this example, the tokenization format is created with the credit card data domain and assign that to the tokenization service. Tokenization policy is applied to the API gateway. When a payload that contains credit card numbers in the payload sent, the request is directed to the API gateway that has the tokenization policy applied. The connection is established between API gateway and the tokenization service. Tokenization service receive the credit card information, transform the data into tokens, and return the tokenized data to the API gateway. The API gateway replaces the credit card number with the tokenized data. and a request is sent to the app. Here you can see the client, the order and credit card number, and client is connected to the with the order and credit card connected to the tokenization order and credit card number, and client is connected to the tokenization policy via order and credit card number, and organization policy is in the API gateway, and payload.ccn and credit card number. Tokenization policies connect to the tokenization service via credit card number, and tokenization service is connected to the tokenization policy via token, and tokenization policy is connected to the Mule app order API via order and CCN with the token value. Here you can see the secrets manager in Anypoint security. Anypoint security secrets manager uses secure vault technology to store and control access to private keys, passwords, certificates, and other secrets. Note, if you cannot access secrets manager, or you receive an error saying cannot create secrets groups, you must add the correct permissions in access management. If you need access only to the secrets manager and do not manage instances of Anypoint runtime fabric, add the appropriate user permissions to the access management, then permission, then secrets manager tab. If you manage the instances of runtime fabric, you need to add only the manage runtime fabric permission. You do not need to add the secrets manager permission separately. You use secrets manager to write and manage your secrets, keys, and transport layer security TLS artifacts. You can read the metadata of the secrets, but actual secrets can be consumed only by the authorization platform services on your behalf. Secrets manager is designed to store and manage secrets for supported Anypoint platform services. It is not general purpose storage for secrets. Only trusted services within the platform have access to the content of the secrets. Secrets manager supports the management of TLS context for following services: runtime fabric ingress. You can store TLS artifacts in secrets manager and then configure Anypoint runtime fabric ingress with the secrets reference. Secret manager support the runtime fabric ingress only for RTF on VMs, bare metal appliance products. API manager on Anypoint platform. You can store TLS artifacts in secure secrets manager and then configure Anypoint API manager with the secret reference. Anypoint platform secrets manager enable you to store secrets in secrets groups, which are vaults associated with your environment and business group. Each secret group has unique encryption keys, which are generated and managed only by secrets manager. You can configure supported Anypoint platform services to request secrets stored in the secrets manager, and you can control which supported services are authorized to access them. This task is handled by two microservices. Services secrets manager. This is publicly exposed service that can handle uploading and storing your secrets. Every time you upload secrets to a vault, the secrets manager establishes a reference to it, so it can be shared or read without revealing its contents. You can read secrets metadata, but not the secret itself. Secrets provider. This is the internal service that handles the secrets for consumption by supported platform services. This is only service that can read the actual secrets on, and due to its nature, it is not accessible from the public network. And secret is connected to secrets manager name or password anypoint.mulesoft.com/secrets manager/ and etc. and sg1, and secrets is connected to secrets manager. Secrets manager, Anypoint organization, and secrets provider and support platform service are in Anypoint platform, and secrets manager is connected to secrets group 1 here. This is Vault. Secrets groups are in the here in the organization acme.com here, and secrets group 1 is connected to secrets provider here. Secrets provider is connected to a secret username or password. Secrets is in supported platform services here, so supported platform service here. Here you can see the anypoint service mesh architecture. Anypoint service mesh is an independent architecture layer encapsulated in the Kubernetes or Red Hat OpenShift cluster. In the anypoint service mesh architecture, instead of services directly communicating with one another, a sidecar proxy is used to perform the same job. The sidecar proxy enables you to bring the your existing non-mule application existing non-mule microservices from the Kubernetes from the Kubernetes cluster as APIs into anypoint platform. You can then manage these APIs within API designer. API manager and exchange. Additionally, you can monitor the health of your APIs using API analytics. Because the mixer component is deprecated in Istio version 1.5 and later, the authorization mechanism aspect of the mixer is now implemented by leveraging anypoint service mesh envoy filters. With the envoy filter, requests are sent directly to the adapter, thereby minimizing additional processing. As illustrated in the diagram, at the top of the architecture is anypoint platform, which brings the complete lifecycle API management capabilities to the microservices built with the Mule runtime engine Mule. These Mule instances might be deployed within Cloud Hub or Runtime Fabric at your location. Istio, which is installed on the Kubernetes cluster, uses Envoy to manage services by using a sidecar proxy. The sidecar proxy is responsible for any communication with your service and resides within the same container as that service. With anypoint service mesh enabled, you can continue to use the Istio native policies for traffic control and security. The MuleSoft adapter connect components to the anypoint platform. Along with the broker, and the adapter enables all services that are managed by the mesh to share the metadata, which in turn enables your existing microservices in the Kubernetes cluster to be recognized as APIs anypoint platform. After services are discovered, anypoint exchange uses the metadata to automatically discover and create APIs, HTTP, REST, and SOAP for each service. These APIs can then be managed within the API manager. Similarly, the anypoint monitoring uses the metadata to get information from the sidecar proxy. And makes it available for API analytics. Here you can see the internal and external APIs. Below that you can see the endpoint platform, API-led connectivity for microservices. Discover, manage, and secure are in endpoint platform, and Mule applications are connected to endpoint platform, or aggregated to endpoint platform. Cloud Hub and runtime Fabric are in Mule applications here. The Mule apps are in Cloud Hub, and Mule apps are in runtime fabrics here. And the Kubernetes cluster or Red Hat OpenShift is aggregated into endpoint platform or connected into endpoint platform. Istio is in Kubernetes cluster or Red Hat OpenShift. Mule adapter and containers are in the Istio, and the service A is connected to sidecar proxy. Sidecar proxy interacts with the other sidecar proxy in the container, and service B is connected to sidecar proxy. Here the service request flow is you can see the service request flow in endpoint service mesh here, and when service is called, endpoint service mesh ensures a smooth request flow, and security checks and checks are shown, and the security checks are shown in the following diagram here. One here, the client which might be another microservice, so any Kubernetes ingress component send the request to the service. NOI captures the request and redirect it to the MuleSoft adapter using NOI filter. The adapter then perform the policy checks and verifications. When no policy violations are encountered, when no policy violations are encountered, the request is routed to the microservice. For the microservice runs the service logic and send the response back to the client. And periodically adapter communicates with the endpoint platform asynchronously to get the latest policies and contracts. 6. The periodically adapter returns the API analytics information to endpoint platform. Here you can see the service user is connected to client. Client is connected to Envoy microservice and Envoy filter in one group here, and Envoy filter microservice and Mule adapters are in runtime plane in Kubernetes cluster. Here the Envoy is connected to Mule adapter. And Mule adapter then is connected to Envoy filter. Then the Envoy is connected to microservice, and here the Mule adapter interacts with endpoint platform via adapter, gets new policies and contracts, and here the Mule adapter interacts with the platform via adapter, pushes the API analytics. Here you can see configure endpoint. Here you can see the flow for the configuring endpoint service mesh using the CLI in endpoint service mesh. Endpoint service mesh command line interface. CLI is a unified uh, tool that enables you to easily manage your resources. The CLI provides a layer of abstraction over Kubernetes operations. You can use CLI in an interactive mode from the command prompt or in an uninteractive mode for automating scripts. The following diagram illustrates the flow for configuring endpoint service mesh using CLI. Here start is connected to provision adapter using CLI. Provision adapter using CLI is connected to API. Create API using cluster resources. The question and if it is yes, it is connected to create API using endpoint service mesh. Create API using endpoint service mesh and bind resources using Kubernetes resource name in endpoint service mesh. Auto creates a feature. Create API using endpoint service mesh is connected to bind service using Kubernetes resource name. Bind service using Kubernetes resource name is connected to manage APIs, and manage APIs are connected to stop. Create APIs using cluster resources. If the answer is no, then it's connected to create API using endpoint platform and bind service platform. Create API using endpoint platform and bind service using API ID in endpoint platform. Create API using endpoint platform is connected to bind service using API ID. Bind service using API ID is connected to API manage APIs, and manage APIs are connected to stop. Here you can see the flow for configuring endpoint service mesh using the CRD. If you deploy and manage your Kubernetes objects and your microservices using CRDs, you might find it easier to also provision the endpoint service mesh adapter and bind the service using CRD instead of using CLI. If you have configured continuous integration in your environment, provision the adapter and bind your services using CRDs. Following diagram illustrates the flow for configuring endpoint service mesh using CRD. Here the start is connected to provision adapter using CRD, and provision adapter using CRD is connected to create API using cluster resources. If the answer is yes, it is connected to create API using endpoint service mesh. Create APIs using endpoint service mesh and bind the service using Kubernetes resource name in endpoint service mesh in auto create feature. Create APIs using endpoint service mesh is connected to bind service using Kubernetes resource name. Bind service using Kubernetes resource name is connected to manage APIs, and manage APIs are connected to stop. And here the create APIs using cluster resources are resources. If the answer is no, it is connected to create APIs using endpoint platform. Create APIs using endpoint platform and bind service service using API ID in endpoint platform. And create APIs using endpoint platform is connected to bind service using API ID. Here you can see synchronous communication in runtime manager agent architecture. Example, get deployed applications. Here the actor is connected to interacts with the agent, and agent interacts with the mule. Here you can see the asynchronous communication in runtime manager agent architecture. Example, deploy and notify about the deployment stages. Here the actor is connected to agent, and agent interacts with the mule, and agent is connected to actor. Here you can see the push communication in runtime manage agent architecture. Example, push JMX information into an external system. Here the actor is connected to the agent, and agent interacts with mule, and agent is connected to external system. Here you can see architecture diagram in runtime manage agent architecture. The agent architecture is quite simple. Transports handle communication. External message handlers dispatch messages. Services connected to Mule. Internal message handlers dispatch Mule internal message handlers dispatch Mule notifications. The interaction of each component is shown in the diagram below for each of three types of messages. Synchronous and asynchronous and push. How components interact. Below is the outline of typical sequence of component interaction. One, the external system send a request to an agent. Two, the external message handler is executed and calls the Mule service using interface. Three, the Mule service call the Mule to perform the corresponding action. For the Mule response with a notification. 5, the service maps the notification to an agent notification and looks for the internal message handlers that may handle the notification type. 6, the corresponding internal message handlers are executed. Here you can see REST client interacts with the REST transport. Here the REST transport and WS transport are in transports. REST transport interacts with the REST application external handler. The REST application external handler and WebSocket application external handlers are in external handlers. Here the REST application external handler interacts with the deployment, poll management, event tracking, asynchronous or synchronous, and deployment, poll management, event tracking are in agent services, and the then the deployment, poll management and event tracking interacts with the Mule API. Event deployment is connected to WebSocket deployment stage notifier. WebSocket deployment stage notifier and CloudWatch event handler are internal handlers. Here the WebSocket deployment stage notifier is connected to WS transport and WS transport is connected to the WS client, and here the event tracking is connected to CloudWatch event handler. CloudWatch event handler is connected to CW. Here the WS client is connected to WS transport. WS transport is connected to WebSocket application external handler that interacts with deployment, poll management and event tracking. Event tracking is connected and the deployment is connected to WebSocket deployment stage notifier, and WebSocket deployment stage notifier is connected to WS transport. WS transport is connected to WS client, and the event tracking is connected to CloudWatch event handler, and CloudWatch event handler is connected to CW. Here you can see Anypoint Runtime Manager. Anypoint Runtime Manager is the instance of Anypoint platform that provides a unified view of your application, servers and APIs. With Runtime Manager, you can deploy, manage and monitor your Mule application in a sandbox, staging or product environment from one central location, whether your apps are deployed on cloud or on premises. You can use Runtime Manager in these scenarios. Cloud Hub. Mule host your deployment in Cloud Hub, and you use Anypoint Platform Runtime Manager Cloud Console to manage them. Cloud Hub is a complete integration platform as a service, IPaaS, that automatically meets all of your server needs without requiring any configuration or customization, including object store infrastructure, monitoring, troubleshooting, and scheduling. For applications deployed on Cloud Hub, you can use Insight for analytics and monitoring. Hybrid, your on-premises Mule servers host your app deployment, and you use Anypoint platform platform runtime manager cloud console to manage them. For applications that you deploy on premises, you can send data to third-party analytics applications. If you are using MuleSoft Government Cloud, you can deploy Mule Runtime Engine to a private cloud or on-premises environment and manage your apps and deployments using your MuleSoft Government Cloud control plane. Anypoint platform Cloud Edition. Your local Mule servers host your app deployment, and you use the on-premises runtime manager instance included with the Anypoint platform PCE to manage them. If you are using the on-premises runtime manager, you can deploy anywhere except Cloud Hub. For applications deployed to your private cloud servers, you can send data to third-party analytics applications. Anypoint Runtime Fabric. Your local hosted runtime fabric instance host your app deployments and use Anypoint platform runtime manager cloud console to manage them. Note, when you run an app in Anypoint Studio, the app deploys an embedded test server in Studio because this server is not meant for production deployment, and uptime restriction apply. Deploy your Mule app using one of the deployment options supported by the runtime manager. Here you can see the Anypoint Runtime Manager Cloud is in Cloud Hub and Insight are in Anypoint platform here. Here Anypoint Runtime Manager Cloud is connected to a Mule app deployment on Cloud Hub. It is in the Cloud Hub, and Mule app deployed on Cloud Hub interacts with Insights. Here the Anypoint Runtime Manager Cloud in Anypoint platform is connected to Mule app deployed on premises servers in hybrid, and Mule app deployed on premises servers interacts with third-party integrations, Splunk, ELK, Slack, and Anypoint Runtime Manager Cloud interacts with is connected to a Mule app deployed on Runtime Fabric in Anypoint Runtime Fabric. Here Anypoint Runtime Manager on premises is connected to Mule app deployed on PCE. Anypoint Runtime Manager on premises and Mule app deployed in PC are in Anypoint Platform Private Cloud Edition. Here you can see my MuleSoft architecture and API-led connectivity. Want to understand MuleSoft architecture and API-led connectivity? The MuleSoft approach to integration of data from different systems using layer APIs allows you to spend less time on IT projects and more time on your core business. Whenever you turn a business process into an API, you make it easier to implement that process in the next project, and the API have proven to be best size of reusable code. Anypoint platform helps you build a structured application network that connects applications, data and devices with reliable with reusable APIs. The unified endpoint platform makes it easy to discover, create, and manage APIs in modular organized layer. instead of retrieving random and possibly unstable code snippets, you can shop for API created using industry's best practices. Here the mobile is connected to mobile APIs. Here the mobile API and web app API in experience APIs, and shipment status, order status, customers, and order history are in process APIs. Toll ships, UPS ships, shipments, and shop customers, Salesforce customers, and orders are in system APIs. Here the mobile is interacts with the mobile API and mobile API is connected to interacts with the shipment status, order status, and order history. Order status interacts with the customers and orders in system API. Here the shipment status interacts with the Troll shipments and UPS shipments, and Troll shipment is interacts with Troll, and UPS shipment interacts with the UPS. Here the mobile app interacts with the order status, and order status interacts with the customers. Customers interact with the SAP customers in system APIs, and SAP customers interact with SAP. Here the customers interact with the Salesforce customers, and Salesforce customers interact with Salesforce, and order status interacts with the orders, and orders interact with the orders here. Here the web app API interacts with the order status and order history. Here the order status interacts with the orders and orders interact with the orders, and here the order status interacts with the customers, and customers interact with the SAP customers, and SAP customers interact with the SAP, and order customers interact with the Salesforce customers, and Salesforce customers interact with the Salesforce. And here the web app API interacts with the order history, and order history interacts with the customers again, and order history interacts with the orders here. Here you can see the API-led connectivity. API-led connectivity is a methodological way to connect data to applications through reusable and purposeful APIs. These APIs are developed to play a specific role, unlocking data from systems, composing data into processes, or delivering an experience. When the entire organization adopts what is known as API-led connectivity, everyone in the business is empowered to access the best capabilities, delivering applications and project through discovery, self-creation, and reuse. API-led connectivity not only depends on three categories of reusable APIs to compose new services and capabilities, but also decentralizes and democratize access to enterprise data. Central IT produces reusable assets, and in the process unlocks the key systems, including legacy applications, data sources, and SaaS apps. Central IT and other teams can then use these API assets and compose process level information. Then the app developers can discover and self-serve on all these reusable assets, creating the experience layer of APIs and ultimately the end applications. This API-led approach to integration increases agility, speed, and productivity. Here the system APIs, decentralized access to core assets, interacts with here the mobile and other stuff interacts with the experience API, the innovation and digital products. Experience APIs, innovation and digital products interacts with process APIs, agility and new value creation. Process APIs, agility and new value creation interacts with system APIs, decentralized access to the core assets. System APIs, the decentralized access to the core asset interacts with SaaS apps, mainframe, FTP files, databases, web services, and legacy systems. Here you can see the accessibility and ownership. Central IT is connected to LobDev IT. LobDev IT is connected to AppDev, and Central IT is connected to the system APIs, and LobDev or IT is interacts is connect. It's related to process APIs, and AppDev is related to experience API. Here this is the decentralization, and developer communicates knowledge, assets, and exchange here. C4E. How does API-led connectivity reduce IT's workload? API-led connectivity has an important role to play. This is because IT is often tasked with implementing these new technologies and making the necessary changes, as well as maintaining legacy systems and their connections to other systems. The request they must fulfill is ever growing, and even as their resources stay constant, eventually what result is then IT delivery gap. The number of new projects necessary to implement today's technology needs measured against IT capability to deliver them is spiraling upward, and as the technology requirement of the business continue to grow in the multiplicative fashion, IT resources only grow in linear way. No matter how many resources in a business can throw at the problem. According to our connectivity benchmark report, most of IT decision makers are expecting their budget to either stay the same or increase very slightly. So unlimited resources are not an option. That is why IP-led connectivity is better integration strategy. Here the you can see the time here and demands on IT. Here the IT delivery capacity, and here the cloud and SaaS, and here the with time, and the SAP upgrade, and here the mobile, and here the security and regulation. Here you can see MuleSoft endpoint platform in a different architectural view. MuleSoft endpoint platform is a powerful framework to help both in marketing and in making and utilizing association between independent frameworks. This can essentially make an application network where already detached wellsprings of data meet up to address your business issues. Incidentally, in case you are inexperienced with MuleSoft yet, you can study the fundamentals here. Few steps to get the most out of MuleSoft. Thinking about integrating your organization frameworks utilizing MuleSoft endpoint platform. Here are some significant steps to consider. Not a large number of these should be done well before you really implement endpoint or make any APIs streams. Focus on your business outcomes. What does your organization need to see? Where might a single view on data help you acquire efficiencies and increment sales? Where is the current problem that requires the physical handling of spreadsheets with many lines of data? Build up a plan for key matrices and reports. This pattern will help your user group set up the endpoints and flows required in the platform. Here you can see endpoint API. Here customers and partners or suppliers, and cloud platforms, and SaaS, and social and mobility and devices interacts with endpoint API manager. Here with the mobility and devices are new, and the customers, partners, and suppliers has an interface here. Endpoint API manager interacts with endpoint connectors. Cloud Hub and MuleSoft, Mule ESB are in endpoint connectors. Here the API kit is new here, and Anypoint data mapper and Mule Studio. Here you can see the API hub. Anypoint connectors interacts with Anypoint service registry. Anypoint service registry interacts with packaged app, customer apps, and databases. Here you can see API-led connectivity. The MuleSoft define API-led connectivity through the lens of a three-tiered approach. These three layers are made up of experience API, process APIs, and system APIs. Here the mobile interacts with the mobile API, and here the computer interacts with the web app API. Here the mobile API and web app API are in experience APIs. Here the shipment status, order status, customers, and order history are in process APIs. Toll shipments, UPS shipments, SAP customers, Salesforce customers, and orders are in system APIs. Here the mobile API interacts with the shipment status, and shipment status interacts with the toll shipment, and toll shipment interacts with the toll, and then shipment status interacts with the UPS shipment, and UPS shipment interacts with the UPS. Here the mobile API interacts with the order status. Order status interacts with the customers. Customers interacts with the SAP customers, and SAP customers interact with SAP, and the customers interact with the Salesforce customers, and Salesforce customers interact with the Salesforce. Here the customers interacts with the order history here, and the web app API interacts with the customer status here, and here the mobile API interacts with the order history, and order history interacts with the customers, and order history interacts with the orders, and orders interact with the orders here. And here the web app interacts with the order status, and order status interacts with the customers, etc. And the web app interacts with the order history, and order history interacts with the customers and orders, etc. Here you can see event-driven architecture. Although the applications components exchanging events can be organized similarly, this is not an inherent part of the event-driven architecture. API connectivity restricts the communication patterns according to the three tiers, essentially top to bottom, whereas the application component exchanging events do not have adhere to the same communication pattern restrictions. API implementation typically have well-defined static dependencies on other APIs or backend systems. While the similar relationship may materialize in the event-driven architecture at runtime, there is no static dependencies between the application component exchanging event. Instead, these application components only depend on the exchange event types, the destination and message broker hosting those destinations. Furthermore, the event consumers may change dynamically at any time, thereby dynamically reconfiguring the relationship graph of the application components in an event-driven architecture without event producers becoming aware of that change. Event-driven architecture requires a message broker as an additional component of the technology architecture, with all application components with which exchange events having to agree on same message broker. API-led connectivity and in particular application networks are defined by API-centric assets published for self-service consumption. The equivalent for an event-driven architecture would resolve around destination and event types. Here the you can see the event producer, event transport, and event consumers. Here the producers are connected to event transport. Broker, queue, topic, and message exchange are in event transport, and consumers are in event consumers here. Event transport is connected to consumers here. Here you can see the API-led architecture. API-led connectivity is multi-layered approach that scales IT capability through its emphasis on modular components. a decentralized authority over application development, reusable assets, application development and reusable assets. It is a functional shift. It is a fundamental shift in the IT operating model and promotes decentralized access to data and capability while retaining security. API-led connectivity calls for distinct connectivity building block with three components: interface, presentation data. Interface, the presentation of data in a governed and secured form via an API. Orchestration, application of logic of data such as transformation and enrichment. Connectivity, access to source data, whether from physical systems or external services. System layer. System APIs provide means of accessing underlying systems of record, for example ERP, billing systems, etc., and exposing that data while providing downstream insulation from any interface changes or rationalization of these systems. These APIs are changed more frequently and are governed by central IT given the importance of underlying system. Process layer, the business processes that interact with and shape this data should be encapsulated independently of the source systems from which data originates, as well as the channels through which data is delivered. These process APIs perform specific function, provide access to non-centralized data, and may be built by either central IT or line of business IT. Experience layer, data is now consumed across a broad set of channels, each of which want to access the same data but in a variety of different formats. Experience APIs reconfigure data so that it is most easily consumed by its intended audience, all from a common data source, as opposed to setting up separate point-to-point integration for each channel. Here you can see the Experience API, purpose-built APIs for apps. And Experience API interacts with Process APIs, orchestration, composable APIs, and microservices. Process APIs interacts with system APIs, legacy modernization, connectivity to SaaS apps, and web services, and RESTful apps. And system APIs interacts with SaaS apps, mainframe, web services, FTP files, databases, legacy systems, and applications. Here, accessibility and ownership here. So, central IT, then LOB, DOV, IT, then AppDev. Here you can see the API-led connectivity with EDI context. In the EDI context, API-led approach provides flexibility to serve different partners as well as control over core systems. Using the retail industry as an example, below is here is the diagram of API connectivity can coexist with EDI. In this example, we show the following APIs: system API layer. This layer provides consistent managed and secure access to backend systems by abstracting and unlocking the data core systems such as legacy backend databases, SAP, and Salesforce to create products APIs, order APIs, and partner APIs. Process API layer. This layer takes core assets and combines them with the business logic to create more value by aggregating data extracted from the product. Order and partner APIs, the sales order, invoice, and shipping notice APIs are created. These APIs process the purchase order, check inventory levels, and create appropriate acknowledgement notices necessary for partners. Experience API layer. This layer is designed for consumption by a specific end user app or device that will be exposed to partners. Anypoint Partner Manager create a partner profile that can be templatized and reused from partner 1 to partner 2 if the new partner requires similar B2B or EDI formats. For example, EDI 850 via AS2. This will ultimately be exposed to partners via a web channel or portal to allow for B2B transaction statuses to be viewed and the associated payloads to be viewed or downloaded. The architectural benefit of this approach includes creating a decoupled architecture that abstracts away complexity and having a more agile response to change. All channels are able to reuse the same process logic, so as new partners are onboarded, all that's left to manage is the logic of receiving messages. The purchase order processing logic is already backed in, thus allowing the retailer to move quicker. This approach can be taken one step further, and retailer could apply the API-led connectivity approach to the experience API layer 2. In this scenario, trading partners can submit purchase orders via a partner API and create the required EDI 850 message to process the purchase order document. In this way, it could be onboard partners more quickly by eliminating intricacies in EDI for franchises that may not have an EDI gateway, or for new retail channels like kiosk that do not speak EDI. To access this EDI, and here you can see partners. Partner 1 interacts with here you can see EDI 850, EDI 810 and EDI 856 in partner 1, and here EDI 850, EDI 810 and EDI 856 in partner 2, and here EDI 50, EDI 810 and EDI 856 in partner 3. Here partner 1 interacts with the partner 1 in experience layer, and here the partner 2 is interacts with partner 2 and partner 3 interacts with partner 3. Here the partner 1, 2 and 3 are in experience API. Message mappings partner specific, and experience API interacts with process APIs, business processing partner agnostic. Here the partners interacts with the invoice here. Here the sales order, invoice and shopping notice are in process APIs. Process API interacts with system APIs. Here the sales order, invoice and shopping notice interacts with product API, order API and partner API. Here the product API interacts with product and database, and order API interacts with SAP and partner API interacts with the Salesforce. Here you can see sales central IT, then in parallel with system API, and then it's connected to LOB div or IT, and it's connected to app div. LOB is in parallel with process API, and div app in parallel with experience APIs. Here you can see endpoint platform. What is MuleSoft endpoint platform? The MuleSoft endpoint platform is a unified single solution for IPAAS and full life cycle API management. Endpoint platform consists of following major components: endpoint security, endpoint design center, endpoint management center, endpoint exchange, runtime engine and services, API led connectivity, application network, and data view. Here you can see design, manage, engage, run and scale in endpoint platform. Here the design interacts with engage, manage, and run and scale. Here design the Anypoint Studio, Anypoint Design Center. Here the manage, Anypoint monitoring, Anypoint management center. Manage interacts with design, engagement, run, and scale. Here the engage, Anypoint exchange. Engage interacts with design, manage, and run. Here the run Mule, Mule 4. Run interacts with design, engage, and manage, and scale. Here the scale, Anypoint security, tokenization and edge, Anypoint runtime fabric, scale runtime services. Scale interacts with design, run, and manage. Here the Anypoint platform interacts with on promises and private cloud, hybrid, hosted by MuleSoft, and cloud service providers. Here you can see the relationship between design tools and other MuleSoft products. Anypoint Design Center includes a web-based tool where MuleSoft developers design and create API specifications and fragments. API designer. Once your API specification or fragment is ready to be shared with the rest of the organization, you publish it to Anypoint exchange. Here for testing and approval, this development approach is called spec driven. Before moving into API implementation phase, it's crucial to get the sign off from the business and other teams involved. They will test the API returning mocked result, provide initial feedback, and validate requirement. Anypoint exchange is a virtual market to share, discover, and reuse APIs, connectors, and templates. The other parts of the design center, Flow Designer, is used to build Mule applications that connect system into workflows. Here, this diagram illustrates the relationship between design tools and other MuleSoft products. Here, the specification writer uses API designer, and here the developer uses Anypoint Studio. Anypoint Studio imports API specification and as connectors for Mule apps from API designer, and Anypoint Studio imports API specifications as connectors for Mule apps from Anypoint exchange. API designer publishes specification and fragments to and imports them from Anypoint exchange. Anypoint designer can create dependencies on assets in Anypoint exchange. Here the API designer and Flow Designer are in Design Center, and Design Center, Anypoint exchange, and API manager in Anypoint platform. Here the citizen integrator uses Flow Designer. Flow Designer imports the API specification as connectors into Mule apps from here the Flow Designer imports API specification as connectors into Mule apps from Anypoint exchange, and the developer uses API manager, and API manager imports API specification from Anypoint exchange. Here you can see main parts of the of Anypoint platform. Anypoint platform can be deployed in a variety of different ways, including both cloud and on-premise options. From the deployment point of view, it's important to understand the platform is divided into two fundamental parts. And this is shown in the diagram here. Control plane runs in AWS, and for example, and is made up of design center management. Made up of design center, management center, and exchange. No customer data reside in the control plane, and just metadata specific to the APIs. Runtime plane can run on Cloud Hub, for example AWS, public and private cloud, and customer data center. This is where runtimes are based, the engine operating the APIs. This offers a single tenancy and is where customer data is processed. Here you can see a control plane running in AWS. Here the data, the no customer data, API metadata. Anypoint design center here, and it includes a studio, API designer, connector, div kits, and API design interacts with the API, anypoint management center, and anypoint exchange. Here the anypoint exchange interacts with anypoint design center and anypoint management center. In the runtime manager, API manage and analytics are in anypoint management center. Anypoint exchange, then the runtime plane is connected to control plane via one-way mutual TLS connection. Here the Mule is connected to anypoint exchange via one-way mutual TLS connection. Runtime plane running in Cloud Hub, AWS, public cloud, private cloud, customer DC, and single tenant APIs and integrations, data, customer data. Here the Mule interacts with hybrid cloud, runtime services, and anypoint connectors. Anypoint connector interacts with Mule, hybrid cloud, and runtime services. Hybrid cloud interacts with Mule and anypoint connectors and runtime services, and runtime services interacts with Cloud Hub, anypoint connectors, and Mule. Here you can see MuleSoft Universal API Manager, UAPIM. You might already have some internally developed or supplied by your SaaS providers API running on a cloud platform like the AWS or Azure. Many of you use an API managing tools to build application on microservices architecture. With multiple APIs scattered all over the organization, you might come to a point when reinforcing standard security regulations and compliance become almost impossible. Furthermore, the teams have a hard time finding APIs for reuse, leading to duplication of efforts, not to mention challenges managing these APIs from multiple management consoles. MuleSoft has recently launched a Universal API Management, UAPIM. Its capabilities include Flex Gateway, API Manager, API Governance, and Experience Hub. Regardless of their origin or where they are physically running, API can now be categorized, catalogs, and managed under one roof. API management creates a single source of truth for your organization integrations and enforces industry compliance and company standards to secure your microservices and APIs. The digital marketplace makes your APIs searchable and consumable while allowing you to stay in control and monitor their use. Here you can see universal API management with MuleSoft. Discover, manage, secure, and monitor an endpoint platform. Mule apps and integrations aggregate endpoint platform aggregate Mule apps and integrations, and endpoint platform aggregate Mule microservices, distributed API, and dedicated gateways. Mule apps and integrations here: Cloud Hub, RTF, and on-premises. Here microservices, distributed API, dedicated gateways, AWS, Azure, GCP, Docker, containerized Kubernetes, and on-premises. Here you can see a monolithic architecture. Monolithic architecture could be defined as the first in the single unit. Monolithic architecture can be defined as the first architecture, simple and tightly coupled applications. They are executed in a single application layer and group all functionality in some same one. If for example we want to access another service or system through an API, we must develop business logic as well as error management and so on the application itself. The following diagram shows a simple example of monolithic architecture on a custom relationship management. Here you can see application server interacts with the web application. Here they add to cart, delete from cart, return purchase, track order, check inventory, price item, checkout, and purchase are in web application, and web application interacts with SAP, mail, API, and Salesforce and database. Here you can see monolithic architecture, single unit. For small architectures they work well, but when the architecture grows, the application is more complex and complex to manage and refactor. In addition, it makes continuous integration more complicated to carry out, making the DevOps process almost impossible to accomplish. Communication between resources or application is direct without any other middleware ESB intervening. It even increases the level of difficulty when it comes to implementing communication with a web service in some languages such as Java, where the connection with the SOAP service is complex. Here the web application server interacts with web application and mobile application. Here the web add to cart, delete from cart, return purchase, track order, purchase, checkout, price item, and check inventory are in web application. Here the mobile add to cart, delete from cart, business, return purchase, track order, purchase, checkout, price item, and check inventory are in mobile application. Here the web application interacts with SAP, mail, API, Salesforce, and database, and here the mobile application interacts with SAP, mail, API, Salesforce, and database. Here the example customer relationship management with monolithic architecture. Here you can here now we are considering SOA architecture, coarse-grained. SOA, service oriented architecture, already allows for greater decoupling and therefore evolution to a more diversified architecture, or as they call it, coarse-grained. This is the original architecture of MuleSoft, the ESB that allows to centralize all business logic. And allows the connection between services. An application regardless of their technology or language in a fast and simple way. MuleSoft offers a Mule runtime similar to Apache Tomcat, which works as a servlet container as defined in the following diagram. In this way, we eliminate all the work and most of the business logic to the application with monolithic architecture. the ESB will be here you can see the here application server interacts with web application and mobile application. Web application and mobile application interacts with Mule runtime instance or service. Mule runtime instance of service interacts with SAP, Mail, API, Salesforce, and databases. This is a classic SOA architecture in related to customer relationship management. Here you can see the SOA architecture, coarse grained. In this way, we eliminate all the work and most of the business logic to the application with monolithic architecture. The ESB will be in charge of transforming data, routing and accessing the necessary services, managing errors, etc. The source application will simply generate a message if necessary and send it to the ESB via HTTP request. However, one problem persists, and that is that all the integrations deployment work on the same runtime by leading it to the coupling and to an architecture that continues to have monolithic nature. For example, when you apply configuration in runtime, it will be applied to all your deployed applications. Here the customer relationship management. It's classic SOA architecture. Application server interacts with web application and mobile application. Mobile application interacts with service web application and mobile application interacts with service bus. Add to cart, delete from cart, return purchase, track order, purchase, checkout, price item, and check inventory are in service bus. Service bus interacts with SAP, Mail, API, Salesforce, and database. And here you can see microservice architecture, fine-grained. Finally, the fine-grained one. This architecture imitates SOA, but with smaller and independent services. Microservices bring a lot of complexity to the architectural level, as there are many small actors involved. But advantage is that they are all isolated and independent. The time limits, the limits must be very clear. Reducing it too much can end up with a very complex and excessive architecture. The use of microservices requires a great change in mentality. Things must be simple, well documented, simple to execute. This is why the development cycle should be used to execute, implement, and evolve quickly. MuleSoft has evolved and is no longer just a middleware with SOA architecture. Now also focuses on the architecture of microservices with its integration as a service SaaS platform, endpoint platform. In this way, through its Cloud Hub by storage, integrated with endpoint platform, you can deploy applications so that they are automatically created in the separate instances without realizing it. Here you can see the sample customer relationship management. Here the application server interacts with the web application and mobile application. Web application and mobile application interact with the experience layer here. Add to cart, delete from cart, return purchase, and purchase are in experience layer. Experience layer interacts with process layer. Checkout and price items are in process layer. Process layer interacts with system layer. Check inventory and track orders are in system layer. System layer interacts with SAP, Mail, API, Salesforce, and database. In addition, here you can see Microsoft microservice architecture fine-grained in customer relationship management, for example. Here, in addition, my MuleSoft methodological way of connecting data and applications to reusable and useful APIs. The API-led connectivity which helps to decouple between implementation and API. API-led connectivity is divided into 3 layers: experience layer, process layer, and system layer. The first layer is the one that interacts with the client and has no implementation. The only an exposed API that can be managed and secured. Here you can see a sample customer relationship management. Application layer interacts with web application and mobile application. Mobile application and web application interacts with experience layer. Add to cart, delete from cart, return purchase, and purchase are in experience layer. Experience layer interacts with process layer, which is microservice layer. Checkout and price items are in process layer. Process layer interacts with system layer. This is a microservice layer. Microservices layer. Check inventory and track orders are in system layer. System layer interacts with SAP, Mail, API, Salesforce, and database. Here you can see the Microsoft architecture fine-grained. Here the experience layer is there, and the remaining layers contain the implementation. The process layer interacts between API exposed and the system layer that connect to the necessary services. Database, SAP, Salesforce, Mail, e-commerce, etc. Here you can sample relationship management. Application server interacts with web application and mobile application. Web application and mobile application interacts with the experience layer, that is API, which interacts with the API manager. Add to cart, delete from cart, return purchase, and purchase are in experience layer. Experience layer interacts with the runtime manager and cloud hub here. And the process layer interacts by process checkout and price item are in process layer. Process layer interacts with the system layer. Check inventory and track orders are in system layer. Experience layer interacts with API manager, and process layer and system layer interacts with the runtime manager and cloud hub. API manager and runtime manager or cloud hub are in endpoint platform. Here the system layer interacts with the SAP, Mail, API, Salesforce, and database. Here you can see the microservice architecture fine-grained as a customer relationship management, but still there are one more evolution thanks to endpoint runtime fabric and runtime manager integrated with the endpoint platform. These applications can be deployed on a runtimes in instances, in infrastructures managed by the client in AWS, Google Cloud, Azure, virtual machines, or bare metal. Here you can see the application server interacts with web application and mobile application, and web application and mobile application interacts with the API manager. Experience interact with the API manager, and add to cart, delete from cart, runtime purchase, and purchase are in experience layer. Experience interacts with process layer. Checkout, price, and price items are in process layer, and process layer interacts with system layer. Check inventory and track orders are in system layer. Process layer interacts with cloud instance, and system layer interacts with cloud instance. These cloud instances interacts with ASUS, AWS, or Google Cloud. API manager, Azure, AWS, Google Cloud, and cloud instances, and process layer, system layer, and experience layer are in endpoint platform here. System layer interacts with SAP, Mail, API, Salesforce, and database. And here you can see the Microsoft microservices architecture in fine-grained. For customer relationship management as an example. for container, for containers, although it requires Docker's knowledge. Here the application server interacts with web application and mobile applications. Web application interacts with the web application, and mobile application interacts with the experience layer. Experience add to cart, delete from cart, return purchase, and purchase are in experience layer. Experience layer interacts with API manager. Experience layer interacts with the process layer. Checkout and price items are in process layer here. Process layer interacts with the Docker container, and here the process layer interacts with the check inventory and order track order, and system are in system layer. System layer interacts with the Docker container, and Docker containers interacts with the Azure, AWS, or Google Cloud, and API manager and Azure, AWS, Google Cloud, and Docker container. These are and process layer, system layer, and experience layer. These are related to any point platform. System layer interacts with the SAP, Mail, API, Salesforce, and database. Here you can see MuleSoft API cycle. MuleSoft API cycle tells us how effectively and efficiently we can use MuleSoft Anypoint platform while going through different stages of API lifecycle. Anypoint platform provides us all the required tools and features to develop and maintain the APIs within organization. Here is the lifecycle which MuleSoft suggests. API lifecycle start with the requirement, where a team or organization come up with their business need for integration. MuleSoft development team analyze the requirement, come up with the proper implementation architecture. MuleSoft suggests API-led approach for implementation. Assuming all requirements are clear and required documents like high-level design, service-level design, and mapping sheets are already created for the API. Here are the different phases in API lifecycle. Design. API designer. It is a web-based tool to design APIs, REST interfaces, or specification as per the requirement. While creating the interface, it will validate the interface for any syntax error and highlight the same. It also shows the tab to validate the interface, where it shows the mock interface. Prototype. Flow designer. It is a web-based tool to implement the actual API without using the Anypoint Studio. This is helpful when we have to create a small box and have to validate implementation logic. It's a part of Design Center only. Mock service. It is again one of the feature in Design Center through which we can quickly validate the API specification. This only provides the mock API without any actual implementation, and the developer can validate the request and the response of API. Validate. API console. This is used to validate the API specifications, different vendors or clients. Whenever code is generated in the Anypoint Studio using RAML, then the default API console code is also generated. API console only comes when Mule application is deployed on a Mule runtime. Advantage of API console is it can be shared outside the organization, and the client don't need to access Anypoint platform to validate the same. This is a recursive process where we keep on validating an RAML design specification with client or vendors, and based on the feedback, either we again follow the process RAML design to mock service design to validate, or move ahead with the development. When we receive the positive feedback from the client or vendor, we move to develop and testing phase. Develop. To start with the development, Mule provide an Anypoint Studio, which is an IDE for developing and testing Mule applications. It provides the feature through which it can directly download the API specification RML from Design Center and create a base Mule application. Testing. Anypoint Studio also come with the local Mule runtime on which we can run the Mule application and validate the same. It run in the debug mode as well. This is really helpful in debugging. MUnit framework also comes with Anypoint Studio, which is similar to JUnit and help the developer to verify internal logic. Deploy Runtime Manager. Runtime Manager is available in Anypoint platform and used to manage the Mule runtimes. Mule runtime is an engine or container in which the Mule applications are deployed and run. This can be on-premise or cloud hub Mule runtime and configured in Runtime Manager accordingly. Operate. API Manager is again available on Anypoint platform. It is an API management tool using which the organization can secure and restrict the access on APIs. It provide out-of-box policies and policies creation in which can be applied on different APIs. Anypoint Analytics. It is a feature available in API Manager and it provides useful information on how APIs are accessed. This is similar to Google Analytics and provide information like request by date. The line chart that shows the number of requests for all API in your organization. Request by location. Map chart shows that the number of requests for each country or of origin. Request by application. Bar chart that shows the number of requests from each of the top 5 registered application. Request by platform. Ring chart that shows the number of requests broken down by platform. Publish. API portal. It's a portal used by the other developer to access the different API available within the organization. Portal includes the API related documentation, tutorials, use case, and examples. This is helpful. This is quite helpful to understand API usage. API portal can be public available on the internet or private accessible within organization. Anypoint Exchange. It is available in Anypoint platform, which can be used for API discovery. Within organization, different development teams can access API Exchange for getting required APIs. Once APIs are developed in organization, it's published on API Exchange as assets so that other teams can utilize APIs as per their needs. This promotes API reusability within the organization. For example, product management related to APIs can be reused by different development teams with the organization. API lifecycle will not stop here and again go into next iteration based on the feedback. For example, existing product management APIs are not capable enough to handle customized products. So based on how new requirements on a new set of API version is created, which will follow its own lifecycle. Here you can see a deploy. Here you can see the application runtime manager and operate, and it's interact with the API manager. Operate is connected to publish and operate also interacts with the Anypoint Analytics. Operate is connected to publish. Publish interacts with the API portals and Anypoint Exchange, and then next stage is feedback. Feedback interacts with Anypoint Exchange. Then it's connected to design. Design it interacts with API designer, and design is connected to prototype, which interacts with flow designer and mocking service. Prototype interacts with the is connected to validate. It interacts with the API console, and then here you can see the develop, it's connected to Anypoint Studio, and develop is connected develop interacts with Anypoint Studio, and develop is connected to test interacts with Immunit, and test is connected to developed. Here you can see 3 API lifecycle stages. The core of API management is the need to serve the full lifecycle of API and enable the associated ecosystem. An API first approach emphasizes the importance of the entire lifecycle by strategically treating APIs as products and managing them as such. The outcome of this approach is well designed, managed, and secured API to serve developer building new experiences. Here are the 3 distinct stages of this product-centric lifecycle: design, implementation, and management. Design. The first step in API lifecycle is design. When the API is created, designing an API starts with an outside-in perspective, beginning with an interface or contract of API. API developers create a user interface of API first, determining how API look like and behave. This is also known as API contract. This approach is typically referred as an design first approach, and should follow the deliberate API design lifecycle to optimize the first best experience. This step must be done in a human readable fashion to specify the contract in a way that developers can easily digest. Design. Identify the process and business requirement, create logical metadata, logical data model, translate into logical service and API groupings. Then is simulate, model API resources, model API operations or methods, model request or response payload or codes. Feedback, mock up the API, publish interactive console, create notebook use cases, receive developer feedbacks, and validate. Modify API design as appropriate based on the developer feedback. Continue to validate. Any well-designed API will have repeatability across all the APIs. This can be easily encapsulated into best practice patterns, both at the structural level of the API, nouns, resources, as well as at the method levels, verbs. So an API developer go about the design process. It is important that they can discover and share repeatable patterns. API implementation is critical phase of enabling next generation enterprise. Enabling the connectivity of hundreds or thousands of API to a backend as well as to each other is key. This must be done in the systematic manner as opposed to point-to-point code. The 2 steps that go into implementation stage are building and testing. A systematic approach to building ensures that the API developer has the following architectural patterns easily available to them: orchestration, transformation, routing, data mapping, connectivity across platforms. Once the API is built, it will go through rounds of API testing to ensure that it is functioning as expected. If the test is completed with no problems, it can move on to next lifecycle stage. But most often the API will go through several rounds of testing and adjusting before moving into the deployment. Test automation tools are critical here, as this integrates into the DevOps process of continuous delivery and deployment. Management. It is critical to ensure your application building blocks are followed best practices in security and architectural governance by applying policies to them at runtime. Monitoring all traffic via an API manager is equally critical, because it is just one weak link to bring up ship down. With this lifecycle stage are following steps: secure, deploy, monitor, troubleshoot, and manage. Additionally, these APIs need to be discoverable to be reused for other purposes. The ability to appropriately publish them so the consuming developer can find, research, and understand them easily could make or break your entire program. Here you can see design is connected to simulate, and then simulate is connected to feedback, and feedback is connected to validate, and it's produce a API spec. Sorry, connected to this API spec, and it is connect and this is the design stage, and then the implement design is simulate, feedback, and validate in design stage, and then you can see the build, and build is connected to test, and build and test are in implementation, and and test is producing service with APIs, and SQL is connected to deploy is connected to monitor is connected to troubleshoot, and troubleshoot connected to manage, and you can see here the service with API, secure, deploy, monitor, and troubleshoot, and manage are in management. Here you can see who does what across the API lifecycle. Depending on the maturity of your organization, there may be one person handling all these responsibilities, or three or there may be multiple people handling certain areas. Each stage in the API lifecycle provides a specific value, which ensures application building blocks decide business outcomes. API manager could oversee the API across the full lifecycle in a small organization, while in more robust organization, an API analyst and admin would cover design. DevOps and integration developer and application network architect would handle implementation, and an API admin could cover management portion. Here you can see design is connected to implementation, is connected to management. Design you can see API manager, API analyst, and admin. Here the implementation again API manager, integration dev, application network architect, and ops. In management, API manager and API admin here. Here you can see DevOps and API lifecycle capabilities on Anypoint platform. MuleSoft Anypoint platform provides a unified suite of design, management, and runtime capabilities to make it easy for organizations to address the full API lifecycle. MuleSoft Anypoint platform's component guide developers from design to implementation to production and beyond, enabling discovery and self-service. Each of the steps mentioned above has a certain aspects that can be automated. Most developers are familiar with the build stage. Work done in Anypoint Studio can easily plugged into a continuous integration platform. Leveraging some of the technologies that are mentioned, and GIT Hub for GitHub for version control, Maven for dependencies management and build automation, JUnit and MUnit for test automation, and Jira and ServiceNow, Jira or ServiceNow for issue and service management. Here you can see design is connected to simulate, is connected to feedback, and then feedback is connected to validate, and is connected to API spec, and here build is connected to test or deploy, and is connected to a service with API. Here you can see Maven, GitHub, JUnit, MUnit, or MUnit, and Anypoint CLI. Here and this lifecycle can engage API designer, mock service, API console, API notebook, studio, MUnit, API portal, and exchange. When the code is ready to be sent, MuleSoft customers often use Jenkins, Puppet, or Chef, or HV ALM for both deployment automation and the orchestration of release process across the different across a number of different environment. Dev, test, stage, and production. Docker is quickly gaining popularity among customers since it reduces the complexities of continuous deployment, and the Mule runtime can be shipped in a Docker container. And through the management agent, Anypoint Platform API and Anypoint Platform CLI customers can further automate process using configuration automation and management tool such as Puppet, Chef, Ansible, and Salt instead of Anypoint Platform user interface. Here you can see the deployment, and here you can see the operations. Here you can see the build and under that application build block and studio and its commit to CI/CD. Here you can see GitHub is connected to interacts with the JUnit. It interacts with the Jenkins and interacts with the Maven, and Maven interacts with the GitHub and ship to here the image with Docker. Here the Docker here, and the here you can see the management agent here, and here the runtime platform, and here you can see the development test. Develop interact with the test, and test interact with the stage, and stage interacts with the production. And the here you can see under under deployment and operation, you can see the runtime platform, due, test, stage, and production in production are in runtime platform, and here the deploy, manage, and scale and third-party tools are also in operations. Here runtime manager, API manager, and exchange with the Docker are in Anypoint Platform, and here the Splunk, Kubernetes, Zabbix, Logstash, Kibana are in third-party tools. Here you can see full API lifecycle connectivity microservice. Here you can see design API is connected to design, and API interacts with the design, and design API is connected to simulate interacts with the simulate, and simulate is connected to solo seat feedback, and here solo seat feedback interacts with the feedback, and here the solo seat feedback is connected to validate or not. Validate or not interacts with the document, and validate or not is connected to publish, and again design API, and here the public interacts with interacts with the publish, and publish is connected to implement. Implement interacts with the implement, and implement is connected to test and deploy. Test and deploy interacts with the automate, which includes MUnit, Maven, Jenkins, GitHub, Gradle, Puppet. Test and deploy is connected to secure, and secure interacts with the apply policies, and secure is connected to manage interacts with the operate, and manage is connected to monitor interacts with the analyze. Here you can see anatomy of Mule microservice. Here you can see the API contract here. It's a RAML specification. It includes trails, resource types, security schemes, reusable properties. Here you can see the logic, business logic flows, routing and enrichment, transformation, aggregation, parallel execution, and splitting, etc. And here you can see connectivity, protocol implementation, connections, resources management, and pooling. Here logic and connectivity are with API contract, and API contract is on top of Mule runtime and interacts with Mule runtime. And RML specification, business logic flows, and connectivities interacts with the Mule deployable archive.zip. And here you can see business logic, integration logic, and connectivity are in connectivity microservices. Here you can see Mule microservice on private PaaS. Here the logic and connectivity are in with API contract. Here an API contracts is on top of Mule runtime and interacts with Mule runtime. Mule runtime interacts with Java virtual machine. Java virtual machine interacts with container. Container interacts with OS, and OS interacts with VM. Here the Mule runtime, Java virtual machine, container, OS, and VM are in PaaS. Here you can see Mule microservices on Mule PaaS Cloud Hub. Here you can see API contract, here logic and connectivity with API contract, and API contract interacts with the Mule runtime. Mule runtime interacts with the Cloud Hub. Here you can see Mule SDLC overview. In the deployment, you can see the cycle stage is connected to developer. Developer is connected to Anypoint Studio. Anypoint Studio is connected to deployment and itself. And Anypoint Studio is connected to GitHub, Maven, plus Gradle, and these are connected to Jenkins. Jenkins, then here the munit, run test, run unit test plus run mock test, and it is connected to Artifactory. And Jenkins is connected to Puppet Hub tabs. Here the run build test, run build process plus run test, and it is connected to staging Mule app, and then it's connected to production Mule app. Here the developer, Anypoint Studio, the development, GitHub, Maven, Gradle, create and run test are in development. Here the create unit test plus create mock test plus functional test are in create and run test. Here the Jenkins, munit, and Artifactory in under test, and Puppet tabs and staging are in staging, and the production are in production. And here the and deployment interacts with the test, and test interacts with the staging, and staging interacts with the production. Here you can see development and operations. Here the build, the studio is under build, and build is connected to commit to CI/CD, and here the GitHub, JUnit, GitHub interacts with the JUnit, JUnit interacts with the Jenkins, Jenkins interacts with the Maven, Maven interacts with the GitHub, and these interacts all together, and it's then the ship these ships Docker in image, and image in Docker, and here the build, CI/CD, and runtime platform under deployment. Here the management agent you can see here, and do interacts with the test interacts with this, production. Here the do interacts with test, and test interacts with the stage, test interacts with the production, and here the runtime platform and deploy, manage, and scale are in operations. Here the Anypoint platform on premises, and third-party tools are in deploy, manage, and scale. Here the runtime manager, API manage, and exchange are in Anypoint platform on premises, and the Docker. Here the Splunk, Kubernetes, Zabbix, Elasticsearch, Logstash, Kibana, and Kibana, for example, and in third-party tools. Here the in the development and operations, here the runtime platform and build and CI/CD are under development. In the studio is in the build, and studio is connected to CI/CD via commit, and GitHub, JUnit, Jenkins, and Maven interacts, and it's published CF in Pivotal CF. In the here you can see CloudFront, Elasticsearch, and here the Java nodes and etc. Under that, in the here the Anypoint platform on premises, and third-party tools are under deploy, manage, and scale. Runtime platform and deploy, management, and scale line operations. Here the runtime manager, API manager, and exchange are in any point platform on premises. The Splunk, Kubernetes, Zabbix, Elasticsearch, Logstash, and Kibana are in third-party tools. Here you can see an anatomy of an application building blocks. An application network is composed of application building blocks. These have multiple elements, and it's critical to separate the concerns between each. API and the API interface, that API implementation and API management aspects, all their own specific unique life cycles to follow. This building block should itself treated as a product, since this characteristic is common to what good product should have. Therefore, it makes sense to treat building blocks from a product-centric approach. Here you can see the product is there, and one is purposefully produced API is connected to aesthetics and to the powerful runtime core with ubiquitous connectivity, and it's connected to performance and reliability, and here the automatic and enforced security and governance is connected to serviceability. Here you can see outside in and done right. API developers must design their the user interface of the API first. It is known as the API contract. In this approach, this approach is typically known as design first approach. And it should follow the deliberate API design lifecycle in order to optimize for the best API experience. As a result, it is important to be able to do this in a human readable fashion, to specify contract in a way that human can easily digest. Here the design, identify process and business requirement, create logical data model, translate into logical service, so API groupings, and is connected to simulate. Model API resources, model API operations and method, model request and response payloads or codes, and it is connected to feedback. Mock up the API, publish interactive console, create notebook use cases, receive developer feedback, and feedback is connected to validate. Modify the API design as appropriate based on the developer feedback, continue to validate, and it's connected to API spec. Here you can see connect systematically not in ad hoc fashion. API implementation is critical phase in enabling next generation enterprise, enabling for dozens, potentially even hundreds or thousands API to be connected down to the backend and connected to each other will be key. This must be done in systematic manner as opposed to the point-to-point code. Here you can see mobile and other apps are connected to orders, app, and customers, and versus the mobile and connected to in a systematic manner. Here the orders SAP, and here this connected to customers. Here you can see embrace DevOps. Embracing modern DevOps-centric process and tooling is critical to reducing mean time to production, and this should be applied to your application building blocks as well. Once the application building blocks has been assembled and tested and deployed, should be as easily as the click of a button. The use of a hybrid integration platform is lightweight, easy to install, and suitable for CI/CD workflows is the key. The ability to seamless support for dependency management, testing, version control, and automated deployment tooling should be an assumption. Here you can see Maven, JUnit. Here you can see the continuous delivery here, and here you can see the Maven, JUnit, GitHub, Jenkins, and this is in the continuous delivery in production here. Here you can see govern and secure all APIs. It is critical to ensure your application building blocks are following the best practices in security and architectural governance by applying policies to them at runtime. Monitoring all traffic is equally critical because it just takes one weak link to bring the ship down. Here you can see the policy configuration, and it's there are connectivities there, and here the monitoring and analytics are there are connectivities here, and you can see here see the in the orders and SAP are here, and the customers are here. This is more systematic. Here you can see, just like any product, application building blocks change. Building blocks will change, and it's when and not if, so be ready for it, and which requires a carefully planned set of policies for the procedures and right platform to seamlessly migrate clients across new versions of API. Getting this migration wrong will affect your customers. That's not a risk worth taking. It will takes a village to have an application network. Here the client A interacts with version 1. Here version 1 is connected to deprecation warning timeline, and here the client A is connected to client B. Here the client A consume version 1, and client A is connected to client B. Here the client B interacts with version 2 and all, and it's produce all new clients and existing clients after deprecation of version 1. And here the client B is connected to client A and is consume version 2. Here you can see a connector project structure, and this is in Eclipse or Anypoint Studio. Your connector project directory looks similar to here. Here the barn connector. Under barn connector, you can see source main Java, source main resources, source test resources, source test Java, source main app, flows, target generated Mule, target and generated sources Mule, JRE system library, Java SC7, Mac OS X default, demo, doc, icons, source src, target, changelog.md, license header.txt, license.md, pom.xml, readme.md. Here you can see a folder structure in Anypoint Studio here. In a sample project. Here the right click on the domain project, Mule domain for example, and then export, then Mule, then Anypoint Studio project to Mule deployment archive, includes studio metadata. Choose a path and click finished. Note, repeat the same steps for Mule applications, for example sample Mule app. Then both executable jars are created, and open the file explorer and navigate to the folder /path2 / Mule enterprise standalone 4.1.2 for example. Here the folder structure must look similar to this, and you can see the folders .mule, apps, bin, config, domain, lib, logs, policies, repository, server, plugin, services, temp, tools, and the files license, migration, and readme.